will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hello team, in this lesson we are going to learn internationalization and localization in Java. We are going to start this lesson from understanding of the challenge that we want to address with the help of internationalization and localization. Once we understand the challenge, we will proceed with learning of these two concepts. I will explain you the difference between these two terms. Also today we will have a lot of practical activities. We will learn how to work with local object on real examples. Using local object, we will format numbers, currencies, and dates. And at the end of the lesson, we will learn how to work with resource bundles. I will show you how to work with properties-based and Java-based resource bundles on real examples. This is going to be a very productive lesson. Let's get it started. Let's understand first the problem that we try to address here and why we need internationalization and localization, and why we should care about it. Nowadays, in most cases, developers work on the applications that are supposed to be scaled across multiple regions at least, and very often apps supposed to be available in multiple countries. This is widespread, non-functional requirement that software engineers should to implement. Having application available across different countries means that we need to handle various regional specific data. Considering our application supposed to serve people from different parts of the world, we should take into account cultural and political specifics during the data representation. For example, numbers, dates, currencies, text. Now let's understand what internationalization is. The first thing that I'd like to explain is abbreviation that is used instead of long word internationalization. As you see, usually it is named as I, 18 and N. Number 18 here is due to 18 letters between I and N. That's why often it is faster to use this abbreviation instead of writing the whole word. So, what is internationalization? First of all, this is a process. Process of what? Process of making software available to be used for different regions by removing any handwriting and building application architecture in the way it potentially can support multiple different regions. Internationalization ensures your software is localizable and is typically done by software developers and engineers. Even if your original software architecture and marketing campaign is oriented on the launch on the one market only, let's say some English-speaking market, internationalization allows you to ensure it could support other languages and cultures if you were to expand to additional markets in the future. So, instead of hard-coding individual language inside application, internationalization helps you to prepare your codebase for using different configurations and translations based on the local. During the internationalization, we also replace code with some placeholders that will be used to retrieve localized version of the content from the provided configuration files. To help you understand how this works, let's imagine an example. Together with all students, we implement our online shop during learning our Java course. And on the welcome screen, there is an option to log in. In the English version of the app, we should use login text here. But in Russian version of the app, we have to use войти text. Inside our code, we need to identify place where a placeholder of the button text will be used. So, during the coding of the app, we may use login text button placeholder. Later, inside our localized configuration file, we will use the same key to define content for that key for different versions. Similar approach inside the code will be applied to date-time formats, currency, and other components. Instead of coding the software for each specific language, the internationalization process replaces that code with keys. This not only makes code base easier for localization, but it also neutralizes the code and adapts it for various languages you may introduce in the future. Now, it's time for us to learn what localization is. Localization is the process of adapting your internationalized software to meet the language, cultural, and other requirements of a specific target market, otherwise known as local, by adding resources and translating content. We also often use abbreviation for localization like we do for internationalization. We use L, TAN, and N, because between L and N there are 10 characters. In simple words, localization is performed by translation of content on user-facing elements and components of your application. But localization goes beyond translations and text representations. When we talk about localization, we mean adaptation of all visual content to specific locale. That includes, but not limited to, numbers, currencies, dates, images, etc. Let's review a few examples that will be different for different regions to help you understand what localization is. For example, numbers. If you are a student of my Java course, then you already know that during the course we implement online shop. In online shop we display numbers, prices, and for different regions there is different pattern established to separate fractional part. For instance, in the United States you would separate thousands with comma and cents with dot, but in Russia you would separate thousands with space and fractional part of the price with comma. But in Germany we'll use point for thousands separation and comma to separate fractional part. If we talk about money representation, currency symbols supposed to be different too. The same money amount may be represented with US dollar sign, Russian ruble, euro, Indian rupee, or British pound. An important fact to know is that even if countries have the same currency and currency symbol, like France and Italy, the position of their currency symbol could be different. Date and time representation also varies and have different formats. In my Java course we learned with you date and time, and you know how painful sometimes may be managing different time zones. But also there are different region specifics in different time zones to represent that time. To optimize the process of localization, engineers can create different resource files, so-called resource bundles, for each locale. These resource bundles will store all the text outside of the code of the product. This allows us to build our application in the way when we use these resource bundles and apply different ones based on the concrete locale. In this way, we don't make any harm to our code and not constantly changing it. From the technical side, the great importance in the process of localization belongs to local type. Before jumping to practical example where we'll review examples that use in local, let's review a little bit of theory about this class. The Java local class, Java util local, is used to represent a geographical, political, or cultural region to localize a given text, number, or date. A local object may thus contain a country, language, and also a variant of language, for instance, a dialect spoken in a certain region of a country, or spoken in a different country than the country from which the language originates. The concept of Java local is implemented by the Java util local class. To define the local for the application, you would use the local object, which is only an identifier. The local class can't do any internationalization or localization by itself. Real localization is done by local sensitive classes. Objects that you create from local sensitive classes customize themselves as to how to format and represent data to the user. These classes use the local object to understand which local is being used in the application. So, we'll create local, and we will set local in our application. To make other local sensitive objects behave differently when needed, and also to use proper resource bundles. A local instance contains the following subparts. Language. This can be an ISO 639 Alpha 2 or Alpha 3 code or registered language subtag. In case a language has both a 2 and 3 character language code, use the 2 character code. A full list of language codes can be found in the IANA language subtag registry. What is IANA? IANA stands for the Internet Assigned Numbers Authority. It is a standards organization that oversees global IP address allocation, autonomous system number allocation, root zone management in the domain name system, that is DNS, media types, and other Internet Protocol related symbols and Internet numbers. Language codes are case insensitive, but the local class always uses lowercase versions of the language codes. Script must be a valid ISO 15924 Alpha 4 code. The script code represents the written form of the language. Some languages can be written using different scripts, different alphabets. Country, region. The country code is 2-character code following the ISO 3166 standard or an UNM49 numeric area code. A full list of country and region codes can be found in the IANA language subtag registry. Variant. It's a case-sensitive value or set of values specifying a variation of a local. The variant part describes a variant, dialect of a language following the BCP47 standard. Extensions. The extension part signals extensions to the local in addition to the language and region. For instance, what calendar to use when displaying dates: Gregorian, Arab, Japanese, etc. Now let's make sure that the difference between internationalization and localization is clear for us. Despite the fact both of these terms are used to achieve the same goal, there is subtle difference between these two terms. So, what is the difference? Internationalization is the process of designing and developing your software or mobile application product, so it can be adapted and localized to different cultures, regions, and languages. Localization is the adaptation of your software or mobile application product to meet the language, culture, and other requirements of each local. Do you feel the difference already? Internationalization helps you build your software or mobile application product with future markets and languages in mind. It is the process of neutralizing the code, content, and design so that down the road it will be easier to adapt your product to additional cultures without having to completely re-engineer it. Localization typically follows internationalization, but beyond adapting your software to a specific region, the localization process can also highlight any words, phrases, or user interface elements that haven't correctly been internationalized. Hope that now the difference between these two terms is clear. Now, let's have a demo of local and examples of formatting considering internationalization and formatting rules. Let's start our demo from local class. Because we are going to use local in different scenarios during the lesson, that's why I believe it will be logical to start from this class review first. Let's learn how we can create local objects. First of all, I want to mention that there are several constants in the local class. You can refer to any of these constants instead of creating a new local object from scratch. So using constants will be the first way to obtain the reference to the local object. The second way to instantiate local object is via constructor. I have separate class here that is called local demo. I put all examples related to local in that class. You can create local with the help of the new keyword and calling the constructor. Constructor is overloaded and you may use any variation of constructor you like the most. For example, there are constructors where you can pass on the language code, or you can pass language code and country code, or you can pass language, country, and variant codes. And here in demo file, I create 4 different locales. The first one is for Hindi language and India country. The second one is for English language and India country, because sometimes we may want to use English language for India country. Based on this local object, we'll select resource bundle that fits the most our local language, country, and variant. The similar case is with another local. People in Ukraine speak some different languages. You can set Russian language for Ukraine country and prepare resource bundles for this version of local. And you can also create local for Ukrainian language for Ukraine country. After having the local object, you can pass it as method argument to the local sensitive objects. Like we discussed during slides overview, the language parameter should be a 2 or 3 letter ISO language code from ISO 639 standard. You can also use a language subtag of up to 8 characters. The country should be a 2-character ISO country code from ISO 3166 standard. Alternatively, a UNM 49-character area code can be used. The variant should be any valid BCP47 variant of a language. The third way of creating local object is using of local builder. You just instantiate object of nested class local builder, and after that use setters methods to set the properties. Once configuration is done, you can call build method that will return the reference to the local object. With the local builder, it is easy to set script and extension if you wish. And the fourth option to create local object is static method for language tag of local class. You can call it and pass language tags that may consist from language and country codes. There are different ways how you can check all available locales. Just in case you wanna check whether your local is supported, or you forgot the code of language or country and you don't wanna check it in the internet, you can check it in another way directly in your program. You can call getAvailableLocals either on local class or a number format or on the date format class. You will receive an array of all available and supported locales. Inside your app, you can easily identify default local. Default local is identified by the environment where JVM is running. For example, I have Russian local currently set in my Windows operating system, and I can easily identify this by calling getDefaultLocal method. And in case I wanna set new default local, I can use setDefault method. For example, during the mobile development in Android system, when user wants to change language inside the application, what you do basically is changing the default local to the one selected by user. I believe now you know enough about local. Let's learn how we can use it by reviewing simple localization examples. Let's open localization demo file. Let me run this example and walk you through the console output. Imagine that we have some random double value. And let's now represent this double value considering local specifics of different regions. I create number format object by calling getInstance method and pass US local. After that, I call format method of number format object and pass our random double value there. And I do the same operation with Russian and German local. In console, you can see similar examples that we discussed during the slideshow. You can see how thousands and fractional parts are separated in different local. Sometimes it is just a space, sometimes it is comma, and sometimes it is a point. Is it clear? Now, on number format class, I call static method getCurrencyInstance and pass different local and call format method. You can see that currency sign is added during the formatting. You can see that dollar, euro, ruble, rupee, pound signs are added to our random double value depending on the local that we used during the formatting. And you can see that automatically currency sign is positioned either before or after numeric value, based on the specifics of a region. Also be aware that you might see question marks instead of currency signs. In case you can't see currency signs, that means encoding in your IDE is set not correctly. To change encoding, click Window, Preferences. Type encoding here and find here Workspace section. In the text file encoding, select UTF-8. That's it. After applying this configuration, you will be able to see currency signs. By the way, guys, you can find the reference to all code examples in attachments to the lesson. Also, I encourage you to run these examples on your computer and play around with different methods and locales. This will help you to understand the topic better. The last example here is example of date formatting. I create zoomed datetime object, and after that, with the help of datetime formatter, I format date with different locales. If you are a student of my Java course, please refer to the lesson about date and time, where we reviewed different ways to work with date and time, including classes from Java Time package. There are different classes that work with local to format date. I just showed one example, but I am sure that you understood how it works. And the last but not the least for this lesson, resource bundles. Resource bundles basically group localized resources. We are going to review different forms of resource bundles. Let's start from the properties-based resource bundles. First of all, I made resource folder my source folder. How I did that? You can mouse right-click on the resource folder, build path, and select Use as a source folder. I already have resources folder marked as source folder. That's why I showed you the example with other folder. But I believe this is clear. Why this is needed? Because resource bundles should be located in the class path. But it is not a good idea to put properties files in the same folder with the source code. That's why it is a rule of thumb to have some folders dedicated for storing resources. Let's review what resource bundles we have. We have MyLabels resource bundle here and different versions of it. We have default version of MyLabels. Also we have bundle for NUS and for RU. These files have properties extension. Let's open them one by one. In the default resource bundle, you can see set of key value pairs. These keys are used inside the code of application, and the values are substituted instead of placeholders during the program execution, depending on the local set inside the app. In the default properties, you can see that welcome message is sound like "Welcome, sir," and the login button text is login. We can write comments in property files like this, starting with number sign or exclamation mark. So, both of these options considered to be a valid comment syntax. Also, we can write key value pairs in different ways. We can either use equal sign or colon, or like in NUS version, I can simply use space between key and value. In the NUS version, welcome message is just welcome, and login button text is sign in. In the RURU version, we have welcome message, but we don't have login text button. What does this mean? This means that login button text will be taken from the default resource bundle. And what these Unicode characters mean? The thing is that resource bundles are uploaded into JVM via byte streams in Java version 8 and below. If you don't remember what byte streams are, please refer to the lessons about input-output streams. In short, byte streams read data per byte, and character streams read data per 2 bytes. That means that it is impossible to describe all Unicode characters in 1 byte. That's why, as a workaround, properties files support automatic conversion of characters not supported by ASCII encoding to Unicode numbers. For example, all Russian letters here are written with Unicode numbers, and this is done automatically. So in case I would write something with Russian letters, my IDE will convert it in Unicode numbers. Fortunately, this inconvenience exists no longer in Java 9 and upper versions. JVM reads property files in UTF-8 encoding, and there is no problem in using non-Latin characters. But still, considering the fact that even after release of Java version 16, Java 8 is the most popular Java version, I would recommend you to not ignore this limitation. Okay, now we have resource bundles and key-value pairs described here. Let's take a look at how this is implemented on the code level. I open resource bundle demo file. I create object of resource bundle. How I can do that? I call getBundle method of resource bundle class and pass name of my bundle. Pay attention that each bundle has base name. All bundles follow strict naming convention. They have base name and different versions. You can specify language, country, and variant, and separate all elements of the resource bundle name via underscores. When you create object of resource bundle in Java, you use only base name, and you let Java decide which resource bundle to use based on the local set. Let's make sure that the default local is ru. The next line of code in our example is extracting value from resource bundle by its key. Let's say welcome in Russian. I will run the program to explore console output together with you. I use getString method on my resource bundle object and pass key. This is exactly what you should do during working on internationalization in your app. This approach will allow you to run your app on the market by simply adding new resource bundle, and that's it. But what will happen if I would try to extract value for login button text that is absent in ru resource bundle? Value from default resource bundle will be taken. Let me show you this. And as you can see in console, even despite we have Russian local set, we get text in English, because the value for this key is just absent in Russian version of resource bundle, and default version is taken. Can you understand this? And logically, after I changed local to NUS and printed values for these two keys using the same placeholders, I get values from another version of my resource bundle. Here you can also see examples with default local. I believe you already understood how properties-based resource bundles work. Pay attention that I upload resource bundle after I changing local. But we can also declare Java-based resource bundles. Why we need them? The Java-based resource bundles have the only one biggest advantage. You can get localized versions of objects. Because with the properties files, you can get only string values. But with Java-based bundles, you can get localized object associated with the key. But to be honest, not so often you need localized version of objects. More often you need translations for your UI elements but not localized objects. Nevertheless, let me show you how you can create Java-based resource bundles, just in case. You have to create class with the name of your resource bundle, and language and country code if needed. This is exactly the case when you can violate Java naming convention and use underscores in class names, because it will not work otherwise in case you will not use underscores. This class should extend listResourceBundle abstract class, and you should override getContents method that should return multidimensional array, matrix. Each array in this multidimensional array is a key-value pair. That's it. Let's get back to our resource bundle demo. I change local, and pay attention. After changing local, I get resource bundle each time in order resource bundle would be updated. And now I can extract object by calling getObject method and passing key. After that, we can cast objects manually if we need. Also, in case I forgot what keys are available, I can extract key set of all keys. You can explore API of resource bundle by your own. Probably you would find other methods that are useful for you. But I really believe I highlighted the most important methods that most likely you are going to use in practice. And in case you have any questions, you can ask them in comments to the video, and I will be happy to answer. One more important thing you need to know is priority for selecting of resource bundles. In the beginning, the application will look for the files in the class path suitable for the local you ask for. It starts with the most specific name, that is, one containing a country and language. Then it goes to more general. If there is no match, it falls back to the default local. Let's imagine that we have rule local set in our app. The priority will be the following one: my labels rule, my labels rule, and my labels, that is our default one. We should keep in mind that each name represents both Java and properties files, but the priority will go with Java bundles. When there is no suitable file, a missing resource exception is thrown. That's all what I wanted to share with you today. Let's recap what we have learned today. Today we learned what internationalization and what localization is. Also, you know the difference between these two terms. On examples, we learned how to work with local class. You saw how to format numbers, currencies, and dates. And at the end of the lesson, we learned how to work with properties-based and Java-based resource bundles. Thanks a lot, team, for your attention. Have a great day and see you in the next lesson. Hello dear students, today we start super important topic. We start learning of databases and structured query language to be able to interact with data in databases. We have a lot of things to learn, but today we are going to hold an overview of databases in order you could understand some basics before we move on with more complex topics. Today in our lesson we are going to learn a lot of things. Most of them important for engineers and software architects, because all architects should be aware about different types of databases, in which case what kind of database is applicable better, and what are advantages and disadvantages of different databases. We are going to start from the simple topics, like what database is, and gradually we'll get to more advanced topics and concepts. We are going to learn different types of databases. I will explain you what relational databases are and when they are applicable, and also we'll discuss different types of non-relational databases. Separately we'll discuss centralized and distributed databases. As we progress with the lesson, we'll learn advantages and disadvantages of different types of databases. We have a lot of things to learn. Let's start our lesson. Let's understand first of all, why do we need databases? and what their purposes. Imagine that you have application, no matter whether it's web application, desktop or mobile. You can run your application, you can stop it, and when your application up and running again, you need to restore its state. For example, information about registered users, information about their purchases, information about the goods that you sell. It depends on what kind of application you have, but usually in all applications there are some data that need to be stored persistently, and you need to have some persistent storage where you can access this data. Does it make sense? So, usually your application is a combination of some code that knows how to process data and some persistent storage of data. Because storing a lot of data in the application memory is not good practice. Let's try to think why. Imagine that all information is stored in the app memory. In this case, you can lose all program-related data once application is stopped. It is not secure. You can't add additional level of security to the data stored in the app. A regular developer may easily read some secured passwords or other sensitive information. Besides that, we can't take advantage of replication of DB to secure data from losing it because of any accident. Usually memory for the process for our application is limited, and it is significantly less than we have physical memory on the hard drive, because to run applications we use RAM memory. In case you want to learn more about memory management for Java applications, please check my The Most Complete Java course where I have separate lesson about memory management. One more point against this. This is against layered architecture pattern. In a separate lesson we are going to learn in details what layered architecture is, but I will briefly explain you the context. Layered architecture implements separation of concerns. Having separate persistence layer, database layer, and business logic layer gives you tons of advantages. The most obvious are: you can develop and improve each layer independently, you can isolate impact of one layer on another one, you can work in parallel on different layers with your team. And these are just some of them. Having all app data stored in the app, it is absolutely not the best way to address requirements of data storage in the app. So, that's why you should never rely on storing data inside the app. But what you should do instead? It is recommended to use separate applications designed and created specifically for storing data and navigation inside this data. Among advantages of databases, it is worth to mention the next ones. Manages large amounts of data. A database stores and manages a large amount of data that is updated literally on daily basis. This would not be possible using any other tool. Imagine Excel spreadsheet that contains a lot of tabs that are logically connected to each other, but contains either duplicated data or just not mapped data that is hard to update at once and avoid logical mistakes when operating on the data. Separate program layer that can be developed and improved separately. In case there is a question of performance improvements, you don't need to touch the code of your app. You can apply optimizations directly on the database layer. If for some reasons you decided to change database, you don't need to update your application code. You can substitute database independently with saving the same interface of interaction with database. Security. Store database on the separate servers with restricted access. Only users who has login and password to access this database with granted rights can access DB. Create users and grant specific permissions only. For example, you may have different users who may read data from separate tables who can't adjust any row of data. There are also another set of configurations that we are going to learn in this course. Having data stored separately and even on a separate server, we can avoid data corruption in case our app server is hacked or down. Data integrity and consistency. Avoid of data anomalies with the help of special restrictions on the database layer. Data integrity in databases makes sure that the data is accurate and consistent in database. API. Providers of databases ensures that there is an API to interact with their databases from program code. and the amount of operations that is provided to research, aggregate, and update data is amazing. Can you imagine querying your Microsoft Excel file to get aggregated amount of month's salary of all employees who works more than 5 years in company, including employees who already left company in the past, and employees from its subsidiaries who successfully delivered 3 or more projects? And also, return each column not just a string value, but in different types. For example, return decimal numbers as int, date values as value of date type, and so on. It is hard for me to imagine performing such operations with Excel, especially in multi-threading manner with different concurrent requests, especially performing requests from different points in the world, accessing the nearest Excel file that is synchronized with other files across the globe. Do you feel the power of databases, or not yet? I believe you do. I believe now you understood why we need databases and why we can't substitute them with other programs or with approach where we just store all app-related data in app memory. So, knowing this, let's come up with specific definitions. I believe now, knowing goals of database and use cases, it will be easy for you to understand these definitions. Database is an organized collection of data stored and accessed electronically from a computer system. Is this definition clear for you? So the database itself is a collection of interrelated data. First of all, database is a data, and you already understand that this might be any application-related data that ensures expected behavior of your app, and in some cases contains enough information to restore state of the system when needed. Database is an organized collection. All data is organized in the specific data structures. Depending on the database type, the approach for structuring this information may be different. But in all cases, there are strictly defined rules and goal to organize different data following common pattern to similar kind of data. For example, you can store information about user in the database row with the specific attributes only, and these attributes are used for storing of all other user-related information. The same as connection of one information with another information. Imagine that each user has its own order history, and the way how connection between this data is organized is the same for all users. But very often engineers and people use two terms as synonyms. They are database and database management system. Very often when people say database, they refer to database management system. And this is one more definition for today. The database management system is the software that interacts with end users, applications, and the database itself to capture, store, retrieve, and analyze the data. We can see very important aspect of DBMS. So, all stored data may be accessed electronically from a computer system, and there is a specific software that provides us with ability to interact with stored data. We have discussed already that we can interact with databases via API. The term DBMS includes the user of the database and other application programs. It provides an interface between the data and the software application. The DBMS software additionally encompasses the core facilities provided to administer the database. The sum total of the database, the DBMS, and the associated applications can be referred to as database system. Often the term database is also used loosely to refer to any of the DBMS, the database system, or an application associated with the database. Now we are going to review different types of databases. There are different pros and cons of each type of database. We are not going to learn each database type in details now, but I want you to be aware of about differences between them, at least on the high level, because this will help you to understand better what you want to learn in depth and what kind of database is better applicable in some specific cases. And the most common classification is based on the way how data is organized inside the database. There are the most popular database types, relational and non-relational, or in other words, NoSQL. We are going to start from the relational databases. Relational databases have been around since the 1970s. But why this type of database is called relational? That is because the way data is stored in the DB. Because all data is stored in different tables that relate to each other. Each table has rows and columns, and very often one table has reference to another tables, and other tables have reference to another tables. So, to extract data from relational databases, very often you need to query multiple tables at once. How does it look like? Let me make an example of relational database, without diving deep in specifics, but just to make you understand how it looks like. To help you understand what relational databases are, let's consider the next example. Imagine you develop a Twitter application, or the similar one, and you have all with posts. That means you already have at least two tables, users and posts, and there is connection between them. I wouldn't bother you too much with details because there are different types of connections between tables. We are going to learn them in details in a separate lesson. Right now, I want you to just understand the idea. What else do we have? Each post may have comments, so we should have comments table. Each comment is connected with a specific post and with a specific user who posted that comment. We already have three tables, and so on. Having these connections between different tables, I can query information I need. For example, get all comments ever of user, or get all comments for specific post with usernames of authors, and so on. Is that clear? To create, update, and manage relational database, we use special programs that are called relational database management systems. There is also specific syntax of querying data from tables. I am talking about SQL. This stands for Structured Query Language. It is the language that allows you to perform operations with data in database. This language allows you to create different queries, including queries to create, read, update, and delete data. Relational databases are very reliable. It is easy to support transactions with these databases. We are going to talk about transactions and such requirements to transactions as atomicity, consistency, isolation, and durability in a separate lesson. I will elaborate more about transactions in a separate lesson, but now I just want you to understand this term at least on the high level, because I am going to use it during the lesson. To understand this concept, you can keep example of money transaction in your head. I transfer money amount from one account to another account. Specific amount of money was removed from my account to proceed with transaction. But after that, it appears that another account is not valid anymore. This is just an example. Probably another credit card has been expired. In perfect world, I would check this before even start transaction. But still, this example is easy to understand. So the failure of the second part of the transaction doesn't mean that I lost my money. All transaction is rolled back to its original state as it was before the transaction, and I receive my money back. Or you can imagine another example when you requested money in ATM and some error happened when ATM tried to cash out your money. Do you understand now at least the concept of transaction? So, relational databases were developed to support transactions, to keep all data in all tables in consistent state, ensuring data integrity. This is one of the advantages of relational databases. Another important thing to mention here is that this type of relational databases is the most popular nowadays across all over the world, because of its relative simplicity, good performance with not big amount of data, design principles of data structuring, and data organization, which make data easy to research and operate on. These are just a few reasons of popularity of such databases. So, most likely, during your life you are going to work with relational databases. Also, if you work with mobile development because of objective reasons, computing power, it is hard to deploy other type of databases on mobile devices. So, Most likely, if you are working with mobile app development, you will use also SQLite, that is relational database for mobile phones. Other examples of relational databases that are popular nowadays you can find on the slide. They are MySQL, MariaDB, PostgreSQL, Microsoft SQL Server, Oracle DB, IBM DB2, SQLite, H2DB. And these are just some of them. As you may already understand, we are going to learn relational databases in this course in depth. The core principles that we are going to learn for relational database design and modeling, SQL language, and operators, all of this will be applied to each relational database. Also, there are a subset of relational databases that are located in cloud. A cloud database refers to any database that's designed to run in the cloud. Like other cloud-based applications, cloud databases offer flexibility and scalability along with high availability. Cloud databases are also often low maintenance, since many are offered via software as a service model, or, like it's sometimes referred, database as a service. But basically, the same principles applied to all relational databases may be applied to these databases. Some of them are Microsoft Azure SQL Database, Amazon Relational Database Service, Oracle Autonomous Database. Knowing all this, let's try to identify advantages and disadvantages of relational databases to understand when we have to use them and when shouldn't rely on them. Among advantages of relational databases worth to mention: simplicity. Yes, I would call this as advantage of relational databases that made them so popular. You have tables and relations between tables. This is logical, this is easy to understand, this is easy to support and work with. Structured data and data accuracy. In relational databases we have strict schema definition for each model, and each row in our database follows the same format, and this is great. This decreases probability of data inconsistency and decreases probability of potential errors when we will perform bulk operations on all dataset. Relational database design includes rules from set theory, normal forms for database normalization, relational algebra, and lots more. Encapsulation. We can hide changes, the way how data changing, and other details of internal database structure with the help of use. Also, we can take advantage of stored routines. Security. With the help of database management system, we can control access to specific tables or make them completely confidential. We can control user permissions and grant or revoke different types of permissions. For example, I can grant to developers user access only to read data from specific table only. Performance. Even though a relational database is pure in terms of performance, still its speed is considerably higher because of its ease and simplicity. And also, various optimizations that is included in a relational database further increases its speed. So all applications will run with appropriate speed when used in a relational database. If we want to talk about disadvantages of relational databases, I would mention the following ones. Relatively low performance with big amount of data. On the one side, using all possible features in relational databases, including indexes, may bring us to the great performance, but this is for relatively not big amount of data with relatively not so much relations. Because imagine that you have some model that contains 1 or even 200 rows. Most of the rows are references to another tables, and in those tables there are references to the third tables. Definitely, retrieving and manipulating with such data is not a simple thing in relational databases. That's why NoSQL databases work better for big data. We are going to discuss NoSQL databases in a few minutes. Complexity. I know exactly what you feel at this moment. You might be wondering, Andrei, you just told us that one of the advantages of relational databases is simplicity. How this may happen that one of the disadvantages is complexity? I will explain you this now. The main thing here is the volume of data. In case you have relatively big amount of data, and when I say big, I mean huge amount of data. In this case, you need to not forget and understand connection with hundreds or even thousands models and tables. Can you imagine that? Yes, from one side, relational databases provide us with tools that allow us easily navigate within existing data, easily identify dependencies, easily add new information to the table, clear structure, and perform bulk operations to update data because it has common structure. This is also true. But from another side, managing all dependencies and relations between different tables may become a nightmare when your application becomes bigger and bigger. This is also one of the reasons why people might opt for NoSQL databases. But remember, it always depends on the amount of data we store, operations we perform with that data, and personal understanding of complexity. Unsuitable data model for certain domains. We have to admit that with relational databases, sometimes it is hard and sometimes even impossible to describe all different kinds of data. For example, using a relational database to traverse the graph will easily become a nightmare because of the huge amount of necessary joins. Using a graph-based database, like Neo4j, will be much more appropriate. The same is valid for deeply nested domain models, hierarchies, that would require a lot of tables and joins. Document-oriented databases like MongoDB or CouchDB are the best choice for these domains. Or imagine you just need to store key-value pairs. In this case, something like Redis will have better performance rather than relational database and will be more suitable for such data structure. Is that clear? Difficult schema evolution. As we have discussed already, it is just great that we have schemas and different models with clear structure, we have tables with a specific number of columns of the specific type. This also allows us to perform bulk operations with data, apply aggregation functions, and lots more. But think about this from another side. Imagine that you need either to change existing field name or existing field type, or you need to extend existing table with other data. Would it be easy for you? Unfortunately, no. That's why I am saying that it always will be difficult to change schema once it was created, and once the data is in there. That's why you shouldn't worry about time when you're just thinking about the database structure for your project. You need to understand business requirements in order to come up with the best relational database design. So, as you can see, in most cases, disadvantages are nothing more than the other side of advantage medal in relational databases. And similar to other programming questions, there is always matter of trade-offs, an understanding of what works better for you and your project at this specific point of time. The next database type that we are going to review is non-relational databases, or, like they are often called, NoSQL database. NoSQL is a broad category that includes any database that doesn't use SQL as its primary data access language. Unlike in relational databases, data in NoSQL database doesn't have to conform to a predefined schema, so these types of databases are great for organizations seeking to store unstructured or semi-structured data. There was a time when NoSQL was a buzzword, and everyone tried to learn it and find a project with NoSQL database. While the idea that stands behind NoSQL is great and cool, it is not so popular as relational databases because of the specific domain. We'll talk about this when we'll come to advantages and disadvantages of NoSQL databases. NoSQL is a type of database that is used for storing a wide range of datasets. There are no relations and data may be stored in different ways. For example, your data may be stored in so-called documents. Imagine that we develop Twitter. We already reviewed example with relational databases and Twitter. Now you will see how example with NoSQL is different. You have wall with different posts. Each post may be treated as a document, and you store all data that is related with this particular post in one single document, instead of storing all related data in different tables. Do you already understand the advantage of such approach? Instead of querying multiple tables by doing cross-join queries, you make just one single query to a database and extract the data you need. It may be post description itself, information about post author, time of posting, number of likes, names of users who liked your post, and you don't necessarily need to store all information about users who likes your post. For example, you need to store only names to show them in the list on the request, and URL to their pages in order we can redirect user on click event. Also, you may store in the same document all related comments to this post and information about users who commented. Do you understand that? Compare the similar example with relational database. You don't have dozens of tables that you need to query to get information about the post. You just make a call to a database to get information about post and that's it. Sounds like a great idea, isn't it? But try to quantify number of duplicated data in the database. If the same user put comments under different posts and we don't have reference to the user table because we don't have tables in relations, then all this information is duplicated multiple times just in favor of the fast reading. And now imagine another thing. You can write information relatively fast and you can extract information relatively fast too. But what if you would need to update existing information? For example, the same user changed his name or anything else? Can you imagine how much time it would take? In comparison to relational database, when one of the core concepts is reducing of data duplication in the database by building connections between tables, in relational database you would just need to change username in one place. But in NoSQL database, this operation will take more time. Some examples of NoSQL databases based on documents are MongoDB, Amazon DocumentDB, Apache CouchDB. We can further divide NoSQL databases into the following types. Key value storage. It is the simplest type of database storage where it stores every single item as a key holding its value together. Key value databases are highly scalable and can handle high volumes of traffic, making them ideal for processes such as session management for web applications, user sessions for massive multiplayer online games, and online shopping carts. Some examples are Amazon DynamoDB, Redis. Graph databases. They are used for storing vast amount of data in graph-like structure. Most commonly, social networking websites use the graph database. Graph-oriented database management systems software is designed to identify and work with connections between data points. Therefore, graph databases are often used to analyze the relationships between heterogeneous data points, such as in fraud prevention, or for mining data about customers from social media. Some examples are DataStax, Enterprise Graph, Neo4j. White column databases. This type is also known as white column stores. They are schema agnostic. Data is stored in column families rather than in rows and columns. Highly scalable, white column databases can handle petabytes of data, making them ideal for supporting real-time big data applications. Some examples are Bigtable, Apache Cassandra, and Scylla. Object-oriented databases. The type of database that uses the object-based data model approach for storing data in the database system. The data is represented and stored as objects which are similar to the object used in the object-oriented programming language. Some examples are Wakanda, Object Store. Hierarchical databases. It is the type of the database that stores data in the form of parent-children relationship nodes. Originally developed by IBM in the early 1960s, hierarchical databases are commonly used to support high-performance and high availability applications. Some examples are IBM Information Management System, Windows Registry. Time series databases. A time series database is a database optimized for time-stamped or time series data. Examples of this type of data include network data, sensor data, and application performance monitoring data. All of those Internet of Things sensors that are getting attached to everything put out a contrast stream of time series data. Some examples are Druid, ExtremeDB, InfluxDB. Column-oriented databases. While a relational database stores data in rows and reads data row by row, column store is organized as a set of columns. This means that when you want to run analytics on a small number of columns, you can read those columns directly without consuming memory with the unwanted data. Columns are often of the same type and benefit from more efficient compression, making reads even faster. Columnar databases can quickly aggregate the value of a given column. For example, they might be used for adding up the total sales for the year. Use cases include analytics. While columnar databases are great for analytics, they are not always the best choice for other domains. But the way in which they write data makes it very difficult for them to be strongly consistent, as writes of all the columns require multiple write events on the disk. Relational databases don't suffer from this problem, as raw data is written continuously to disk. Some examples are Google BigQuery, Cassandra, MariaDB Column Store, Azure SQL Data Warehouse. Cloud NoSQL databases. Similar to relational databases, it is also possible to buy NoSQL database as a service. Among examples of Cloud NoSQL database, I can name Azure Cosmos DB, Google Cloud Data Store, Oracle NoSQL Database Cloud, MongoDB Atlas, and others. Now, let's talk about advantages and disadvantages of non-relational databases. Let me start from advantages first. Flexibility. There is no predefined schema, and client of NoSQL database is flexible to put any data structure needed. This gives flexibility. Also, you don't need to change schema, in case you need to add additional kind of information. High performance with big data. As we have discussed and reviewed an example, with NoSQL database, you can achieve high performance with big amount of data when you read data. And again, usually it is high performance on read-write operations. Later in this course we are going to learn index concept, and you will find out that you can increase performance by indexing data in database. So, in case you have indexes in document in NoSQL, write operations also may become time-consuming, because you need to keep your index in up-to-date state. But definitely, if you use read operations more often than update and write operations, you may take advantage of NoSQL performance. You meet people and articles in the internet that will try to assure you that NoSQL is faster than relational databases in all cases. Be specific. It depends on the relational database configuration and configuration of NoSQL database. It depends on the type of operations that we perform. And it depends on the amount of data we are operating on. And what is more important in my opinion in most cases, it is data consistency. There are different business domains where we can sacrifice with instant data consistency, but in some domains this is critical requirement. So don't be fooled and always verify facts. Scalability. It has been primarily developed to address the scalability problem characteristic of SQL. As a result, it is schema-free and built on distributed systems, which makes it easy to scale and shard. Among disadvantages, it is worth to mention next things. Eventual consistency. We have discussed already that relational databases were created to support transactions. Transactional support means that you have tools to support all data in all tables in consistent state, without anomalies. because in case one operation in the common transaction is failed, all transaction is rolled back to the original state as it was before transaction is started. NoSQL uses this principle of eventual consistency. I listed this item as disadvantage because for some domains and for some operations, this might be critical requirement to the database. Eventual consistency means that if there are no new updates for a particular data item for a certain period of time, eventually all accesses to it will return the last updated value. That's why such systems are usually described as providing base guarantees. Base stands for basically available soft state eventual consistency, as opposed to ACID that stands for atomicity, consistency, isolation, durability. While this approach greatly increases access time and scalability, it may lead to data loss. The severity of the problem depends on database server support and the quality of application code. In some cases, this issue might be very serious. Performance depends on the use case. As we have mentioned before, there are specific cases that should be considered when we decide to use NoSQL database, because it may help us to bring significant performance, and from other side, it can decrease performance while doing other operations. That's why we need clearly understand business domain and data manipulations in our app to make decision about NoSQL database. Little uniformity among different NoSQL databases. There are many types of NoSQL systems, and there is little uniformity among them. Such characteristics as flexibility, performance, complexity, scalability, and so on vary greatly among different systems, which makes choosing from among them difficult even for experienced specialists. Nevertheless, when properly chosen in concordance with the project's peculiarities, NoSQL can provide a much more efficient solution than a SQL system without significant loss in stability. Not mature ecosystem. Probably the biggest downside of NoSQL is that it is not as mature as SQL. Sure, it has been around since the 70s and started to become popular in 2000s, but the truth is that SQL has had massive amounts of investment, time, and effort poured into it. As such, SQL is in a much more advanced state compared to NoSQL. But how this may impact us? People who invest big money and want to be sure with the success of their project more often would opt for reliable and proven solutions. Also, it will be easier to find necessary information in the internet about SQL-related issues, rather than NoSQL. And the same situation is with experts. There are much more experts in SQL domain nowadays. Huge databases. NoSQL isn't designed to remove data duplication. Data duplication is a fact in NoSQL, and not always considered to be an issue. But in case you count on getting high-quality data, you may face with opposite with NoSQL. Definitely, storage doesn't cost crazy amount of money nowadays, but this is something to bear in mind too. So, I believe having information about advantages and disadvantages of SQL and NoSQL databases, you already understand in which case what database is more applicable. And still, in case you have not answered questions after all this, put them in comments to this video and I will be happy to answer those. There is one more classification of databases that I'd like to discuss with you. We can also have centralized and distributed database. Let's understand what are they and what is the difference between them. Let's start from understanding what centralized database first. Centralized database is a type of database that stores data at a centralized database system. It allows to access data through the special applications that contain the authentication process to let users access data securely. An example of centralized database can be central library that carries a central database of each library in university. Such databases have their own advantages and disadvantages. Let's review them. Among advantages, we should list next things. Security. Since all the data is in one place, you can take additional steps and actions to secure it better, and apply additional security measures around it. Data integrity. In case you have all data stored in one single place, it is easy to support its integrity. This means that it is easier to coordinate the data and it is as accurate and consistent as possible. Minimal data redundancy. The data redundancy is minimal in the centralized database. All the data is stored together and not scattered across different locations. Lower costs. The centralized database is cheaper than other types of databases as it requires less power and maintenance. But if we will talk about disadvantages, it worth to name the following ones. More load on the network. Since all data is at one place, all data requests will be redirected to the one place only. This may cause network overhead. And in case multiple users try to access the same piece of information, it may reduce efficiency of the system. No recovery measures. Since all data is stored in one place, it is easy to lose all data at once in case of emergency, or in case of physical destruction of storages. To address disadvantages that are inherent for centralized databases, we have distributed databases. Unlike a centralized database system, in distributed systems, data is distributed among different database systems of an organization. These database systems are connected via communication links. Such links help the end users to access the data easily. Examples of the distributed database are Apache Cassandra, HBase, Ignite, and others. Distributed database storage is managed in two ways: replication and fragmentation. In database replication, the systems store copies of data on different sites. The advantage of database replication is that it increases data availability on different sites and allows for parallel query requests to be processed. However, database replication means that data requires constant updates and synchronization with other sites to maintain an exact database copy. Any changes made on one site must be recorded on other sites, or else inconsistencies occur. When it comes to fragmentation of distributed database storage, the relations are fragmented, which means they are split into smaller parts. Each of the fragments is stored on a different site, where it is required. One of the key things we have to worry about before fragmentation is to make sure that the fragments can later be reconstructed into the original relation without losing data. The advantage of fragmentation is that there are no data copies, which prevents data inconsistency. The fragmentation in turn may be of two types. Horizontal fragmentation. This is when a relation schema is fragmented into groups of rows, and each group is assigned to one fragment. And vertical fragmentation. This is when a relation schema is fragmented into smaller schemas, and each fragment contains a common candidate key to guarantee a lossless join. We can classify distributed databases further into homogeneous databases and heterogeneous databases. Homogeneous database systems work on the same operating system and use the same application process and carry the same hardware devices. On the other hand, heterogeneous database systems work on different operating systems under different application procedures and carries different hardware devices. Basically, there are logical advantages of distributed databases. Hard to lose all data at once and easy recovery. Since data is distributed, it would be hard to destroy all data at once since it is stored in different locations. And anyway, it will be easy to recover lost data since it is also stored in other places. Flexibility. Since data is distributed already, it is easier to scale it across different locations. Better performance. In case you have users across the world, they can send requests to storages that are physically closer to them, and thus, the load on the network is distributed between different locations. Durability. Even if some of the data nodes go offline, the rest of the database can continue its normal functions. And even despite all advantages, distributed databases also have some disadvantages. Some of them are extra complexity. I believe that this is obvious that support of consistent data shared between different places takes additional efforts, so ensuring of data integrity becoming a more complex task. Extra costs. Another obvious thing that more costs will be spent for support and maintenance of such system. In case you have any questions regarding centralized and distributed databases, let me know in comments to this video. Basically, that's all what I wanted to share with you today. Let's review what we have learned in this lesson. Today we learned what database is and why we need it. Now you know advantages of using databases in your apps. This is an important thing to understand. Also, after this lesson you can understand the difference between database and database management system. We learned different types of databases. Namely, we learned what relational database is, and we learned what not relational or NoSQL databases are. We reviewed different types of NoSQL databases. We compared centralized and distributed databases. Also, we reviewed advantages and disadvantages of each type of database. So, as you can see, there are really a lot of things that we have learned today. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello team, in this lesson we are going to configure and prepare environment for our further education. Basically, you can select any database management system you like the most. Because for learning purposes, especially when we learn basics, everything is the same. When gradually we will jump to more advanced concepts, you would understand that dialect of SQL might be in some rare cases a little bit different. Inbuilt functions might be named differently, the way how DB works inside might be different. But anyway, I will give these comments as we go, and considering these differences are not dramatic, it will be easy to hold comparative analysis during the lesson. Today we are going to hold an overview of MySQL, including MySQL Workbench, and install it on your computer. We are going to start from question why MySQL, and we will hold overview of MySQL. We will talk about MySQL features in order you can understand it better. After a small piece of theory, we will jump to practical part. We will install with you MySQL Server, MySQL Workbench and MySQL Shell on your computer. We'll create our root user and configure our database. Once all configuration will be done, we'll establish new connection from MySQL Workbench to our MySQL Server to be sure that we are ready for the next lessons. And at the end of the lesson, I will elaborate more about Windows servers for MySQL. Let's start our lesson. Let's start from MySQL overview. Why we may wanna choose MySQL? In few words. According to some statistics and different sources of information, MySQL may be considered as the most popular relational database nowadays. Definitely, there will be different opinions on that, because it is hard to calculate the number of users objectively. But still, it is hard to reject the fact that this is definitely one of the most popular relational databases in the world. I will try to explain you briefly what MySQL is. First of all, MySQL is a relational database management system. A relational database stores data in separate tables rather than putting all data in one big storeroom. The database structures are organized into physical files optimized for speed. The logical model with objects such as database, tables, views, rows, and columns offers a flexible programming environment. Another important thing is that MySQL is free. You should pay nothing for using it. You can use it even in commercial projects for free. There is MySQL Community Edition that you can use following GPL license. GPL stands for General Public License, is a series of widely used free software licenses that guarantee end users the freedom to run, study, share, and modify the software. there are different versions of it, so you can follow up with the specifics of the license for MySQL, but in general and in main goal, all versions of GPL license are similar. MySQL is open source. This is an important point of MySQL. It is supported by a huge and active community of open source developers. That means that there are a lot of information available in the internet about it, a lot of problems resolved, and a lot of workarounds found. Definitely selecting a tool with a big community support usually considered as a right step. MySQL is ideal for both small and large applications. It is easy to make this statement when you are familiar with advantages of MySQL and how it is built inside. MySQL works just perfect with small and medium amount of data. Definitely, if we are talking about terabytes of data, we might consider NoSQL database, but for most cases, MySQL is just perfect. MySQL is very fast, reliable, scalable, and easy to use. If that is what you are looking for, you should give it a try. MySQL Server can run comfortably on a desktop or laptop alongside your other applications, web servers, and so on, requiring little or no attention. If you dedicate an entire machine to MySQL, you can adjust the settings to take advantage of all memory, CPU power, and I/O capacity available. MySQL can also scale up to clusters of machines networked together. MySQL Server was originally developed to handle large databases much faster than existing solutions and has been successfully used in highly demanding production environments for several years. MySQL also comes with MySQL Workbench that we can use to administrate our database. This is a nice desktop application that allows us to perform different operations with our database and data inside it in a very simple manner. MySQL is cross-platform. There are different installation packs for different operating systems, so you can be sure that MySQL will be supported on your operating system too. MySQL is compliant with the ANSI SQL standard. Like I mentioned already, originally there are different dialects of SQL, and currently there is a process of standardization of structured query language between different databases. Obviously, this is not the easiest thing, because owner of each database, first of all, worries about his user. But MySQL is already compliant with the first SQL standard that was created by American National Standards Institute. MySQL Server works in client-server or embedded systems. The MySQL database software is client-server system that consists of multi-threaded SQL Server that supports different backends, several different client programs and libraries, administrative tools, and wide range of application programming interfaces, APIs. MySQL was first released in 1995. MySQL is developed, distributed, and supported by Oracle Corporation. During the course, I will demonstrate features of MySQL. I will just briefly mention them here on the slide. So, main features of MySQL are: MySQL Server design is multi-layered with independent modules. It is fully multi-threaded by using kernel threads. It can handle multiple CPUs if they are available. MySQL provides transactional and non-transactional storage engines. It has a high-speed thread-based memory allocation system. Also, it supports in-memory heap table, handles large databases. Server works in client-server or embedded systems. Works on many different platforms. In general, there are a lot of cool features in different areas, namely in such areas as internals and portability, statements and functions, security, scalability, and limits, connectivity, localization, etc. As of now, I believe you have at least high-level understanding about MySQL. Let's proceed now with MySQL installation. I prepared a special guide for you highlighting the main things during the installation process. As we said before, MySQL is cross-platform. That means you can install it on different operating systems. I use Windows. That's why in video I prepared a tutorial for Windows installation. In case you have Mac by Apple, don't worry. In attachments to the lesson you can find detailed guide on how to install MySQL on Mac. And at the meantime, let me proceed. The first thing that I recommend you to do is to download MySQL installer. I'm going to leave links in attachments to this lesson for Windows installer. You can download it from official MySQL website. Download the bigger file, like it is shown on the slide. On the next page we will be offered either to log in or to sign up. And a lot of students of mine starting registration at this moment. Just wanted to draw your attention that this is not necessarily to create an account. If you want, you can create one, but this is not a blocker for us to proceed with download. Please pay attention to clickable text below. No thanks, just start my download. Just click here and download will be started straight away. After you click this button, your download will be started. Make a cup of tea because this may take some time. Once download is finished, run the installer. Right after the startup, you will be offered to choose among the different setup types. This is MySQL installer that allows you to install the different products. You can spend a minute or two reading through the setup type description. Somewhere you will be offered to install MySQL Server, Router, Workbench, MySQL for Visual Studio, connectors, documentation, samples, and different combination of these options. I always prefer to select things that I need by myself. That's why I select Custom Radio button. Remember, it is only up to you what you would like to install on your computer, but I would select for myself the next things. MySQL Server. This is our actual database. MySQL Workbench. This is desktop application that allows us to interact with MySQL database with nice user experience and great UI. MySQL Shell. MySQL Shell is an advanced client and code editor for MySQL. I install it, just in case. Because in case Workbench will be accidentally broken, I would use MySQL Shell. I believe you would be able to handle this UI in installer. Basically, you need to expand each option and select the option you need. And after that, press on the arrow to move your selection in other area that is called Products to be installed. After this, I press Next button. On the next step, you basically need do nothing. Just verify your selections. All products should have status ready to install. And press Execute. After that, install process will be started. You just need to wait until status will be changed to complete for all products. Wait for a few minutes here. You can press pause in the lesson and wait until installation will be over. When all products successfully installed, you would be notified with complete status. After this, just press Next button. Now, when all products are installed, you will be offered to run configuration wizard for products that require configuration. In our case, only one product requires configuration. That is MySQL Server. Not so much other options at this stage, besides clicking Next. The first thing that we need to configure is config type and network configurations. You have a few predefined config types. The main differences between them is how much memory and resources dedicate to MySQL Server process. Obviously, if this is development computer, we can't afford the same computing power as on the separate server that we use specially for databases. That's why I opt for development computer option here. Next thing that we need to do is to configure port number. MySQL Server will be running on your computer and we need to specify port of this application. We are going to learn web development and web technologies in a separate course, and I will explain there in details what TCP/IP protocol and how it works. But still, I want you to understand what this configuration is about. All computers are connected in the global network, and you can use IP address to find the device that is connected to the network. IP address is similar to the address of the building in your city. And when we found the building in the city, we need also to know apartment number to visit our friends. Do you understand the analogy? So the port number is number of apartment in the building. In order other apps know address of MySQL server. Hope this is clear now. By default, MySQL server uses port 3306. If for some reasons, and this is almost next to very unlikely, in case your port 3306 is not available because other app using it, just change this port number. Anyway, this is not super critical because we will use this port during the configuration of any connection and we will be able to change it manually when we need. The port of X protocol supported by clients such as MySQL Shell, MySQL Connectors, and MySQL Router is calculated by multiplying port used for classic MySQL protocol by 10. For example, if the classic MySQL protocol port is the default value of 3306, then X protocol port is 33060. That's all configurations that we are going to apply on this page. Let's press Next button. On this step, we need to select authentication method. It is recommended to use strong password encryption. MySQL will use improved stronger SHA-256 based password methods. Let's move on to the next step. In database, we always have user with all rights and privileges. Got admin user who can do everything with the configurations of the app. Usually such user is called root user. And now we have opportunity to set the password for this user. Please make sure that you will never forget this password. This is important password. You may forget passwords to other users, but never for this one. On this step, you can also add other users, but I don't think that this is necessary at this moment. We are going to learn how to add users and grant them privileges later in the course. Let's press Next button. Here you have opportunity to configure Windows Service. Windows services are core component of the Microsoft Windows operating system and enable the creation and management of long-running processes. Basically, MySQL Server will be up and running with the name you specify here. Also, you can start MySQL Server every time at system startup. You will be able to change this configuration later too. And below you can select accounts that will start MySQL Server. I recommend you to not change this option and leave it selected on standard system account. And the last thing that we need to do is to agree to apply configuration. You can check all your configurations and navigate back if you want to change something. But in case you are happy with all configurations that we set, click Execute button. When all configurations are applied, you are going to see something like you see on the slide. Finish button will become available to you. Let's click it. Now, after all configuration is completed, click Next and Finish to close MySQL installer. You can keep checked checkboxes to start MySQL Workbench and MySQL Shell. Anyway, they are already installed, and you will be able to find those in the menu. Finally, we managed to open Workbench. In the MySQL Connections section, you can see that by default you already have one connection. This is connection to your local MySQL server that is running on your local host and available via port 3306. In computer networking, localhost is a host name that refers to the current computer used to access it. It is used to access the network services that are running on the current machine. Even in case this connection is absent, or you need to create a new one, just click a plus sign to add new connection. To add new connection, add connection name first. This is just a name that you will use to refer to this specific connection. We will keep standard connection method, but remember, this is also configurable. You can also use TCP/IP connection over SSH or local socket pipe. Anyway, this information doesn't bring a lot of sense at this moment. As I said before, I have separate course about web and web programming. In that course, we focus all our attention on network questions. You can check that course later because it is not critical at the moment. If your MySQL server is running on your local machine, you can leave hostname like this. But this address also refers to the local host. In other words, to this computer. If you have another IP address, you can put it here. You also should verify port. If you use default MySQL server port, you can leave here 3306. If no, then change. Change username that you wanna use to connect to the database and password for this specific username. To add password, click on Store Involved button. In this case, I'm going to use my root user with his password. If you remember, so far we have only one user. If you didn't add any other users during the database configuration step that we did together, then you also need to use root user and password for this user to connect to the database. Press OK button once you entered password. Now we can test our connection. In case we successfully connected to the database, you will see similar message to the one you can see on the slide. If there are some errors, for example like wrong password, you are going to see that notification in this window. Once connection is tested, press OK button in the pop-up window and OK button one more time to create new connection to a database. Great! Well done, team! We prepared environment for our future lessons. Congratulations with this! Now we are ready to start learning how to work with the workbench and database. In case you still have some questions, please let me know in comments below this video. And the last thing for the day that I'd like to share with you is configuration of MySQL Windows service. Just open services. You can find them in your Windows menu using search via services keyword. Here in the list you will be able to find MySQL service. This is a place where you can stop it, put it on pause and start again. Also you can change startup type. In case you don't want this service load your processor, click Properties and change startup type. Everything is simple here. Well done, team! That's all what I wanted to share with you in this lesson. Let's recap what we have learned in this lesson. In this lesson we hold MySQL overview. We reviewed its main features. After that we installed MySQL Server, Workbench and Shell. We connected to our MySQL Server using our Workbench. And at the end of the lesson I explained you more about Windows service for MySQL. That's it. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students. In previous lesson we hold an overview of MySQL. Also we installed it on our laptops. But in this lesson I would like to review with you another popular database management system that is called PostgreSQL. We are going to start this lesson from general overview of PostgreSQL and its main features. After you become a little bit familiar to this relational database management system, we will proceed with practical part of the lesson. We are going to install with you PostgreSQL Server, pgadmin, Stack Builder, and command line tools. The goal of our lesson is to make sure that your environment is ready for further learning of databases. So, I will explain you how to connect to the database using pgadmin. I am going to show you how to create new connections to other PostgreSQL servers. At the end of the lesson, you will also understand how to manage PostgreSQL Windows service. We have a lot of plans for this lesson. Let's get it started. PostgreSQL is a powerful open-source object relational database management system that uses and extends the SQL language combined with many features that safely store and scale the most complicated data workloads. It also worth to mention that PostgreSQL has come a long way since 1986, when it was part of the Postgres project at the University of California at Berkeley, and has more than 30 years of active development on the core platform. PostgreSQL is not controlled by any corporation or other private entity, and the source code is available free of charge. PostgreSQL is loved by many developers across all over the world because it has earned a strong reputation for its proven architecture, reliability, data integrity, robust feature set, extensibility, and the dedication of the open source community behind the software to consistently deliver performant and innovative solutions. PostgreSQL is cross-platform and it runs on all major operating systems. Also, it is transactions compliant since 2001. and has powerful add-ons such as the popular PostGIS geospatial database extender. It is no surprise that PostgreSQL has become the open-source relational database of choice for many people and organizations. PostgreSQL comes with many features aimed to help developers build applications, administrators to protect data integrity and build fault-tolerant environments, and help you manage your data no matter how big or small the dataset. And on top of all things that we have already discussed about PostgreSQL, it is also highly extensible. What does this mean? For example, you can define your own data types, build out custom functions, even write code from different programming languages without recompiling your database. Pretty cool features, don't you think so? In the lesson about MySQL, we also discussed on the high-level existing standards for SQL, structured query language. And also we mentioned that each database management system may have its own dialect. Dialect includes some minor differences in syntax, like it is stated on the PostgreSQL.org website. PostgreSQL tries to conform with the SQL standard where such conformance does not contradict traditional features, or could lead to pure architectural decisions. Still, it is not always clear how syntax differences may impact on architectural decisions. In my subjective opinion, this is just inheritance from times when there were no standards for SQL. And as you already know, PostgreSQL is not a new project. As a conclusion of dialect differences, I'd like to say that many of the features required by the SQL standard are supported, though sometimes with slightly differing syntax or function. Let's review core features of PostgreSQL. Among features, it is worth to mention the next ones. Data types customizations, composite custom types, just-in-time compilation of expressions, sophisticated query planner optimizer, index-only scans, multi-column statistics, advanced indexing, point-in-time recovery, active standbys, replication, asynchronous, synchronous, logical, write-ahead login, authentication features, multi-factor authentication with certificates and an additional method, support of procedural languages, SQL JSON path expressions, foreign data wrappers, connect to other databases or streams with a standard SQL interface, many extensions that provide additional functionality, including PostGIS. These are just some of the features that you can find in PostgreSQL. Probably we can say that you already have an impression about PostgreSQL. And yes, you are right. This is also a cool database management system. This is one of the reasons why it became popular. So, let's now install it on our computers. The first thing that we need to do is to download distribution pack for your operating system. You can find link to the download page in attachments to this lesson. You can find either interactive installer or zip archive with binaries. For this tutorial, and personally for myself, I would download interactive installer. I don't wanna play hacker game in console to extract binaries. Also, all examples from the slide are for Windows. There are similar steps during the installation for Mac OS. But just in case, you can also find an attachments guide on how to install PostgreSQL on Mac. Basically, after you selected your operating system, there is a separate page where you can select what you would like to download, binaries or installer. You can make a cup of tea because downloading may take some time. Once downloading is finished, run the interactive installer. On the first step, there is nothing special, just welcome message. Click Next button. On the next step, make sure you specified installation directory. Once you are ready, click the Next button. On this step, we have to select PostgreSQL components that we want to install. Let me explain you a little bit about each of these. Well, PostgreSQL Server, it is our core component. You can treat it as database itself. pgadmin is a client UI to interact with PostgreSQL Server. The Stack Builder utility provides a graphical interface that simplifies the process of downloading and installing modules that complement your PostgreSQL installation. When you install a module with Stack Builder automatically resolves any software dependencies. So, this is a nice tool to have installed, just in case. And another component is a command line tools that are used to interact with PostgreSQL with the help of command line. I recommend you also to install this, just in case. After that, click Next button. After that, you have opportunity to configure paths to the folder where your data will be stored. By default, you will be offered to create data folder in PostgreSQL installation directory. If this is okay for you, then just press Next button. On the next step, please provide a password for a super user who has all rights in database. Having access to this user, you can start creation of other users, schemas, tables, and so on. Please remember this password. This is important. PostgreSQL Server is an app that will be running on our computer. And to get connected to the PostgreSQL, we need to know port number on this computer. In the previous lesson, when we installed MySQL, I explained what is port number. Also, I have a separate course about web programming where I cover network concept. Just to remind you a few words about port number. We are going to use it as part of the address when we will connect to the PostgreSQL server. And if IP address is an address of our machine in the network, then port number is an address of the app on this specific machine. The default port of PostgreSQL is 5432. You can change it if you wish, and if for some reason this port is already captured by other app. In my case, I just click Next. Select locale that works the best for you. This configuration will impact all localization settings of the app. Don't worry, you will be able to change this later too. You can keep default locale option and click Next button. On this tab, check installation information, and if everything looks good to you, proceed to the next step and start installation. If installation finished successfully, you would see notification about installation completion. You will be offered to launch Stack Builder. You can keep this checkbox marked if you wish, and afterwards just press Finish button and that's it. Congrats! PostgreSQL installed on your computer with all other components. So, in case you kept checkbox marked, you would have Stack Builder open. But what to do with it? In the future, you can run it separately, in case you want to install some add-ons to your PostgreSQL. For example, on the slide you can see just an example of what can be installed. We don't need anything from this list at this moment, so I just close Stack Builder. Let's understand now how to run PostgreSQL, and let's test that interaction with databases is configured properly. In previous lesson I also explained you what Windows Service is. Just to remind you, Windows services are core components of the Microsoft Windows operating system and enable the creation and management of long-running processes. Right after installation, you have PostgreSQL Windows Service up and running. You can check this by opening services on your Windows machine. Also, in this place, you can either stop this service or configure startup type. For example, I keep my SQL service started automatically on startup, and my PostgreSQL service I keep in manual startup type, because I don't see a lot of reasons to load my machine with two databases running in parallel. Definitely, for this demo, I turned PostgreSQL service on. Now you know the place where this may be configured. Great! Now let's learn how to work with PostgreSQL through the nice UI. We have separate application that we have also already installed, and that is called pgadmin. To start it, please navigate to the installation directory of PostgreSQL. You are going to find separate folder with name pgadmin. Open it, and find executable file with the same name. Double-click it, and pgadmin app will start loading. On the first startup, you will be asked to set a master password for pgadmin. This is needed because potentially you can have multiple connections and server configurations stored in the app. To secure this app, on each startup, this app will ask you master password. So also remember that password and press OK button. The next thing that we need to do is to connect to an existing server via pg-admin. You just need to expand servers in the left panel, and you will find a server that already exists on your local host. This is exactly the server that we have just installed. Click on it, and you will be prompted to enter your password. Enter here a password that you set during the installation. You can save password in pg-admin if you wish, and press OK button. Congrats team, we managed to connect to our server. That is great. On the home page you can see some charts and information about performance. There are also a lot of other things that we can do from this point, but all of this will be discussed in separate lessons in details. The most important thing is that you successfully managed to connect to the PostgreSQL server. Let me show you one more interesting thing. You can always connect to remote database knowing the exact address of the PostgreSQL. Let me show you now how to add new server. Click on servers and then click add new server. Now we need just to add some information about server that we want to connect. On the general tab, just enter names that would be easy to recognize for you and server group. You can group different servers together to navigate easier between them later when needed. After that, you need to choose connection type to the server and configure it separately. In the top bar, you can see different tabs. They are Connection. This one is for connections via TCP/IP protocol. SSL. This tab is to configure connection via SSL. SSL stands for Secure Sockets Layer. And again, we are going to learn web in a separate course. This protocol runs on top of TCP/IP protocol. SSH tunnel. On that one tab you can configure SSH connection. In our particular case, I wanna use connection tab to configure connection via TCP/IP protocol. In host address you should put the address of the host. Usually this is an IP address. In this example, I am going to connect to my local host. This IP always refers to the local host, or you can just use localhost name in this particular example. Localhost is a host name that refers to the current computer used to access it. I use default port for PostgreSQL, so I put value 5432 in the port field. In maintenance database, put Postgres. What is maintenance database? The Postgres database is also created when a database cluster is initialized. This database is meant as a default database for users and applications to connect to. After that, we need to specify name of the user. The name of our admin user by default is Postgres. Also, we have to use the password for this user. And after all configurations are on place, just click Save button. That's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson we hold PostgreSQL overview. We reviewed its main features. After that we proceed with the practice piece to prepare environment. We installed PostgreSQL Server, pg-admin, stack builder and command line tools. I showed you an example how to connect to PostgreSQL Server via pg-admin and how to create a new server inside pg-admin. Also, I explained you how and where you can configure Windows servers for PostgreSQL. Thank you all team for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we are going to start learning relational databases. We are going to start from understanding of basic concepts and gradually we will move to more complicated topics. We are going to start our lesson with learning such basic terms as table, entity, attribute, tuple, record, etc. Separate focus I will put on the differences between database and schema, because very often my students ask me what is schema and how it is different from database. After that, we are going to learn such important concept as primary key. I will share with you different examples and I will help you to understand the difference between simple and compound key, natural and surrogate key. Also, you will learn what alternate key is. To understand relationships in databases, we need to learn what foreign key is. And once we learn all these terms, we'll start learning relationships in relational databases. You are going to understand what types of relationship we have and how they are different from each other. Let's start our lesson. Before we dive deeper into the details of relational databases, let's learn some basic terms that we are going to use during today's lesson and in future lessons. Let's go over each term one by one. Database. We use this term usually to refer to a set of tables with some data in them. Is that clear? I believe there is one more question. What are tables? Table is a matrix with data of the specified format. In table you have rows and columns. Each column has name. Also, each column has data type. We can specify what kind of data will be stored in this column. Tuple. In relational databases, we use this term to describe one record of data. Okay, so what is a record? Record is one row in table. Let's continue with other terms that we need to be familiar with. Entity. An entity is a distinguishable real-world object that exists. An object should not be considered as an entity until it can be easily identified from all other objects of the real world. In other simple words, if you can't identify a set of characteristics that define some object in a unique way, which allows you to store data about the object, or if you are not going to retrieve data about some object, then there is no point in creating that entity in a database. Does it make sense? Attribute. Attribute is a characteristic. In a database management system, an attribute refers to a database field. Attributes describe the characteristics or properties of an entity in a database table. An entity in a database table is defined with a fixed set of attributes. For example, if we have to define a user entity, then we can define it with a set of attributes like email, name, etc. The attribute values of each user entity will define its characteristics in the table. In more simple words, attributes are columns in database tables. And each row has set of column values. Those are attributes. But this is a very simplified definition. There is also one more term that we are going to use often today in the lesson. Schema. A database schema is an abstract design that represents the storage of your data in a database. It describes both the organization of data and the relationships between tables in a given database. Sometimes you can find that people use schema and database as interchangeable terms, but this is not correct. The fundamental difference between them is that the database is an organized collection of interrelated data. And on the other hand, the schema is a logical representation or description of an entire database. Schema contains the structure of tables, attributes, their types, constraints, and how they relate to other tables. Do you feel the difference between these two terms? These are just basic terms. The rest terms we are going to learn with examples as we go. Is that clear? If yes, then let's proceed. Another important term in relational databases is a primary key. I decided to dedicate a separate slide to review the definition. So, primary key is a specific choice of minimal set of attributes, and you already know that attributes mean columns, that uniquely identify a tuple. And you already know that tuple is a synonym to row in a table. In more simple words, primary key is an attribute or unique set of attributes that can identify a specific row in a table among others. And if you would ask me to come up with even simpler definition, I would say that primary key is a unique ID. We are going to build a relationship between tables, and being more specific, we would build relationships with data in one table with data in another table. That means we need to find a way uniquely identify each row in each table to connect them between each other. That's why primary key is so important. Let's come up with duties of primary key. The first goal is to uniquely identify tuple in a database table. And the second goal is to ensure connection between tables. Is that clear? And always remember that in case of any questions, ask them. You can put your question below this video and I will be happy to answer it. But how to choose the primary key among other attributes? What rules should be applied, or what are the best practices? The rule of thumb is to select the shortest possible field, if you understand what I mean, or the shortest possible combination of fields. By saying this, I pursue one goal. Primary key should be simple enough to work with. It should be atomic and shouldn't consist from multiple values inside one field. It should be unique, and achieving of this uniqueness shouldn't be a hard thing to do. I mean, it is easy to find not unique first name, and it is impossible to find the same email. That means that achieving uniqueness for email field is more simple, and it is better option to use for primary key. And obviously, primary key can't be null value. Do you understand my point? Another important classification is that primary key may be simple and compound. In short, and in simple words, simple primary key consists of the one table field. This can be an email, ID, passport number, or anything else what is unique for each row in table and fits in one field. On the other hand, compound primary key consists of two or more fields. So, the combination of these fields should be unique. For example, I have online courses, and each course has ID, that is course primary key. Also, I have students, and each student has its own unique identifier. And let's imagine that I need to store information about enrollments in my course. I have enrollment table that has compound primary key that consists of two values, namely course ID plus student ID. And the rest information in the table, like date of enrollment, price paid, discount applied, or any other possible field, can be easily connected and identified with this compound primary key. Does it make sense? To be honest, compound primary keys are less often than simple primary keys, but still, they exist. And I'm going to teach you how to create compound primary keys in a database in a separate lesson during the practice exercise. Another classification of primary key depends on its origins. Primary key may be natural or surrogate. Surrogate primary key is also called synthetic sometimes. In simple words, the natural primary key is a field that stores useful information. For example, passport number may be unique for a person, but this is also value that contains information related to a specific person. This is real data that occurred naturally in this record. The same situation with email. Email may be considered as natural primary key. Natural keys have one logical advantage in my opinion. It sounds like this. Easy to search. Since natural key contains some valuable information, it is easy for you to understand this information. For example, it will be hard to remember sequence number for each user to search user by its ID, but instead it will be easier to memorize user email and search user by its email. Natural primary keys have some disadvantages though. The most important are: take more memory to store rather than surrogate key. This means that you would require more memory to store the data, and also this means that join requests on multiple tables may take more time, because usually natural keys are strings but not integers, and it takes time to compare strings. requires cascading update in case of changing. Imagine that you use email as a primary key, and user decided to change email. Shall we forbid him to do so? Of course not. He changes email. After that, we have to update email everywhere, where we used his primary key to build relationships, basically in other tables. Definitely, this operation will take some time, depending on number of changes that we have to make. But why should we do these cascading changes if we could avoid doing them at all? And one more problem that you might face with while using natural key. There might be cases when you just don't have all necessary information all the time. Imagine that in your application, you also support registration via phone number. User can choose whether he or she wants to use phone number or email for authorization. And what shall we do in this case? It is hard to answer. You would have to come up with some email that you don't have in order to fill out the primary key. And what will happen when you start sending newsletter? You are going to send an email to the false address. Well, do you see what problems may appear? To address all issues mentioned above, you can just use surrogate key. On the contrary to natural keys, surrogate key doesn't have natural relationship with the rest data in the record. That's why, no matter how record will change, your surrogate key will stay the same, because its only goal is to identify record in the table. That's it, and nothing more. Usually, this is integer value that is incremented with each new row, and you are not bothered with cascading update or thinking about any false value. I recommend you to use surrogate keys, but this will be only up to you. Summarizing all above, let's come up with advantages of surrogate keys. Surrogate key has no any business-related information built in it. This makes things easier. We shouldn't worry about updating it in all related tables, performing cascading operations in case some business-related information from primary key has been changed. Also, this type of keys takes less memory, because usually we use integer type for surrogate keys, and this is only 4 bytes. Join requests on different tables also completed faster. Usually there are no reasons to change surrogate key, because it is just an identifier. Thus, there is no need in cascading update of the value in all related tables. And the only drawback that I see in using surrogate integer key is that it can limit the number of rows in a table, because at the end of the day, we have limited amount of memory reserved for data of integer type. That is 4 bytes only. But on the other hand, you can use unsigned integer value. This gives you opportunity to use one more bit to store additional information, and in total you can create more than 4 billion rows. And believe me, if you have more than 4 billion records in your table, you are going to have a lot of other problems besides limit of integer value. And if you have 4 billion users registered in your app, you have enough resources to apply workaround for this issue. One of the solutions maybe is to create table with big int type for primary key. This data type uses 8 bytes to store information, which should be enough. And after that you can copy and paste rows from one table to another and update the last ID value for auto increment. In order you can proceed adding new IDs for new records. Don't worry, I am going to show you how to do this on practice in the following lessons. We already know what primary key is and learned different classifications of primary keys. Now let me explain you what alternate key is. They are also called sometimes secondary keys. Alternate keys are those candidate keys which are not the primary key. Since there is only one primary key for a table, other fields that are also unique and can be used for tuple identification are called alternate keys. For example, imagine that you have a table with users, and you decided to use surrogate primary key. But you also have another column that contains only unique values. It can be a column with emails, for example. Indeed, it is impossible that two users will have the same email in the system. But database administrator decided to use ID as a primary key. We applied unique restriction to email column and still can use it to extract user when needed. But this attribute may be considered as an alternate key. Is that clear? Now let's learn another important term. Let me explain what foreign key is. Foreign key is an attribute which is primary key in its parent table, but is included as an attribute in another table, with the goal to establish connection between entities. You already know that in relational database we may have different tables, and tables will be connected with each other to avoid data duplication and to ensure the most efficient and consistent data storage. Literally in a minute you are going to see examples how relationships between different tables are established. So now you know what primary key and foreign key is. That means we can learn type of relationships and understand technical side of establishing connections between tables. First of all, let's understand what relationship is. There is a definition from relational database theory that was defined by Edgar Frank Codd, inventor of relational model for database management. But instead of reading that definition, I'm going to explain you what relationship is in simple words. Relationship in a relational database management system is an association of records from two or more tables. Let me also explain relationship on example from real life. User has a car. This is a relationship between user and car. And depending on the number of objects from each side of this relationship, there are different types of relationship. Is that clear? In a relational database, there are three types of relationships. They are one-to-many, that is when one user may have many cars. Many-to-many, one user may have a lot of cars, and one car may be owned by two users, by two co-owners. And one-to-one. This is a relationship when one user can own one car only. And now I'd like you to understand each of these relationship types one by one in details. We'll try to understand it logically first, and after that I will provide technical explanation on how this is implemented on database level. One-to-many means that one object from one table may be related to many objects from another table. In our particular example with user and car, we can apply one-to-many relationship in the next way. One user may own multiple cars, but each car has only one user. This is called one-to-many relationship. One user owning many cars. Does it make sense? If you understood it logically, let's learn how this is implemented on database level. Each relationship is implemented by migration of primary key from parent table into direction of another table. The field that we received after this migration is called foreign key. In this example, we have table user and table car. We add new column in table car that is called user ID. This will be a column that stores foreign key, and for each car of specific user, we put his ID. And that's it. We successfully established a relationship. Now you can query these two tables together. For example, your query may sound like this. Return me car manufacturer of each car that belongs to the user with ID 1 and user email. And you have enough information to map records from two tables between each other. Do you understand? In our SQL lesson, I will teach you how to create SQL queries to retrieve this kind of information. But is it clear for you at least on the high level? Remember, understanding the concept is much more important rather than understanding of detailed query, because syntax of SQL is something you can always learn and something what you can always find in the internet. But deep understanding, that is something what belongs only to you. and can't be found in the internet. So, press a pause for a minute if needed to understand this. Once you feel sure that you understood this, let's proceed. On the diagram, we usually mark this relationship with asterisk and 1 digit. Asterisk stands for many, and 1 stands for 1. Again, 1 user and many cars. Each car has only 1 user. One more thing. In case you are going to use Object Relational Mapping Framework in your programming language, you may find that sometimes there is a difference between one-to-many and many-to-one relationship. Basically, these are the same relationship types, but the only difference in what is the ratio in the current object between related other objects. For example, in the same case, relationship will be named one-to-many in user entity, and it will be many-to-one in car entity. Do you feel the difference? That's great. Let's move on. And the next relationship that we are going to review today is many-to-many. This kind of relationship defines the situation when one record from one table may be connected with many records from another table, and one record from another table may be connected with many records from the first table. I can say that many-to-many relationship, it is also humans naming. Technically, this is just two one-to-many relationships, implemented in two directions. Does it make sense? Let's try to understand how to implement this. Imagine that we have students and different courses. Each student may enroll in multiple courses, and basically each course may have multiple students. We have bidirectional one-to-many relationship between these two tables, or in other words, many-to-many. In this case, we can't just put foreign key into tables, because we need to build many relationships on one side and many relationships for each record on another side. So, technically, this is impossible to do with two tables only. That's why, to organize many-to-many relationships between two tables, we need to create the third table. The third table will contain foreign keys from one and the second tables, and will map them between each other. In this particular case, if student with ID 1 enrolled in some course, we map IDs of course and student in the third table. And if this course has also students with ID 2 and 3, we also specify this in the table. Here we have compound primary key. Combination of these two fields has to be unique in each tuple. Regarding naming convention for such tables, it depends on the final purpose of this table. If we just want to establish connection between two entities, then we can use entity names and a verb that describes connection between them. In this case, we can name this table student has course, or even shorter, student course. In case we would add another business-related info in each tuple, like date of enrollment, price, information about discounts, and in case we are going to operate with this entity as with the separate one, in this case we can give some business valuable name to this table. For example, enrollment. Is that clear? And we have one more type of relationship to discuss. I am talking about one-to-one relationship. This is the rarest type of relationship. To be honest, based on my experience, you would face with one-to-many and many-to-many relationships more often than with one-to-one. Because this type of relationship describes very specific business case, when one record in one table is related with only one record from another table. Can you think of cases like this? It is hard to do without preparation, and I can understand you. I come up with some example for this type of relationship. Imagine money transaction, and you have table with all transactions in it. And also there is transaction info table. There is more detailed information about each transaction, and it also stores sensitive information, and not all users can read it. That's why there is a need to store some attributes and values insecure table. But still, there is a connection between these two tables. And each transaction is connected with only one record in transaction info table, and vice versa. Each transaction info record connected to only one transaction. To implement this connection, you can use two strategies. You can either use shared key. That means that primary key in one table is equal to primary key in another table. Or you can create join column and declare a field where primary key will be exported to another table. Both options are good in this case, because they allow you to build a relationship between two tables. I would just put a stress one more time on the fact that there are not so many cases for one-to-one relationship. Having one-to-one relationship without clear argumentation is an indicator of pure database design. That's all what I wanted to share with you in this lesson. Now, let's recap what we have learned today. In this lesson, we learned basic terms in relational databases. Now you know the difference between such terms as database and schema. We reviewed in details what primary key is. Also, we have learned different classifications of primary keys, such as single and compound, natural and surrogate. I explained you what alternate key is. After that, we learned such important concept in relational database as foreign key. And at the end of the lesson, we learned three main types of relationship. Now you know the difference between one-to-many, many-to-many, and one-to-one relationships. Thanks a lot for your attention, team. Have a great day. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, by this moment in our course you already have some theoretical knowledge about relational databases. And in this lesson we are going to have more practice activities. This lesson will be dedicated to learning of basic operations with database management system. We are going to create schema and table in database. And as we go, we'll learn a lot of interesting things. We are going to have super interesting lesson because we'll start from practice activities and we are going to learn just enough theory to achieve goal of the lesson. During the lesson we'll perform operations in MySQL workbench and you will gradually start learning it step by step. I will explain you what main buttons are and I will hold live demo with explaining of each step that I'm doing. The main goal of the course in general, and this lesson in particular, is orientation on skills that you would need on practice. And you already know enough theory to proceed with this lesson if you watched all previous lessons. Now, we will not have one more theory lesson, because I understand that it will be hard to remember so much information without understanding how this information may help you, and why do you need to know it at all. That's why in this lesson we'll just create a schema and one table with you. That's it. Sounds like not a lot of things to do, but still, a lot of things to understand. I will put separate focus on naming convention, we'll talk about char set and collation, also we are going to review MySQL storage engines. When we'll start create columns in our table, you would need to understand different data types and column properties. Be prepared. This is going to be interesting and useful lesson. Let's start. Let me start from the screen sharing straight away. As I already said, today we are going to have a lot of practice activities. In this lesson we are going to work in MySQL workbench. In case you don't have neither MySQL nor workbench installed, please refer to the previous lessons. I have a separate lesson where I explained how to install MySQL apps on your computer and configure connection to MySQL server. So, here is how our connected server looks like via MySQL workbench. Few words about interface. Once connection to the MySQL server is established, you have a separate tab here. You can return back on the home page if you wish by clicking on this icon and vice versa. Menu options are located here on top. One of the most frequently used operations depicted via icons here. We are going to use them a lot during the work with Workbench. Some of them are: create SQL query tab, create schema, create table in active database, create a new view, and others. Gradually, we will have practice with each of these options. Pay attention that in Navigator view you have two tabs. They are Administration and Schemas. Since this is our first practical lesson, I wouldn't start from Administration tab because I believe we need to start from something more simple at this moment. We are going to have also a separate lesson where I will explain how to administrate your database, including data import and export, users and privileges configuration, server performance monitoring, and others. So, in this lesson, let's perform our first steps in order to create our database and fill it out with data. The first thing that we need to do is to create schema. Find this icon here. It will help us to create schema. We need to specify name of our schema. Let's call it LearnITDB. And the first rule here: while this is not a strict rule and you wouldn't break the database, it is still strongly recommended to follow naming convention. A naming convention is a set of unwritten rules we all should use if we want to increase the readability of the whole data model. We'll apply these rules while naming anything inside the database: tables, columns, primary and foreign keys, stored procedures, functions, views, etc. While most rules are pretty logical, you could go with some you have invented, and that is completely up to you. For example, when name any database object, it is recommended to use lower letters. In case we need to have multiple words in name, we use underscore. Like in this case, for example, learn_it_db. Is that clear? I believe that it is clear for you how to use underscores, but probably the only one thing that is still not clear for you is why we need to follow naming convention and what benefits we expect to get. For example, why we just can't follow the same naming convention as we have in Java and use camel case. Let me name at least few reasons to follow naming convention. Reason number 1. Simplicity of database model. Usually, you don't have just one or two tables in your database. Usually, there are much more of them in your database, and having consistent naming would simplify navigation between the tables and the data, because to avoid total mess, you have to follow at least some organizational rules. The second reason is database stability. If you decided to use the same naming convention as in programming language of your application, you have to remember one more rule. Usually, database is one of the most stable components in your app. Changes on database layer are avoided and only done when it is necessary. Imagine that you would like to use Java naming convention for a database, but in 1 year you decided to have other modules written on Node.js or Python or PHP, and those modules also interact with this database. What will you do? You can't constantly change naming convention just because you changed main programming language in your app. Do you understand this? In case you follow database naming convention, you can expect that even after you changed programming language of your app, you still have stable database layer. This will help you to keep your database well organized and structured. And the last but not the least reason, readability of data model by each team member. Once you have specific patterns that you follow, it will be easier for you, and what is also important, it would be easier for colleagues of yours to query your database. Very often we work in teams, no matter small or big, and very often we support databases created not by us. That's why following common rules would simplify our lives. Is that clear? Even in case you still have any questions, please put your questions below this video and I will be happy to answer those. So, we specified name for our new schema. What else we need to specify here? Let's check together. The next thing that we need to specify here are char set and collation. Let's review one by one and we'll start from char set first. A MySQL character set is a set of characters that are legal in a string. For example, imagine that we have English alphabet from A to Z, and we assign each letter to a number. We have A equal to 1, B equal to 2, and so on. In this case, A is a symbol, and the number 1 that is associated with the letter A is encoding. The combination of all letters from A to Z and their corresponding encodings is a character set. Does it make sense? Can you understand now what a char set is? Let's select in char set UTF-8 MB4. Why? Because we need to have here UTF-8 encoding that use 4 bytes to store character. By default, MySQL use UTF-8 as alias of UTF-8MB3 that only stores a maximum of 3 bytes per chord point. On official website of MySQL, it is referred as deprecated, and it is mentioned that it will be removed. Instead, it is recommended to use UTF-8MB4. Each character set has one or more collations that define a set of rules for comparing characters within the character set. A MySQL collation is a set of rules used to compare characters in a particular character set. Each character set in MySQL has at least one default collation, and it can have more than one collation. However, two character sets cannot have the same collation. Usually, there is a default collation associated with each char set, but during the creation of our schema, we can select a collation for our char set. By convention, a collation for a character set begins with the character set name and ends with SI, that stands for case insensitive, CS stands for case sensitive, or bin, that stands for binary. MySQL allows you to specify character sets and collation at 4 levels: server, database, table, and column. Currently, we can set up collation on database level, and if you are wondering which collation to choose, I recommend you to go with UTF-MB4 Unicode CI so that sorting is always handled properly with minimal, unnoticeable performance drawbacks. Anyway, you can see there are really a lot of different variations of collation here, and you can check documentation to select the one that works the best for you. In case you're also experiencing issues with interface here, like I do, and you can't see the whole name of your selection, don't worry. In MySQL Workbench, every operation that you are going to perform is translated into SQL query, and you can check query before execution of any command. By the way, this is also one of the ways to learn SQL better. I click Apply button here, and here you can see SQL query. This is not the lesson about SQL. My goal was to let you understand what operations we need and we can do in general with our database, and only after that jump to learning of SQL. Because when I started learning SQL with students straight away, they just couldn't understand why they need this and what they are doing with it. As you can see here, we use create operator to create schema with name learnItDB with default character set UTF-8MB4 and collation UTF-8MB4 Unicode CI. Even in case you selected wrong option because you were not able to see the full name and drop down, you can adjust name of collation here. Now, query looks good to me. Let's execute it. In case operation was successful, you can see that SQL statement has been executed successfully. Click Finish button. Now, on Schemas tab, on the left, we can see that we have new schema in the list here. Double-click with mouse left-click, and once the name of the database is in bold, that means you selected the specific database, and you can work with it. Inside, you can see that we may have tables, views, stored procedures, functions. We are going to learn how to create all these database objects and how to work with them. But in this lesson, let's create table and perform basic operations with it. We can create table using Workbench interface in different ways. You can use one of the menu icons here that is called Create New Table. Or you can use menu. I do mouse right-click on tables and select Create Table. Let me walk you through the configuration here. The first thing we need to specify here is table name. Let's imagine that we want to create user table. User table will contain information about users. And now, important thing about naming convention for tables. One of the arguable questions is whether you need to use plural in the naming of tables or singular. For example, if you are going to store users in this table, isn't it logical to name table users in plural? There are different points of view on this. Let me explain. The first option is to use singular for table name. That is what I would recommend you to. I prefer to use the uninflected noun, which in English happens to be singular. If you are naming entities that represent real-world facts, you should use nouns. These are tables like employee, customer, city, and country, for example. If possible, use a single word that exactly describes what is in the table. Let's try to understand what benefits this brings to us. The first reason is logical and semantic. And I really understand that this is also may be considered as arguable point. For example, at your home, if you have bag with socks, you would put a label on it that says socks, but not sock in singular. But another question, why you should apply naming convention from socks to your database? Just joking, but indeed, naming table in plural form also contains some logical holes. Because if we want to name table in plural, why we don't ask other questions about grammar too? For example, we also might be thinking about questions like this. Since we are usually doing something with the rows, why not to put the name in the accusative case? Or another question, if we have a table that we write to more than we read, why not put the name in dative? It is table of something, why not to use a genitive? And you know what? We will not constantly address all of these questions, because we will end up with mess. The table is defined as an abstract container that exists regardless of its state or usage. Using the uninflected noun is simple, logical, regular, and language independent. The second reason is convenience. It is easier to come out with the singular names than with plural ones. Objects can have irregular plurals or not plural at all, but will always have a singular one, with few exceptions like news. Another reason is simplicity. When we'll jump to learning of SQL, you are going to use table names for queries. Also, we are going to refer to attributes of a table. Like for example, to get value of name attribute in user table, we'll use user.name, but not users.name. And it seems logical and simple, don't you think so? You extract name of specific user, but not all users. Definitely, I can find a workaround for this too. More experienced students while watching this video may mention that we can use aliases for table names. But why we need to do this if we just can name table in singular and that's it? I'm the guy who always finds a way to simplify everything to the possible degree, and this is one of the cases. One more reason that often considered not like important one, but still, it's worth of your attention. It is globalization. Very often we work in multinational teams, and very often for many of team members, English is not native language. And having repository table instead of repositories, or having status table instead of statuses, will save your team a lot of time and minimize errors because of typos and similar linguistic issues. Probably, this is not like the most critical reason to use singular names for tables, but promise me just to think about it. Another point to think about, you know that table names may consist of multiple words separated by underscore. This would raise additional questions from your team. What words should be in plural and which not? For example, order detail. If you use singular, there are no questions at all. It is simple to write queries because you remember that everything is in singular. But in case you would like to follow some grammar, how far will you go? Will you use order details? Or some team members may think that you should name this table as orders details. Believe me, this might happen, and this will happen in big multinational team. And I give you hints to think about it right now, before you start a new project. And always remember that tables are the subjects of the database. Thus, they are nouns. Again, singular. There might be different reasons to use singular for table names, but in my opinion, these are the most important ones. I wouldn't lie to you that I always worked on the projects where tables were named as singular. Sometimes I worked on projects where we use plural for database tables names. And remember, the main thing in each naming convention is consistency. If all team agreed to follow some specific naming convention, and different generation of programmers on this project also understand this and agreed with this, then you don't have any problem at all. At the end of the day, your team might find logical to name container of rows with plural. If container contains users, it is obvious that we have to name it users. But we also reviewed point of view that explains why this might not always be the best way to name a table. To be honest, it is hard for me to come up with other advantages of using plural names for tables. Remember, it is always up to you what naming convention you are going to follow, but the most important here is consistency in naming across different parts of your app. I believe I answered to all concerns regarding naming convention and why I named table in singular form. Let's proceed. So you already know that you can set charset and collation on table level too. Another interesting configuration here is an engine. Let's talk about it now. Let me explain you more about storage engines in MySQL. A storage engine is a software module that the database management system uses for main operations with data, such as create, read, update, delete. Generally speaking, there are two types of storage engines in MySQL, transactional and non-transactional. In MySQL, we have 9 types of storage engines. To compare this with PostgreSQL, in PostgreSQL there is one storage engine. It is very important to select the right storage engine because this is a strategic decision that will impact future development. The default storage engine in MySQL is InnoDB from version 5.5 and later. Previously, it was MyESUM. Let me very briefly cover each storage engine in order you could understand the difference. InnoDB is the most widely used storage engine with transaction support. It is an ACID-compliant storage engine. ACID-compliant means it meets requirements for transactions. ACID is an acronym that stands for Atomic, Consistent, Independent, Durable. These are properties of transactions that we are going to cover in details during the lesson about transactions. InnoDB supports row-level locking, crash recovery, and multi-version concurrency control. It is the only engine which provides foreign key referential integrity constraint. Oracle recommends using InnoDB for tables except for specialized use cases. Another storage engine is MyESUM. The main difference from InnoDB, it is not transactional one. It is a relatively fast storage engine, but as we already said, it doesn't support transactions. MyESUM provides table-level locking. It is used mostly in web and data warehousing. Let me say now a few words about memory storage engine. It is named so because it creates tables in memory. It is the fastest engine. It provides table-level locking. It doesn't support transactions. Memory storage engine is ideal for creating temporary tables or quick lookups. The data is lost when the database is restarted. Definitely, there are not so many use cases for this storage engine, because each application requires persistent storage. CSV storage engine has specific format of the stored data. It stores data in CSV files. It provides great flexibility because data in this format is easily integrated into other applications. Merge operates on underlying MyESUM tables. Merge tables help manage large volume of data more easily. It logically groups a series of identical MyISAM tables and references them as one object, good for data warehousing environments. Archive storage engine is optimized for high-speed inserting. It compresses data as it is inserted. It doesn't support transactions. It is ideal for storing and retrieving large amounts of seldom referenced historical archived data. The black hole storage engine accepts but doesn't store data. Retrievals always return an empty set. Pretty cool feature, don't you think so? And I understand your feeling. Probably it is not so easy to come up with use case for such storing engine. But I have few use cases when this might come in handy. The functionality can be used in distributed database design where data is automatically replicated, but not stored locally. And also, this storage engine can be used to execute performance tests or other testing. Federated storage engine offers the ability to separate MySQL servers to create one logical database from many physical servers. Queries on the local server are automatically executed on the remote federated tables. No data is stored on the local tables. It is good for distributed environments. NDB cluster is an in-memory storage engine offering high availability and data persistence features. The NDB cluster storage engine can be configured with a range of failover and load balancing options. Using SQL nodes is the most common way of executing queries, and SQL node is the same as an instance of MySQL server with the NDB storage engine compiled in. The NDB storage engine provides the bridge from MySQL server to the data nodes. The NDB storage engine is implemented using a distributed shared nothing architecture, which causes it to behave differently from InnoDB in a number of ways. For those unaccustomed to working with NDB, unexpected behaviors can arise due to its distributed nature with regard to transactions, foreign keys, table limits, and other characteristics. This is not so easy to explain in few sentences, but in general, if you are interested, you can ask us a specific question about this storage engine or find documentation on MySQL site. So, what storage engine to choose among such variety? It depends only up to you and business problem you are trying to address. And one thing you should remember for sure, there is no perfect storage engine that would work the best in all possible cases. Some of them better under certain conditions and perform worse in other situations, and some of them vice versa. In software engineering, it is always a matter of trade-offs. A more secure solution takes more resources. Thus, it might be slower, take more CPU time and disk space. But you should understand that you have not one, but 9 storage engines. And MySQL is very flexible in the fact that it provides several different storage engines. Some of them, like Archive engine, are created to be used in specific situations. In some cases, the answer is clear. Whenever we are dealing with some payment systems, we are obligated to use the transactional storage. We cannot afford to lose such sensitive data. InnoDB is the way to go. If we want full text search, then we can choose either MyISAM or InnoDB. Now you know the difference between different storage engines. In our particular case, let's keep the default one here. So I keep InnoDB storage engine. After that we can proceed with declaring columns. Let's use surrogate primary key with name ID for each row. And let's make it of type int. You have to fill out column name, data type, and set column properties. We are going to learn more about each column property right after we finish discussion about data types. As you see, each column will have its own data type. There are different types in different relational database management systems, but more or less they are similar. In MySQL, all data types might be grouped into the next categories: numeric data types, date and time data types, string data types, spatial data types. MySQL supports geometry types of point, line string, polygon, multipoint, multi-line string, multi-polygon, and geometry collection. Other geometry types are not supported. JSON data type. most likely will not go over each and every possible data type in MySQL. I prepared slides to cover the most popular numeric, date and time, and string data types. On this slide you can find numeric data types. Press a pause for a minute if you want to read comments for each particular data type here. But in most cases you are going to use int type. That is my opinion. Probably sometimes you are going to use other data types too, but int type is generally enough. Especially if we use unsigned int, you have one more additional bit to store information. And pay attention, in this list you have both integers and floating point numbers. So you can select data type for your columns that meets business needs to store value. On this slide you can find data types that will help you to represent date and time in database. You may store date or time separately, or you can store data time. Working with date and time in multi-regional app always was a pain. Why? First of all, formatting during the storing in database and retrieving from database. It seems to be like simple thing, but I promise you, at least someone from your team will mess up with format. The second thing that might be challenging are time zones. Team, believe me, time zones are very painful. Some engineers use timestamp to store a number of seconds since Unix epoch, but there is a specific range of dates that is supported by MySQL by default. So one of other options, probably it is not super duper popular, but still, workaround that deserves to live. You can use even big int data type to store milliseconds from Unix epoch. Having time in milliseconds, you can convert it in any app to any date. During the conversion in both directions, you can consider time zone of the user. In this case, all milliseconds would be according to UTC. Do you understand what I'm talking about? Remember this workaround, it might help you someday, and no matter what application you will work with. And also, if you want to learn more about date and time in Java, please refer to my Java course. I have separate lesson dedicated to time zones and working with date and time in Java programs. And on this slide you can see a list of data types that you can use to store text values. One of the differences between all these types is the amount of memory that is reserved to store the value in this field. Press on pause if you want to check comments for each data type. So, we learned what data types might be used for columns. Now, let's learn another thing. Let's talk about column properties. You can see different letters here, and also the checkbox here. They are the same. Let's learn what do they mean. PK stands for primary key. NN stands for not null. UQ stands for unique. This creates unique index. We are going to learn about indexes in a separate lesson. B stands for binary, stores data as binary strings. There is no character set, so sorting and comparison is based on the numerical values of the bytes in the values. UN stands for unsigned. That is property for all number data types that allows you to store only positive numbers. ZF stands for zero fill. This is an interesting one. I need to demo this. We'll use zero fill property for one of the fields just in demo purposes. In short, it fills with 0 all the lengths reserved for value. AI stands for auto increment. Number value can be increased by 1. Usually this one is used for surrogate primary keys in order database can generate unique number for ID field by incrementing values with each new record inserted. And G stands for generated. The value is generated by a formula based on other columns. If the field is primary key, that means that this field will have only unique values, not null values. Additionally, I recommend you to add auto increment property. This will automatically increment your ID integer value on each new insertion. In this case, you shouldn't be bothered about generation of unique ID. Also, I want to use unsigned integer values in order to increase range of positive numbers that can be used as ID. Let's also create few more fields of varchar type. We are going to create first name, last name, and email. To create each new field, just press on empty space. I will create unique index for email column to make performance of extracting user by email better and faster. According to naming convention, we use lowercase and words are separated with underscores. Pay attention that you have to specify maximum length of the varchar. By default, it is 45 characters. You can just click in data area type and change this limit. And as I said, let me demo zero field property. For our ID property, we would adjust length of int data type to 5. Also, we will select the F checkbox. So, when you're ready, you can click Apply button. SQL query will be shown for you to approve. We are going to learn SQL in a separate lessons. We'll also cover create table statements. But you already can start at least watching at these queries. Click Apply button. Now, when our query is applied, we can find our table under tables in our databases. Let's expand it. And here is our user table. Congratulations! We have created our first table. To look through the rows, mouse right-click, select rows. And you can see separate tab with SQL query executed and representation of your table. You can play with this table by entering different values. Pay attention that values in email column should be unique, and you don't need to populate ID column because it is auto-incremented. Once you adjusted table, click Apply button. Again, you will see preview of insert statements. Click Apply one more time. And now you can see that ID values have been generated. And pay attention to the format. The length of ID is 5 digits. Numeration is going according to the regular number sequence. And the rest digits are filled with 0. That's what zero field property does. But to be honest, I don't use this option very often. But at least now you know what it does. Wow, we have learned a lot for today. Let's recap what we have learned in this lesson. In this lesson, we created our schema. We learned what char set and collation is and which one I recommend to use. During the lesson, we covered topic of naming convention for database objects. Now you know recommended rules to follow during the naming of schemas, tables, and columns. After this lesson, you know what storage engines are, and you know the difference between 9 storage engines in MySQL. We reviewed different data types in MySQL, and at the end of the lesson we learned column properties and created table in database. Thanks a lot for your attention. Have a great day. See you in the next lesson. Hello team! Today we are going to proceed our practical activities combined with some new piece of theory. In this video we proceed working with our first database table that we created in previous lesson. We are going to learn more about referential integrity, foreign key constraints, and cascading operations. We'll start our lesson from understanding of referential integrity and potential consequences in case it will be broken. After that, we'll focus our attention on the solution for broken referential integrity and how to avoid this happening in your database. We are going to review what cascading operations are and understand different types of cascading operations. After that, in practice, we are going to configure foreign key constraint. After review of all examples and by the end of this lesson, I am sure you will understand such concepts as data consistency, data integrity, data quality, and data validity. Let's start our lesson. And before we start altering our database table, let's try to understand problems that we are going to avoid. Let's talk about referential integrity. Referential integrity is one of the most important and mandatory property in relational databases that ensures that all references are valid. So, in case one attribute of a relational table references a value of another attribute, then the referenced value must exist. In simple words, valid means that there are no references made by foreign keys to non-existent tuples. And to simplify it even more, if we build relations between tables using foreign keys, we have to be sure that foreign key is referencing to valid and existing data, because otherwise it is not clear how to build relations between entities, in case parent entity is not present in database anymore. Why referential integrity is important? There are different issues that may appear during the corruption of referential integrity, but the root cause of all issues is lost data, because of corrupted integrity. A lack of referential integrity in a database can lead to incomplete data being returned, sometimes even with no indication of an error. This could result in records being lost in the database, because they are never returned in queries or reports. And the consequences might be different. Your existing queries may not return some specific field from other tables during the cross-join queries, and this will produce some system error, because the logic in code is usually built around the data to modify it and to process it. And in case some data is absent, required logic is not triggered. So, I want you to understand that this is not just data consistency issue. Referential integrity potentially may lead to not expected program behavior. Let's review example of a problem and let's try to find a solution for it. Imagine that we have two tables. They are user and role. Each user should have role. It can be either admin or content editor or employee or client. There might be different roles here. But what is important, there is one-to-many relationships between role table and user table. Each user may have only one role, and each role may be assigned to multiple users. And now imagine that we decided to remove content editor role, and we decided to introduce different roles instead: media editor and contributor. We'll not dive deeper in the business domain because anyway, I want you to focus not on the specific business issue, but on the technical one instead. When we removed tuple that contained information about content editor, what shall we do with foreign keys in our user table? They still reference to the tuple that doesn't exist anymore. Do you understand the problem? In case I would need to get role name for all users, what will I get for users that have non-valid reference? This is exactly the problem that is caused by corruption of referential integrity. How to prevent this happening? We need to set up foreign key constraint. Let's understand now what it is. The foreign key constraint is used to prevent actions that would destroy links between tables. A foreign key is a field or collection of fields in one table that refers to the primary key in another table. The table with foreign key is called the child table, and the table with the primary key is called the referenced or parent table. In our particular example, user table contains column with name fk user role. This is exactly foreign key that allows us to build relationships between user and role tables. Now, let's think how we can fix the issue with foreign key constraint and how exactly it will prevent corruption of referential integrity. Let me suggest few ideas how to avoid corruption of referential integrity. The first option is just to forbid removal and update of tuple in case some other tables contains reference to it. In this case, we can't remove content editor role or update its ID until some references exist. The second option is to remove all related records. For example, If I remove content editor role, then keeping content editor users in the system makes no sense, and I also remove related users. Now imagine that instead of removing content editor, you just decided to update it, and you changed primary key and role name. In this case, we update all references with updated primary key. Another option is to set null values instead of all references. You may also consider this option, but again, in this case, you have to have logic in place that process null values that you would receive in response, instead of required data. A null value is a special marker used in SQL to indicate that a data value doesn't exist in the database. In other words, it is just a placeholder to denote values that are missing or that we don't know. And last but not the least is setting default value instead of all references. For example, in this case, when content editor role has been removed, we can set default reference to employee role record. That means that all references to content editor role will be substituted with references to employee role. All these options are called cascading operations. These operations are special kind of database restrictions that describe its behavior in case of removal record from parent table, or in case updating of its primary key. Does it make sense? And today in the lesson, we are going to learn how to set up these restrictions in our table on practice. So, to sum it up, we can configure foreign key constraint on update or on delete of primary key in parent table. Foreign key constraint may be of the following types. Restrict. This restricts any cascading operations. So, we have to make sure first that we removed all references to this table, and only after that, remove or update the primary key in parent table. Cascade. This option will update foreign key in child tables, in case it was updated, and will remove tuple from child table, in case primary key in parent table has been removed. Set null. Based on the name, you can make an assumption what does this option do. It sets null instead of foreign key if the last one was either updated or removed. No action. This is also an option that is possible to choose, but I'm not sure whether you will need it, because the whole idea of foreign key constraint is to set up a constraint, but not just select no action option and ignore things. Set default. You can substitute reference to the foreign key with the default value. While this is also one of the foreign key constraints, you won't be able to find this option in MySQL Workbench. Also, you wouldn't be able to set default option via SQL query, because it is simply not supported by InnoDB storage engine in MySQL. Still, there is a workaround with usage of triggers in MySQL. But we are going to learn how to work with triggers in the separate lesson. And now it is exactly time for the live demo. Let's learn on practice how to set foreign key constraint. In previous lesson we created with you user table. In case you didn't watch that lesson and don't know how to create tables, please watch it. If you have user table, we are good to proceed. For the sake of the demo, we need one more table. Let's create role table now. I already created this table before the lesson to save the time during the video lesson. If you need time to create a table, press a pause for a minute and resume video when you are ready. This table has only two fields. They are ID and role name. That's it. When you created this table, please populate it with values. It is not critically important what would be role name. The main thing here is to have at least few roles for demo purposes. If you wish, you can create the values as I have. And when you added values into the role table, we are done with it. And again, if you don't know how to add values in table via MySQL Workbench, please refer to the previous lesson. Now, we need to establish relationships between role and user tables. If you remember lesson about relational database basic concepts, then you should remember that one-to-many relationships is implemented by adding foreign key into another table. We need to adjust our user table now. I do mouse right-click on the user table and I select Alter Table option. In this view, we need to add one more column for foreign key. There is an agreed naming convention for the name of the foreign key. While you still can name it as you want, I would recommend you to follow the next pattern. FK, that stands for foreign key, followed by underscore, followed by foreign key table name. In our case, foreign key table name is the target table, the current one. Thus, I write user after FK. After that again goes underscore, and this time it is followed by primary key table. That is our source table. In this particular case, this is role table. That's why we have such name for a foreign key column, FK user role. Considering that we use surrogate primary key in role table, we have to use int type for the foreign key column too. When we are done with creation of the column for the foreign key, let's open another tab. I open Foreign Keys tab. This is exactly the tab where we can configure foreign key constraint on the database level. Specify foreign key name. This is just a name for foreign key constraint. In reference table, select the parent table, the table that contains primary key that we are referencing to. And after that, you have opportunity to select the column with foreign key in the current table and specify reference column in parent table. Now, when we configured connection, let me specify foreign key options here. Usually, you can specify constraints on update and on delete operations in parent table. For the sake of the demo, let me set restrict options here. I click Apply button. You also can check SQL query that is going to be executed. Don't worry, when we will come to learning of SQL, we are going to also cover alter table queries, but still, it is good for you to be at least familiar with queries. My concept of teaching databases is to let you understand operations that we need to execute against database and when we need to execute them. This gives my students understanding of end-to-end flow, and when we'll understand this, we'll go to details and we'll learn SQL itself. Hope this approach will also help you to learn the topic faster. In our user table, we have new field now. Let's put foreign keys for each user. Just to help you understand, I add ID of tuple from role table to establish one-to-many relationships. It isn't critically important which one role will be assigned to which user, since this is all fake data. That's why I put IDs in random order here. The interesting thing to demo, in role table we have maximum ID equal to 6. Basically, they are values from 1 to 6. What will happen if I would try to set, for example, value 10 in foreign key column? I put 10 and click Apply. You can see that there is an error because we set to our database something like this. Listen, database, I want to establish relationships between two tables, and this column will be used as foreign key to reference the parent table primary key. And our database listened to us and do what we asked it to do. That's why you can't add reference to non-existent primary key in parent table. Let me open role table. In case I'd like to remove role that participates in relationships with record from another table, I wouldn't be able to do that. I do mouse right-click on the row and select Delete Row. After that, I click Apply button. Database doesn't let me remove the row because we restricted removal. In this case, if we want to remove row with ID 1, we have to remove all references to this record in other tables, and only after that we will be able to remove this row. Does it make sense? So, our SQL query wasn't executed successfully. That's why I click on Execute Query icon here one more time. And here's our row back again. It is still stored in DB. And as always, guys, do not shy to ask questions in comments under this video in case you have any. I always will be happy to answer. Now let's demo another thing. I need to alter user table one more time to demo you another thing. Now in foreign key options I am going to select Cascade. What we expect now? On update, foreign key should be updated. On remove, related record will be removed. Let's get back to role table. In case I updated primary key for one record, it will be updated in another table. Let me open user table now. You also can see that foreign key has been changed once I refreshed table. To refresh table, you need to execute select query that was prepared by MySQL workbench one more time. Let me open role table again. And let me remove the related row. I execute this query. No error so far. And once this query is executed and tuple is removed from parent table, we triggered cascading operation in related table. On delete event, all related rows should be also removed in cascading manner. Let me refresh user table. And you can see that row with the reference to the tuple that we have just removed is also removed. Let's adjust foreign key constraint, and this time we will select set null. Once we applied all changes, I assume you can understand what will happen in case I remove row in parent table or update primary key. The related values in foreign key will be set to null. That's all possible cascading operations that you can perform in MySQL in tables within a DB engine. I will not demo you last foreign restriction that is called no action, because I assume you are smart enough to understand what will happen. And if you want to remove foreign key constraint, just open table configurations by selecting Alter Table one more time, and click Delete Selected on the foreign key constraint, and execute query. That's it. On these examples, I believe you already understood what data consistency and data validity means. In other words, this is nothing more than referential integrity and internal consistency. Data consistency means that there is consistency in measurement of variables throughout the datasets. Data integrity is the overall accuracy and consistency of data. A database can be said to be data consistent when the content under question doesn't give us the chance to infer a contradiction directly or indirectly. Data can be entirely consistent, but entirely wrong. So the phrase data integrity is about the quality of data. Database management systems provide data consistency tools which can help around data integrity. There are other parameters which are used to indicate the condition of data, such as data quality. Data quality is a measurement of the condition of data, considering factors such as accuracy, completeness, consistency. Data integrity is not about data quality. Data quality answers some questions such as meeting the defined standards of an organization. Data quality is a part of data integrity. Data integrity includes all the aspects of data quality and also forces rules. And if we would review one more term like data validity, it is worth to say that this is just an aspect of data quality consistent in its steadiness despite the natural process of data obsolescence, increasing in time. Stay tuned, we'll have a lot of lessons where we'll discuss tools and techniques to ensure the best data quality. That's all for this lesson. Let's recap what we have learned today. In this lesson we have learned what referential integrity is. Now you know what consequences of broken referential integrity are. We learned the concept of cascading operations. On practice activities, we configured foreign key constraint in our tables. I am sure that after this lesson you have clear understanding of what data consistency, data integrity, data quality, and data validity is. Thanks a lot, team, for your attention. Have a great day. See you in the next lesson. Hello dear students, in this lesson we are going to learn indexes in databases. I will explain you what they are and why we need them. Also we will have practice during the lesson. We will create few indexes for our existing tables that we created in previous videos. In the lesson we are going to learn definition of index and I will explain you what it is. On example you are going to understand why we need indexes. Also, we are going to review different index types. They are primary, secondary, and clustering. Also, we are going to have a practice during the lesson. In MySQL Workbench, we are going to learn how to create indexes, configure them, work with different properties, and delete them. And as a summary, at the end of the lesson, we are going to review advantages and disadvantages of using indexes. Let's start our lesson. We are going to start our lesson with definition of indexes. So, what are indexes? Index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. Indexes are used to quickly locate data without having to search every row in a database table every time a database table is accessed. Indexes can be created using one or more columns of a database table, providing the basis for both rapid random lookups and efficient access of ordered records. In a minute I will explain you what lookups are. To understand what is an index? In more simple words, an index is a small table having only two columns. The first column is a copy of the primary key of a table. The second column contains a set of pointers for holding the address of the disk block where that specific related record is stored. In some cases, index is sorted and extract the reference to the record become easier thing to do, and operation is significantly faster, rather than going over each row. Before we move further with learning of indexes in details, I promised you to explain what lookup tables are. In computer science, a lookup table is an array that replaces runtime computation with a simpler array indexing operation. The savings in processing time can be significant, because retrieving a value from memory is often faster than carrying out an expensive computation or input-output operation. The tables may be pre-calculated and stored in static storage. This is something what doesn't require for a separate lesson, but still important for you to know this term. Sometimes you are going to create such lookup tables, or just how they called lookups, in your database. And definitely, indexing will help you significantly improve performance of your app by reducing time of computation to find the value you need. That was a small step aside to make sure you understood all terms I mentioned. Let's understand now in more details what does indexing do and why it is important and deserves for a separate lesson. Indexing is a way to get an unordered table into an order that will maximize the query's efficiency while searching. When a table is unindexed, the order of the rows will likely not to be discernible by the query as optimized in any way, and your query will therefore have to search through the rows linearly. In other words, the queries will have to search through every row to find the rows matching the conditions. As you can imagine, this can take a long time. Looking through every single row is not very efficient. Imagine that you have a list of users in your database, and there are 100,000 of them, and you need to find the user by its email. You can pass user's email as a search query to your database. But to find the row that you need, database will go over each row comparing email in a search query with the actual email in each tuple. How much time will it take to iterate over each tuple? What do you think? Well, believe me, it will take time. Indexing is supposed to improve the performance of the database while reading data from it. Index causes the database to create a data structure. In this data structure, we have a search term and pointer to the actual record in a database. For example, index can be created for email column. In this case, index will consist from the email value and pointer to the tuple associated with this email. Pointer is simply speaking reference information for the location of the additional information in memory. Basically, the index holds the search term and that particular row's home address on the memory disk. Index records comprise search key values and data pointers. Multi-level index is stored on the disk along with the actual database files. As the size of the database grows, so does the size of the indexes. There is an immense need to keep the index records in the main memory so as to speed up the search operations. If single-level index is used, then a large size index cannot be kept in memory, which leads to multiple disk accesses. Multi-level index helps in breaking down the index into several smaller indexes in order to make the outermost level so small that it can be saved in a single disk block, which can easily be accommodated anywhere in the main memory. The index data structure type is very likely a B-tree. What is it? In case you are not familiar with this kind of data structure, I will briefly explain the main points now. While the advantages of the B-tree are numerous, the main advantage for our purposes is that it is sortable. When the data structure is sorted in order, it makes our search more efficient for the obvious reasons. So, the definition of B-tree sounds like this. B-tree is a self-balancing tree data structure that maintains sorted data and allows searches, sequential access, insertions, and deletions in logarithmic time. A B-tree is a balanced binary search tree that follows a multi-level index format. The leaf nodes of a B-tree denote actual data pointers. B-tree ensures that all leaf nodes remain at the same height, thus balanced. Additionally, the leaf nodes are linked using a linked list. Therefore, a B-tree can support random access as well as sequential access. If you want to learn this data structure in details, I have a course where I review different data structures on example of containers in Java. But the general idea is the same. You can check my Java Collections Framework course if you wish. I also explained in details what Big O notation is in that course. Now let's proceed with learning of indexes. I'm going to explain you now different types of indexes. There are 3 types of them. They are primary, secondary, clustering. Primary index in turn may be dense or sparse. Primary index refers to an index stored in sorted order on the sorting key of data stored in blocks. To look up a value, you do a binary search on the index which will produce a pointer to the block, and then you can do a binary search on the data in the block. Let's start from the primary index. Primary index is an ordered file which is fixed length size with 2 fields. And like we have previously discussed, the first field is the same as indexed value, and second is a pointer to that specific data block. We can say that there is always one-to-one relationship between the entries in the index table. You already know from previous slide that primary index may be either dense or sparse. A dense index in database is an index with pairs of keys and pointers for every record. Every key in this file is associated with a particular pointer to a record in the sorted data file. This means that number of records in the index table is the same as the number of records in the main table. Obviously, this type of index needs more space to store index record itself, in comparison with sparse primary index. The sparse primary index is somewhat different. It is an index record that appears for only some of the values in the file. Sparse index helps you to resolve the issues of dense indexing in database management system. Following this indexing technique, a range of index columns stores the same data block address, and when data needs to be retrieved, the block address will be fetched. This is key difference between the dense and sparse index. Let me repeat one more time in other words, and pay attention to the visualization on the slide to understand this better. We have blocks that stores a range of data. Is that clear? And based on the search query, I get access to the block of data. After that, we'll go over data in block linearly till we get the requested data. Also, in comparison to dense index, sparse index stores index records for only some search key values. Thus, its advantage in requiring less space, less maintenance overhead for insertion and deletions. So, as you already understood, sparse index is called so because we need less number of pointers from index to records of database. All records are arranged based on ordered key, and hence, we can quickly access the record by going to block first and then access the following records without having individual index for each of the records. Does it make sense? We are done with primary index. Even in case you have any questions related to primary index, please do not hesitate to ask your questions in comments to this video, and I will be happy to answer. Let's move on. Now let's discuss and learn what secondary index is. The secondary index in database management system can be generated by a field which has a unique value for each record, and it should be a candidate key. If you don't remember what candidate key is, this is a similar term to alternate key. Please review one more time lesson about basic terms in relational databases. Imagine that you have a table of users, and most likely you are going to have ID column that will be used as primary key and primary index for records in this table. But you know that according to your business logic, user may be often requested by email. That's why you decide to create one more index for email. Email column contains also unique values and may be treated as candidate key. Does it make sense? Let me explain now clustering index. If you already understood what primary and secondary indexes are, it will be easy for you to understand clustering index. Imagine that you want to improve performance of reading records, querying them by column that may contain similar values in multiple rows. For example, in the same scenario with users, in case you want to search user by their last name, you should understand that last name may not always be unique. That's the use case of clustering index. In order to identify the records faster, we'll group two or more columns together to get the unique values and create index out of them. Pay attention to this, because it is critically important to have unique search query, and this is impossible to create index on non-unique values. So, you still would need to identify a combination of columns that would give you the unique value for each tuple, and create index based on them. This method is called a clustering index. Basically, records with similar characteristics are grouped together and indexes are created for these groups. I believe we learned enough theory to jump to practice activities. We are going to use our user table that we created in previous lessons. In case you don't know how to create table or want to create similar one, please make sure you watched previous lesson when we created our first table in database. Do mouse right-click over the table and select Alter Table. Select Indexes subtab here. This is the tab that allows us to create, configure, and remove indexes. Each index has name. To create new index, click in an empty row and type any name. After that, select index type. Let me review with you each of these. This is MySQL index types. They are similar from the relational database theory that we have discussed, but definitely these ones have specifics related to MySQL database management system only. Primary index is created by default for each primary key, and you see the one was already created. MySQL creates the index by default for primary key column. You can click on existing index to explore the details. For example, you can learn which column is used to create this index, and column order, ascending or descending. Index type may be used for secondary indexes. That means that values in this column may not be unique. For example, you can see that MySQL automatically created index for foreign key. I didn't do that. This was done by MySQL. Unique index type created for columns with only unique values. For example, if we have unique property set for email column, that means that it is possible to create unique index for this column too. Thus, reading operations from user table using user email in search query will become faster. Full text indexes are used for full text searches. Only the InnoDB and MyISAM storage engines support full text indexes, and only for char, varchar, and text columns. Indexing always takes place over the entire column and column prefix. Also, we can create indexes on spatial data types. MyISAM and InnoDB support R3 indexes on spatial types. Other storage engines use B-trees for indexing spatial types, except for Archive, which doesn't support spatial type indexing. On this slide, you can see the characteristics of different index types in InnoDB storage engine of MySQL. Each index also has different set of properties. Let's review each of them. For string columns, indexes may use only the leading part of column values, using length property. This allows us to create index only for prefixes. Another property that can be used here is a key block size. For MyISAM tables, key block size optionally specifies the size in bytes to use for index key blocks. The value is treated as a hint. A different size could be used if necessary. A key block size value specified for an individual index definition overrides a table-level key block size value. It is not supported at the index level for InnoDB tables. Also, only for full-text indexes you can specify parser. It associates a parser plugin with the index if full-text indexing and searching operations need special handling. InnoDB and MyISAM support full-text parser plugins. If you are interested, you can find more information in official documentation of MySQL about full-text parser plugins. For this specific case, I believe that topic lies outside of the scope of this lesson. Also, you can specify index visibility. You have separate checkbox here. You can place a tick to make index visible, and you can remove a tick to make index invisible. MySQL supports invisible indexes. That is, indexes that are not used by the optimizer. The feature applies to indexes other than primary keys, either explicit or implicit. Indexes are visible by default. After you configured all what you need, just click Apply button and execute generated SQL query. To remove index that you created, do mouse right-click on the index and click Delete Selected. That's it. By this moment in our lesson, I believe you already have both theoretical and practical understanding of indexes. And now we will be able to come up with advantages and disadvantages of indexes together with me. Among advantages of indexing, it is worth to mention the following ones. It helps to reduce the total number of input-output operations needed to retrieve that data. Offers faster search and retrieval of data. So we can say that performance of read operations is increased. And we shouldn't forget about the next disadvantages. Additional disk, memory space needed to store index. Decreased performance of write operations. Slower insert, update, and delete operations. because besides removal of tuple, it is also required to recalculate index to keep it in sorted state. That's all what I wanted to discuss with you today in this lesson. Let's recap what we have learned today. In this lesson, we have learned a lot of interesting things about indexes. We learned what index in database is. I believe that you understood why we need indexes. Also, I put separate focus on the details to help you understand how it works. You also know what B-tree data structure is and how logarithmic big O notation of element retrieval from collection may be achieved. We reviewed different index types. Those include primary, secondary, clustering. I showed you how to create and remove indexes in database. And at the end of the lesson, we have reviewed advantages and disadvantages of using indexes. That's all for this lesson. Thanks a lot for your attention, team. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello dear students, in this lesson we are going to learn more advanced concepts in relational databases. We are going to talk about database normalization and denormalization. Believe me, this is a really important lesson, and knowing the rules that I'm going to share with you in this lesson, you will be able to create scalable database architecture. And also this will help you a lot in your career. We are going to start the lesson from understanding of what data anomalies are. I'm going to explain what insertion, update, and deletion anomaly is. Knowing the problem, we'll learn how to avoid it. And after understanding of basics of dependency theory, we'll jump to our main topic today. I'm talking about normalization and normal forms that we are going to review with examples. And at the end of the lesson, we'll discuss what denormalization is. Let's start our lesson. And before we even jump to discussion of what normalization is, let's understand what problem we are going to address. Let me explain you what data anomalies are. Data anomalies are inconsistencies in the data stored in a database as a result of an operation such as update, insertion, and/or deletion. Such inconsistencies may arise when we have a particular record stored in multiple locations and not all of the copies are updated. Generally, a good relational database design must capture all of the necessary attributes and associations. The design should do this with a minimal amount of stored information and no redundant data. In database design, redundancy is generally undesirable because it causes problems maintaining consistency after updates. We are going to learn such term as normalization later today, but I already can say that normalization can help us to reduce data redundancy and minimize risks of data anomalies. But sometimes we want to add data redundancy on purpose. We need to do this carefully and with clear understanding of why we are doing this and what benefits we expect to get. Redundancy can sometimes lead to performance improvements. We are going to discuss how this may improve our performance when we will talk about denormalization. There are different anomalies. Let's review some of them. I'm going to show you different types of anomalies on example. Let's look at this example first. Imagine that we have a table with suppliers. We also store information about them, like address and products they produce. There is also information about quantity of each product and its price. Is it clear? What do you think about this table? Is it looks good to you? Well, we are going to review in detail what is wrong in such kind of tables. You already see huge data redundancy in this table. Also, I believe we can notice that relationships between key attribute and other data in tuple is not always logical. Let me show you in details what problems may be caused by this data redundancy. And the first anomaly that we are going to learn is insertion anomaly. Imagine that we need to add new supplier. We know its name, we know its address, but we don't know neither products that it produces nor prices for these products. We just started cooperation with them. Our company has been just registered. And what should I put in product, quantity, and price columns? I have to put empty or false data. In this case, I have to paste either null or 0 in different columns. But is this correct? Why I obligated to come up with values for columns that I don't need to use at this moment? What if I just not aware about their products? Or why I have to update this tuple later with information about their products if I just could add new rows with the product? A lot of questions. Another type of anomaly is update anomaly. Imagine that we decided to update supplier name. Probably because of company reorganization, they decided to change their public name. And now we need to execute query to update all tuples where we used supplier's name. And we have really a lot of records where we need to update supplier's name. But what if we accidentally forgot that for some records during insertion we added LTD and for some not? What if accidentally there are different amount of space characters and some records still will be not updated? In this case, I am going to face update anomaly, because after update I will have inconsistent and not valid data. To not accidentally forget to update rows, it would be better if we could organize our database structure in the way when we have only one place where we store supplier's name. Then risk of facing update anomaly is minimal. Let's review deletion anomaly now. This type of anomaly may occur when we remove information, and together with it, we remove information that shouldn't be removed. For example, we stopped cooperation with one supplier, or we need just to remove information about delivery. And in case we remove information about delivery, we lose information about our supplier, and vice versa. All this information is important for our accounting department. We also might need to use this information to create different reports. What we should do in this case? It is a hard question to answer. Do you see what problems may be caused by data redundancy in our table? How to fix this? The best approach to create tables without anomalies is to ensure that the tables are normalized, and that's accomplished by understanding functional dependencies. Functional dependency ensures that all attributes in a table belong to that table. In other words, it will eliminate redundancies and anomalies. Let me show you the solution for our example and what structure would help us to avoid data anomalies. Let's change our tables and create two tables instead of one. We create supplier table and also we create delivery table. In one table, we can store all information related to supplier, and in another table, we are going to store all information related to delivery. And we establish relationships between these two tables to avoid data duplication. For example, for each delivery, there is a specific supplier. Each supplier can have many deliveries. Each delivery is provided by one supplier. Is it clear? In case we want to add information about is it delivery or supplier, we are not obligated to add false information, or information that we don't have at this moment. No dummy values are needed during the insertion. This resolves our insertion anomaly. In case we want to update name of supplier or its address, we shouldn't do this in hundreds rows. We do this in one place, and reference to the supplier is still the same in delivery table. In case we want to remove information about delivery, but don't want to remove information about supplier, we just do so. We can delete tuples from delivery table without losing data from supplier table. Isn't this cool? That's why, to avoid these anomalies, you need to know what normalization is. and its main rules. But before starting learn normal forms and normalization, we need to learn a little bit more theory. Because you need to know at least some key concepts from dependency theory in order you could understand normalization. Dependency theory is a subfield of database theory which studies implication and optimization problems related to logical constraints, commonly called dependencies on databases. The best known class of such dependencies are functional dependencies, which forms the foundation of keys on database relations. And in this lesson we are going to review excerpts from dependency theory. Let's start. And as I already said, one of the main concepts in dependency theory is functional dependency. Functional dependency tells us that if we have two attributes x and y of some relationship, then y is functionally dependent on x. If in any moment of time each x value matches only one y value. X is said to functionally determine y. Functional dependency is a constraint between two sets of attributes in a relation from a database. For example, passport number and last name of the person, employee ID and his corporate email. We can say that there is a functional dependency between these attributes. The determination of functional dependencies is an important part of designing databases in the relational model and in database normalization and denormalization. This is important to understand because during the normalization of our tables, we'll investigate functional dependencies between attributes, and it is crucial to identify which attributes determine other ones. Now, let's understand some more details. Functional dependency between x and y may be called complete functional dependency in case y is determined by all subset of x. And again, I'm trying to simplify these concepts as much as I can, because in case I would tell you definition from the Wikipedia, it wouldn't bring more sense. For example, imagine that you have subset of attributes like place of dispatch, delivery destination, type of cargo, cargo weight. All these attributes determine price of delivery. Agreed? You can easily check this by removing any attribute from the subset and check whether the relationship is still valid. Because in case I remove cargo weight from subset of attributes, then the total price of delivery will be completely different. That's how easily I can check and ensure that there is complete functional dependency between set of attributes and another attribute. Does it make sense? And last but not the least important thing I'd like you to know about functional dependency is clear understanding of transitive dependency. Let me explain. Functional dependency x from y may be called transitive if there are dependencies between x and z and y, but there is no direct dependency between x and y. In this case, dependency will be called transitive. For example, there might be dependency between ID of employee and ID of office where this employee works, and there is another dependency between office ID and number of phone in that office. So, that means that dependency between ID of employee and his office phone number is transitive. Is it clear? Now, when we know what functional dependency is, we are good to proceed with learning of normalization and normal forms. Let's understand first, what is normalization? Database normalization is the process of structuring a database, usually a relational database, in accordance with series of so-called normal forms in order to reduce data redundancy and improve data integrity. It was first proposed by Edgar Codd as a part of his relational model. Another definition of database normalization may sound like this. DB normalization is grouping and/or distribution of attributes between different relationships to eliminate data anomalies during the operations with database, guaranteeing data integrity and consistency and optimization of DB. In the definition of normalization, we used such term as normal forms. What are normal forms? A normal form is a property of a relationship in a relational data model that describes it from the point of redundancy that can potentially lead to mistakes during the data insertion, reading, updating, or deletion. You already know about data anomalies, and you already saw examples. Based on this, I make a conclusion that you understand our motivation to learn normal forms. There are different normal forms. We can say that 3 of them are main ones. But we're also going to hold an overview of different normal forms in this lesson to help you understand this topic better. We are going to review normal forms from the least normalized to most normalized. In database normalization, unnormalized form, that is also may be referred as UNF, also known as normalized relation or non-first normal form. This is a database data model which does meet any of the conditions of database normalization defined by the relational model. Database systems which support unnormalized data is sometimes called non-relational or NoSQL databases. In the relational model, unnormalized relations can be considered as starting point for a process of normalization. It should not be confused with denormalization, where normalization is deliberately compromised for selected tables in a relational database. Normalization to first form requires the initial data to be viewed as relations. In database systems, relations are represented as tables. The relation view implies some constraints on the tables. No duplicate rows. Columns have unique names within the same table. Each column has data type which defines the allowed values in the column. All rows in table have the same set of columns. As you can see, most of the requirements are familiar to us and seems to be logical. But from the theoretical point of view, this is just starting point for our normalization, and a requirement that should be met before we start applying even first normal form. You can see example of unnormalized form on the slide. This table represents a relation where transactions column is itself relation valued. This is valid relation but doesn't conform to first normal form, which doesn't allow nested relations. The table is therefore unnormalized. If this is clear, then let's move on. Let's proceed with learning of basic normal form. The first normal form. A relation is in first normal form if and only if no attribute domain has relations as elements, or more informally, that no table column can have tables as values. But this definition tells us that most relational databases are already in the first normal form by default, because it is impossible to have table value in a relational database. That's why I like another definition of the first normal form. Relationship is in first normal form if and only if each its attribute is atomic. What does it mean? Atomic attribute. This means that in your business domain and in business logic of application, there is no need to extract only specific part of the attribute to perform some operation with it. Let me explain you this on the example. Imagine that you have supplier table, and each supplier has its legal address. This address contains country, city, street, building, office number. But what if your application needs to perform operations with suppliers based on their country location? You need to be able to extract all suppliers from Russia, or all suppliers from India, or Ukraine, or USA. How you can do this with this data model? The only way for you to do this is to extract the whole address, then parse it inside the program and take only country value. That's why we can say that this table violates the first normal form. To make this table meet requirements of the first normal form, we need to introduce new columns in the table. Let's have separate columns for country, city, street, building, and office number. In this case, even when we need to extract suppliers from specific city, we can do this easily by using city attribute as a search parameter. Now we can say that our table meets requirements of the first normal form. Now, it is time for the second normal form. A relation is in second normal form if it fulfills the following two requirements. It is in first normal form, and it doesn't have any non-prime attribute that is functionally dependent on any proper subset of any candidate key of the relation. A non-prime attribute of a relation is an attribute that is not part of any candidate key of the relation. In simple words, you have to store data in the table that relates only to the current entity, but not to another one. All attributes should depend on the whole primary key, especially if this is compound primary key. Attributes should have complete functional dependency with the whole columns in compound key, but not only on its part. This might sound complicated at the beginning, but in real life it is much simpler than you think. Let me show you this on example. I believe it will be easier to understand. Here is the table of items that we sell in our store. We have category, date, discount, and product name. There is compound primary key that consists from category and date. From this table, we can learn discounts that should be applied to goods from specific category at specific date. I believe that based on my explanation, you already understood what is wrong here. Discount depends only on the product category and date. That's it. There is no direct dependency between discount and specific product. Product depends only on the part of the primary key. I mean only on the category. There is a dependency between discount for products from specific categories at a particular date. Does it make sense? Because in this case, we have data redundancy. So, what would be a solution here? The solution here is to make sure that complete functional dependency exists between all attributes and primary key. In our case, product has functional dependency with category, but not with category and date. That's why we create two tables. In the first table, we are going to have information about discount for category in particular date. And in the second table, we are going to store all products. This will allow us to have cleaner DB architecture. Let's learn third normal form. A database relation is said to meet third normal form standards if all the attributes are functionally dependent on solely the primary key without any transitive dependencies. The idea of the third normal form is to not store data in tables that can be retrieved from other table attributes. Imagine that we have a table of tutors at university. We have such columns: ID, last name, title, salary, department, and phone number. Is this table in the third normal form? I don't think so. Let's try to visualize dependencies here. Salary depends on the title only. It doesn't depend on specific person. Specific tutor has its own title and works in concrete department, and they don't have personal work phone numbers. You can contact with them using phone in the department. That's why we can say that there are different transitive dependencies. For example, transitive dependency between concrete tutor, department where he or she works, and phone number. There is transitive dependency between phone number and tutor. Is it clear? To remove all transitive dependencies and make sure that all relations in the third normal form, let's split this data between different tables. We need to create 3 tables to achieve this. Tutor table with last name, title, and department. Title table with title, name, and related salary. Department table with its name and phone. That's it. For some of my students, nothing is changed at the first glance. We just have more tables and relationships between different tables, rather than storing all data in one table in one place. And you need to understand me correct, because you can store everything in one table. This even has its own name, NoSQL. Just to let you know that this is also possible, but you would lose advantages that relational databases offer you. If you opt for relational databases, you need clearly understand what advantage you expect to get from it. That's why the rule of thumb is to follow normal forms. Code later realized that such normal form did not eliminate all undesirable data anomalies and developed a stronger version to address this in 1974, known as Boy's Code normal form. To be honest, there are many other normal forms on top of these that we have just discussed, but in my opinion, these three are the most important ones. I am still going to make a quick overview of other normal forms, at least on the high level, in case you would be interested in more detailed explanation of all other normal forms, or you just have any question related to normal forms reviewed in this lesson, please ask me in comments below this video, and I will be happy to answer you. Elementary key normal form is a subtle enhancement on third normal form. Thus, E, K, and F tables are in third normal form by definition. This happens when there is more than one unique compound key and they overlap. Such cases can cause redundant information in the overlapping columns. A table is in elementary key normal form if and only if all its elementary functional dependencies begin at whole keys or end at elementary key attributes. Boy's Code normal form is a slightly stronger version of the third normal form. If a relational schema is in Boy's Code normal form, then all redundancy based on functional dependency has been removed, although other types of redundancy may still exist. Fourth normal form is concerned with a more general type of dependency known as multi-valued dependency. A table is in fourth normal form if and only if for every one of its non-trivial multivalued dependencies x, y, x is a superkey, that is, x is either a candidate key or a superset thereof. Essential tuple normal form for relations is a relational database where the constraints are given by functional dependencies and joint dependencies. It lies strictly between fourth normal form and fifth normal form. A relation schema is in essential tuple normal form if and only if it is in Boy's Code normal form and some component of every explicitly declared joint dependency of the schema is a superkey. Fifth normal form, also known as project join normal form, is a level of database normalization designed to reduce redundancy in relational databases recording multivalued facts by isolating semantically related multiple relationships. A table is said to be in fifth normal form if and only if every non-trivial joint dependency in that table is implied by the candidate keys. The main key normal form is a normal form used in database normalization which requires that the database contains no constraints other than domain constraints and key constraints. A domain constraint specifies the permissible values for a given attribute, while a key constraint specifies the attributes that uniquely identify a row in a given table. The domain key normal form is achieved when every constraint on the relation is a logical consequence of the definition of keys and domains, and enforcing key and domain restraints and conditions causes all constraints to be met. Thus, it avoids all non-temporal anomalies. Sixth normal form is intended to decompose relation variables to irreducible components. Though this may be relatively unimportant for non-temporal relation variables, it can be important when dealing with temporal variables or other interval data. A table is in sixth normal form if and only if it satisfies no non-trivial joint dependencies at all, whereas before, a joint dependency is trivial if and only if at least one of the projections involved is taken over the set of all attributes of the table concerned. As you see from high-level overview, it might be not so easy to understand the practical need and value of each of these normal forms. To know how to apply those, probably separate lesson is needed for each. But considering the fact that they are not so popular in comparing with the first 3 normal forms, probably I will not cover them in details in this lesson. I strongly recommend you to apply first 3 normal forms during the database architecture and during creation of each table. I might admit that knowing of all other normal forms by heart is not so critical. On the slide you can see comparative analysis. And the last but not the least thing that I wanted to discuss with you today is denormalization. Denormalization is a strategy used on a previously normalized database to increase performance. In computing, denormalization is the process of trying to improve the read performance of a database at the expense of losing some write performance by adding redundant copies of data or by grouping data. Denormalization differs from the unnormalized form in that denormalization benefits can only be fully realized on a data model that is otherwise normalized. So, how we can improve performance? Imagine that we have multiple tables. We have table with soccer clubs. We have table with soccer leagues. And we have table with match data. That should contain information about league, home team, and guest team. We also store a lot of other information about teams and matches. Now imagine that to extract match data for the whole day or week or month, we need to query 3 tables in database for each row. We may have thousands of matches, and not only in soccer. I simplified the original example a bit, but imagine that you have multiple sports and you have teams in different sports and much more leagues. This is literally crazy amount of data each day. Making join queries, finding the mappings in different tables may take some time. While it might be not so dramatic while querying few records, it is different when you query a lot of records. At the end of the day, we are receiving benefits by sorting entities in different tables without any duplication. But when you query thousands rows and do join requests with different tables, this may take some time. And to save time by not querying other tables to get data you need, we add data redundancy on purpose. Do you understand now how better performance of reading operations is achieved? Imagine you need to read all matches data in normalized database, and you query in different tables. And in denormalized database, you request all data from one place. Do you understand the main idea of denormalization? But remember, this is something what should be done super carefully. You need to be sure what benefits you will get from denormalization, and it is recommended to be specific in order you could understand how many seconds you would win in performance after denormalization. I did this several times in my own projects, and I can say that this is technique that really worth of your attention if you are going to use it smart. That's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson we learned what data anomalies are. We have learned insertion, update, and deletion anomalies. Also, we reviewed the main concept in dependency theory. Now you know what complete and non-complete functional dependency is. After that, we learned what normalization is. On examples, we reviewed normal forms. And at the end of the lesson, I explained what denormalization is. That's all for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, today we are going to have a very important lesson. In the lesson we are going to learn basics of structured query language. I am going to explain you what it is and why it is important to know it to work with databases. We'll start from the very basics. We'll learn what SQL is in general, and after that we'll focus on data definition language in SQL. Don't worry, we'll not have only one lesson about SQL. Still, there will be other lessons to learn, but today we are going to build basement for our further learning. In the lesson we are going to learn what SQL is, I will explain what SQL sublanguages are. This will give you insights on what we are going to learn in this course. After holding an overview of SQL language, we'll jump to learning of the first SQL sublanguage. We'll learn data definition language in this video. We'll review different statements with create, alter, rename, truncate, and drop statements. Also, on real examples, you're going to see how we can create these statements and execute them against our database. Enough talks. Let's start our lesson. And to start our lesson, let's understand what SQL is and what we are going to learn in this course. SQL stands for Structured Query Language. It is the main specific language used to manage data held in a relational database management system. SQL was one of the first commercial languages to use Edgar Coates' relational model. The model was described in his influential 1970 paper, A Relational Model of Data for Large Shared Data Banks. Despite not entirely adhering to the relational model as described by Coates, it became most widely used database language. SQL became a standard of an American National Standards Institute in 1986 and of the International Organization for Standardization in 1987. And because standardization of SQL wasn't done since its creation, different relational database management systems invented their own differences. Despite the existence of standards, most SQL code requires at least some minor changes before being ported to different database systems. So, SQL itself is a set of operators that allow us to interact with database management system, query data in it, and perform other operations. These different statements and operators informally can be grouped and classified as different sublanguages. They are data definition language. It is a syntax for creating and modifying database objects such as tables, indexes, etc. DDL statements are similar to a computer programming language for defining data structures, especially database schemas. Common examples of DDL statements include create, alter, and drop. Data manipulation language. This is a set of statements that are used for adding, deleting, updating data in a database. Common examples of DML statements include select, insert, update, delete. Data control language. It is a syntax that is used to control access to data stored in a database. Examples of DCL include grant and revoke statements. And the last but not the least sublanguage is transaction control language. This language groups statements to manage transactions in databases. Among examples of TCL, it is worth to mention commit, rollback, and save point. Based on this, we can make a conclusion that the scope of SQL includes data query, data manipulation, data definition, data access control, transaction management, and managing database objects. In our course on real examples, we are going to learn how to work with different groups of statements. Okay, I believe that now you understand what SQL is and what we are going to learn. And as we announced in the agenda of this meeting, let's start learning DDL now. And we will start from the first statement. It is create statement. The general structure of statement is the following. You write create first. After that, you specify what you want to create, whether it is a database, schema, table, view, index. After that, you put name of the database object that you want to create. And optionally, you can put different options. Let's review a few queries with you. To create database, we need to use the following construct. We start from create keyword. After that, we indicate that we want to create database. And by the way, in MySQL, you can use both options, either create schema or create database. They are similar. After that, we need to specify name of the database. Usually in SQL, we use single quotes for all string values. That's why I put name of our DB in quotes. Basically, this is enough to create a database. But additionally, we can add more things in this statement. we can add a condition to make sure that we wouldn't even try to create table if it exists already. For this, optionally we can add if not exist. And there are different create options that can be specified separately. For example, you know that sometimes we also want to specify char set and collation. You can write default character set followed by char set that you want to use. And after that you can write collate and specify collation that will be used for this char set. Now this is complete query to be executed against database. Let me start sharing my screen to execute this query together with you. I'm going to show you how you can execute SQL queries from MySQL Workbench. If you don't have MySQL Server installed and also you don't have MySQL Workbench on your computer, please refer to the previous lessons where we together installed all required applications for MySQL Relational Database Management System. You can execute any SQL query you wish directly from SQL Editor. Just click on this icon that is called Create New SQL tab for executing queries. A new tab will be opened. Now you can type any query you wish here. To save time during this video lesson, I already pasted here the query we reviewed to create a database. Press a pause for a few seconds if you need to type the query in your SQL editor. One more important thing to mention here is that SQL is not case sensitive. That means that no matter how you would spell create, it would still mean the same. You can write it with capital letters or lowercase. Technically speaking, it doesn't matter at all. But still, there is a common practice to write all SQL keywords with capital letters. If you are ready, let's execute the query. To execute all commands in this SQL file, you have to click this lightning icon. If you want to execute only selected commands, we have to select first SQL instruction and after that click on lightning icon. And if you want to execute only one statement under keyboard cursor, you have to click this icon. I executed query. After it has been successfully executed, I click refresh icon. And I see that new database is created. Let me select this database to make sure that all other queries will be executed against this database. I am going to save each query that we will review today with you in a separate file. In attachments to the lesson, you will be able to find all these queries. Now, let's learn how we can create table. I believe you already understood the general structure of create query. But still, on the slide you can see specifics of create table statement. This query is much more complicated than create database query. We can come up with some different combinations and variations that it will take more than one slide to describe all of them. That's why I would try to share with you the most general and high-level structure of this statement, mentioning the most important things in my opinion. In case you would like to know more details, you can always refer to the official documentation. Basically, we need to write create table, followed by table name. And after that, in parentheses, we have to list all columns with their data types, specifying size for each field if needed. We can specify primary key column name. And if we need, we can create index by specifying its type, column name, sorting, that might be either ascending or descending, and its visibility, just to remind you that it might be visible or not visible. In case you're not familiar with indexes in databases, please make sure you watched previous lesson in this course about indexes in databases. We reviewed all properties of indexes in details there. On the example you can see that after we listed all columns and added necessary properties to columns, we can specify engine type that we want to use for this table. I believe you remember that we can specify char set and collation on different levels. To specify char set and collation on the table level, you can put these statements at the end of the query. That's it. Let's execute real query against database. Here in example you can see SQL create statement that will create a separate table for us with name test table in test database. Pay attention that we separate database name and table name with dot. In case you selected this database in MySQL Workbench, there is no need to specify the full table name to make sure it will be created in the current database. In this case, this declaration is redundant, and you can remove it. Result will be the same. Here's a list of attributes that I wanna have in my table. Next to ID attribute, I specify all properties related to this column. It is of type int, not null, and auto-incremented. First name attribute is of type varchar with maximum length of 45, with null default value, and so on. Primary key is ID column. I create unique index with name email unique for email column with ascending order. And also, I specify engine, charset, and collation. Is that clear? And even in case you have any questions, you can always ask your questions in comments to the video, and I will be happy to answer. Let's execute this query. And we see that query has been successfully executed. After we refresh, we see that test table is created. You already saw how to create index during the creation of the table, but let's imagine that we create a table and we simply forgot to create an index. We still can create index afterwards. Let's learn how to do this. On this slide you can see structure of create index statement. During the creation we need to specify which type of index we would like to create. The difference between these types was covered in the lesson about indexes. You specify index name and on which table and column you would like to create this index. On the slide you can also notice that there might be different index options, index types, algorithm options, and log options. Let's create index for our new table. Just for the sake of example, let's create an index for the first name column. And here on the screen you can see simplified version of create index. I specify name of my new index, table, column in this table, and index option. Let me execute this query. We see the query has been executed successfully, but it is obvious that no rows were affected. To make sure that we really created index we needed, I open Alta table, and on Index tab I can see the new index with my name that I have just created. That's how easily I can create indexes. Also, index might be added as part of Alta table instruction, but we are going to review this later in our lesson, when we'll start learning of Alta statement in details. One of my main goals as a tutor is not just to teach you each possible combination of query, but also I have to teach you how to understand the documentation in order you could easily proceed your self-education. Together we reviewed few queries already. And for example, if you need to create view via SQL, you don't need to open this lesson. You can always open official documentation of specific relational database management system and check the details there. For example, now on the screen you can see documentation page of MySQL. From this page you can find general construction of create view statement and all possible options. We have just reviewed similar ones, and I believe you already understand how to read this syntax by analogy. Press a pause for a minute if needed, or just feel free to explore attachments to the lesson and find this link to the official documentation that I've shared with you. Additionally, if you scroll down a bit, you can also find examples of SQL queries. You can create your own queries for your database and your application by analogy. And at the meantime, let's proceed with another examples. Let's learn now such important statements as alter statements. We use alter statements when we need to update database object No matter whether we need to update database or table, we are going to start query with alter keyword. As you already know how to use documentation, I don't see a lot of reasons to go over each alter statement. I mean, I will not demo you now all possible variations of alter statements. That includes adding columns, adding column properties, changing of char set and collation, and lots more. For the sake of the demo, I will demo only one case with altering table, in order you could understand how it works. Let's adjust this table. We are going to add new column after the first name and adjust first name index to change ordering in there from ascending to descending. I write alter table, and after that I specify the full table name. And after that I put instructions related to my table update. I wanna add column with name last name, with varchar data type, and default null value after first name column. To update index, I need to drop existing index first, and after that to add new index with descending order. Drop command removes index. Let me execute this query. Query is successfully executed. Let's open table now. And here is our new column. We can also check our index. We can see that we have descending order in our index. Basically, that's all what I wanted to share with you regarding alter query. You can rename table using separate statement from data definition language that is called rename. We can easily rename our table to test TB. And after refresh, we see the table name has been changed. One more interesting statement, truncate. We can create statements that will empty all table. We need to add some fake data in it first. For example, let me add just one row in this table. Give me a few seconds. As you see, now we have some data in the table. And when I try to extract all rows from table one more time, I see that my row is in place. If you're interested how to perform such basic operations as data insertion inside Workbench, please refer to lesson about MySQL Workbench. Now we can execute the following statement. Truncate test TB. It should remove all rows in table. And you can see that all rows have been removed. Let's move on. And the last but not the least thing for today that I'd like to show you is drop statements. We use drop statement when we need to remove database object. For example, if you want to remove table or database, you have to use drop statement. Let's review example of deletion of our database. To delete database, we have to execute the following query. Drop database and database name. Everything is simple. According to documentation, you can add if exists check to drop database only if it is present. That's all for this lesson. Let's recap what we have learned today. We have learned a lot of different things in this lesson. Some of them are: now you know what SQL is. After this lesson you know SQL sublanguages. They are DDL, DML, DCL, and TCL. On real examples we learned create statements. Also, I explained alter, rename, truncate, and drop statements. After this lesson you know how to build queries with mentioned statements. That's all for this lesson. Thanks you all for your attention. Have a great day and see you in the next lesson. Hello team, today we are going to learn data manipulation language. We'll learn main statements from DML group of SQL, and we'll review real examples to help you understand how you can apply this knowledge on practice. We'll start our lesson from understanding of select statement. We'll spend significant amount of our lesson learning select statement, considering that this is probably the most popular statement that you are going to use, that has different variations and options that I believe you should know. That includes order by, where clause, distinct, search by pattern, etc. I am going to explain you different operators in SQL that you can use in your queries. We'll review aggregate functions that are often used with select statements. You are going to learn how to group result of select statement and apply condition on it. And also we are going to learn and review other important statements from YAML. You'll see examples with insert, update, and delete statements. Let's start our lesson. During your career as an engineer, you are going to hear very often such acronym as CRUD. It stands for create, read, update, delete. In computer programming, CRUD operations are the 4 basic operations of persistent storage. CRUD is also sometimes used to describe user interface conventions that facilitate viewing, searching, and changing information using computer-based forms and reports. Data manipulation language describes syntax that will allow you to perform CRUD operations on the database layer. Basically, to create, or in other words, to insert rows in tables, to read data from database, or in other words, to select rows that match conditions, to update rows, and to delete rows that you don't need anymore. And the first statement that I'd like to review with you today is select statement. This is really important statement that I believe you are going to use very often. That's why I would like to review different variations of this statement. On the slide you can see how select statement is described in my SQL official documentation. As you can see, it contains really a lot of different variations. Some of them we are going to learn in this lesson. Some of them we will keep learning in other lessons. Let me show you a simplified version of select statement. On this slide you see simplified version of select statements. Let's learn it for now, and we are going to learn even more in practice. You can write select followed by asterisk, from, and specify table name. Asterisk stands for all attributes. This is like mask that is used to extract all attributes of selected tuple. The next thing that you can see on the slide is example of sorting query. It is worth to say that sorting on the database side is faster, rather than extracting unsorted data and sorted in memory of the app. That's why sometimes this query might come in handy, especially when you want to implement pagination. A little bit later we are going to talk about pagination. So, to sort items on database side, you still use the same select statement, but you have to add order by at the end of the query. You should specify column that you are going to use for sorting. By default, sorting is in ascending order. That's why usually you may omit sorting order option if you are good with default sorting. But if you want rows to be sorted in descending order, you have to specify this vividly. You can sort all rows by 2 or more columns if needed. Just list columns that you want to use for sorting separated by comma. Like in the example on the slide, you want to sort all rows by field 1 in descending order and by field 2 in ascending order. Besides selecting all rows with all fields, you can be more specific. For example, after select keyword, you can list fields that you want to extract. Also, you can put where clause and specify select conditions. In this case, we need to select all rows where field 1 has to be less than 10 and field 2 has to be equal to X. I believe you are smart enough to understand that type of data in query should match with data type of the column. You can use logical conjunction keywords. You can use either AND or OR keywords. When you use AND, two conditions will be verified in each tuple, and only those that match two of these conditions will be returned. If you use OR, that means that in case at least one of these conditions is met, we return row. These are not the only logical operators. A little bit later today in the lesson we are going to review other operators too. But I would say that most of the times you would use either AND or OR. Is everything clear so far? Remember that even in case you have any questions, you can always write them in the comments to this video. And if this small piece of theory is clear for you, that means we are good to proceed with real examples and learning of new select statements. Now, let's execute these statements against data in database. And as usual, I am going to save all queries that will be used in this lesson, and you will find them in attachments to the lesson. Having the same queries will allow you to run the same queries on your own computer to understand the topic better. Before we start execute queries, make sure that during previous lessons you also created user table the same as I did. Also, pay attention that we already pasted some information here. I just changed names and emails here to make it look more realistic. Because to be able to see how select statements work, you have to have some data first. So, as you can see, the simplest query is to select all tuples from user table. And it looks like this. Nothing special, agreed? If you want to extract only specific fields, you should list them instead of asterisk, like I did here. In this particular example, I want to extract only first name and last name. Let's sort now fields by last name in descending order, and after that by first name in descending order. That is needed because we already have few rows with the same last name. Thus, sorting only by last name won't be enough, and we have to come up with additional rule for sorting. I add order by keywords and specify columns that I want to use for sorting. Let's execute this query. Now, let's add condition. I'd like to extract all rows where last name is equal to Ivanov. I write where clause and specify condition. And after we executed queries, we received only rows that meet our condition. Regarding operators, in MySQL you can use different operators. As I said, let's discuss operators as a separate topic a little bit later today. But in short, talking about comparative operators, nothing special. You can use more, less, more or equal to, less or equal to, not equal to operators here in condition. One more important thing to show you is distinct keyword. For example, you need to extract all different last names or names from the table without any duplicates. You can use distinct keyword near attribute to receive only different values. Like in this example, when we execute the query, we don't receive any duplicated last names. Does it make sense? Now, let's imagine that you forgot what you are looking for, and you don't remember the search parameter. But you remember that last name of the user is started from if. How to find what you need? You can search by specified pattern with like operator. The like operator is used in a where clause to search for a specified pattern in a column. There are two wildcards often used in conjunction with like operator. The person sign represents 0, 1 or multiple characters. The underscore sign represents one single character. In our specific case, when we want to find all rows where last name is started with if and we don't know the full last name, we need to use person sign. Look at this query. By this I am telling that after if, there might be different number of characters. Let's execute this first query. and you can see that I have 2 tuples returned. In other query, I am saying that there is one character that is followed by we, and after that we have different amount of characters, and I don't know how much exactly of them. Is that clear? Let's learn what pagination is and what we need to know to support pagination on the database level. Pagination is a method of dividing web content into discrete pages, thus presenting content in a limited and digestible manner. Google search result page is a typical example of such a search. If you downloaded applications that I created for my students for mobile phones, Learn IT, you can find example of pagination in the history. If you have a lot of tests and certifications passed and you open history inside the app to explore your previous results, you can scroll test results, but not all test results extracted from the database at once. They are loaded in chunks after you scrolled to the lowest record. I extract records from a database by small chunks, instead of extracting all related records at once. Do you understand? Imagine that you have 100 or even 1000 test results, but you need to check on the few last ones. In this case, is there any sense to extract all rows and pass them from the server into the mobile app? Definitely not. That's why during the design of our app, we foresee that we need pagination support here. And to be even more specific, in mobile apps, this is called infinite scrolling. This allows you to scroll content down without any interruption. Infinite scrolling is a functionality allowing users to scroll down a massive amount of information, presenting it in easy-to-consume chunks. And data is uploaded as you reached the lowest record on the screen. I am sure you're faced with such design while using other apps. In database, we can support pagination by extracting specified range of records with the help of limit operator. The SQL limit clause restricts how many rows are returned from a query. The syntax for the limit clause represents how many records you want to retrieve, and starting from which record. For example, you can use the limit clause to retrieve the top 5 users by number of coins. Or you could extract users starting from the 6th position to 10th, sorted by number of coins. The limit clause is only compatible with the SQL select statement. You can't use a limit clause in SQL update statement, for instance. Your limit number must be positive. Say you want to retrieve records from the bottom of the list. You should use the SQL order by statement to order them in descending order. Then you should use a limit statement. Let's learn how to work with limit statement on practice. We have 3 records here. Let me extract 2 users sorted by email in ascending order. I write select all from user order by email, limit 2. The last part, limit 2, means that it would return me 2 records only. Let's execute this query, and you can see that records with ID 3 and 4 have been returned. But as we have already discussed, we can specify offset via additional parameter. In the second example, offset is 1, so we are skipping the first one returned, and we return 2 records after the first one. Does it make sense? So we return 2 records after skipping the first record, basically from the second position of our ordering. And now, when we execute this query, we have records with ID 4 and 1 returned. Is it clear for you why this is happening? And when you implement queries for your app, you can build them accordingly. For example, you can pass to the server parameters of pages that you want to retrieve and number of records, and paste them into the query. Anyway, this is not the topic of this lesson. It is just a hint. We'll learn how to implement this when we'll start learning of web application development. As of now, I want you to know and remember how to work with limit statement. The next thing that I'd like to review with you is querying the null attributes. This is minor thing to learn, but still very important. And a lot of my students do the same mistake when they just start using SQL. If you want to select tuples that have null value in some of the attributes, you can't just use equal operator. Let me show you. If you want to select users that have null value in the FK user role field, you can't just use equal operator, because it won't give you results that you expect. Instead, you have to use another keyword. You have to use isNull or isNotNull. This is specifics that you should be aware of, so please don't forget about this. We already reviewed few examples and I believe you understand how to work with select statements. But still, another thing that we need to learn is different operators. Definitely, there is no sense to hold live demo of select statement on real data with each possible operator. Instead, probably there is a sense to learn different operators now. I will also provide you with examples of how to apply different operator. Let's start from the first group of operators in SQL, arithmetic operators. Basically, there is nothing special, and no signs that you didn't learn in elementary school. The only exclusion is modular operator probably. But if you are familiar with one of the most popular programming languages, then you already know that usually person sign is used for operations to extract remainder after division. If you need few more seconds to review examples, please press a pause. Let's continue. Another group of operators that we are going to review is comparison operators. Most of them are also familiar to you. Probably not equal to operator may look like the new one for some students. Basically, the general rule is not equal to operator is written like this. But also, in some relational database management systems, it is also possible to use another syntax of not equal to operator that is more similar to one that we use in programming languages. And on this slide you can find logical operators. We already reviewed such logical operators as AND, OR, like. But as you can see, there are more of them. Look through the table on the slide. Press a pause if needed. And ask questions in comments to the video in case something is still not clear here. Now, let's learn aggregate functions. Again, we'll use them with select statements. That's why I believe it is better to review them in conjunction with select statements. An aggregate function performs a calculation on a set of values and returns a single value. Except for count, aggregate functions ignore null values. Aggregate functions are often used with the group by clause of the select statement. And here on the slide you can see product table examples that I'm going to use for the explanation of the following aggregate functions. Let's start from the learning min and max. Based on the name of these aggregate functions, I believe it is easy to understand that the first one returns minimal value in the column and the second one returns the maximum value in the column. And on the slide you can see example of queries executed against table with products. We extract max and min price. The next aggregate function is count. The count function returns the number of rows that matches a specified criterion. You can also find query example on the slide. The average function returns the average value of a numeric column. The sum function returns the total sum of a numeric column. Is everything clear? Let's learn now group by keywords that are often used together with aggregate functions. The group by statement groups rows that have the same values into summary rows. It is often used with aggregate functions. The group by statement groups rows that have the same values into summary rows. It is often used with aggregate functions like count, max, min, sum, average to group the result set by one or more columns. Let's review this on real demo. We are going to demo group by statement on example of user table. Let's find the most used last name among our users. We know that last name in our app is not unique, and we want to understand how much users used the same last name. I want to select total count of all rows and display this count as a mount attribute, and also I want to extract last name from user table and group results by last name. Let's execute this query. You can see that we have two people with Ivanov last name and one user with Komarohov last name. And in the result set, count has been returned as a mount column. When I wrote this query, I used this alias automatically. Because when you use aggregate functions, you also want that column would have meaningful name. The syntax is simple. You use as keyword and specify the desired attribute name. SQL aliases are used to give a table or column in a table a temporary name. Aliases are often used to make column names more readable. An alias only exists for the duration of that query. An alias is created with the as keyword. In MySQL, I usually omit as keyword and use alias straight away. We grouped our result by last name and managed to receive a result like this. Hope that this is clear now. Another interesting thing that when you used group by keywords, you can apply condition to groups. To do this, you have to use having keyword. In very simplified words, having is the same as where in regular select statements. The difference is that you can't apply where after group by statement, because where is applied for each tuple while reviewing each record, whereas having may be applied to the group of tuples once we iterated over records in table. Where clause introduces a condition on individual rows. Having clause introduces a condition on aggregations. Does it make sense? From DML language, we have few more important statements to learn. Let's learn insert statement. Basically, this statement is used to insert new record in a table. The general structure of insert statement looks like this. Insert into table name, list of columns where you want to insert values. After that goes values keyword and list of values. This is the most common syntax of insert statement. But definitely, there is also a way to make simple things more complex. Just joking. But indeed, there might be different variations of insert statements. In attachments to the video you will find link to the official documentation about insert statement in MySQL. The next things that you have to remember about insert statements. Insert specifies the table where data will be inserted into. We can omit column. If a column is omitted, each value must be provided. If you include in columns, they can be listed in any order. Values specifies the data that you want to insert into the table. Values is required. Inserting an empty string into a varchar or text column inserts a single space. All trailing spaces are removed from data inserted into varchar columns, except in strings that contain only spaces. These strings are truncated to a single space. If an insert statement violates a constraint, default or rule, or if it is wrong data type, the statement fails, and SQL Server displays an error message. Let's insert few rows in our user table. On the screen you can see example of insert query. We want to insert two records. Pay attention that one record has FK user role value specified, and another record doesn't have. The number of values should match the number of columns we listed. Let's execute query. Insert statement returns us the number of how many rows have been impacted after execution of this query. We impacted 2 rows in total. Now we can select all rows in our user table and make sure that we inserted 2 records. Is it clear? If yes, then let's proceed. The update statement is used to modify the existing records in a table. The general query structure looks like this. You start with update keyword, after that specify table name. After set keyword, we need to list pairs of column name and related value, separated with comma. Optionally, we can specify where clause to select rows that we want to update, and we can apply limit. The where clause, if given, specifies the conditions that identify which rows to update. With no where clause, all rows are updated. If the order by clause is specified, the rows are updated in the order that is specified. The limit clause places a limit on the number of rows that can be updated. In our example, we decided to change email for our user and assign a new role for him. In example, you can see that I assign a new value to email attribute and to FK user role attribute. I use where clause to update only 1 row. I have unique identifier in this table. That's why in where clause I use ID. Let me execute this query. Update statement also returns the number of updated rows. We successfully updated 1 row. We can check our table to make sure that email and foreign key value is changed. If everything is clear, then let's move on. And the last but not the least for today, delete statement. The delete statement is used to delete existing records in a table. One important thing to mention here is that in case you would omit where clause, you would remove all records from the table. So be very attentive with this query. According to documentation, you can also use order by and limit keywords. In our example, we decided to remove 1 row. Here is how query look like. I specified ID of the row that I want to remove. Let's execute this query. And you can see in logs that delete statement also returns number of rows that were impacted with this query. That's all I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson we learned select statements. I showed you select statements with different options, including selecting rows with order in, where clause, distinct selection, search by pattern, limit the number of rows to be returned, grouping, and applying condition on groups. We learned different SQL operators. Now you know what aggregate functions are and how to work with them. I showed you how to work with aliases in SQL. And also, we discussed insert, update, and delete statements. That's all for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, in this lesson we continue and learn SQL, and we'll focus on such important group of queries as join queries. Considering the fact we are dealing with relational databases, very often we have to create join queries to multiple tables. And also we are going to review a few more SQL statements that I didn't cover in previous lesson, and that are too small for a separate lesson. In the lesson we'll put our focus on join SQL statements. We are going to review different types of join queries. That includes inner, left, right, cross, and full auto joins. I also prepared examples for each case to review with you. You will be able to find all examples that we'll review in this lesson in attachments to the video. Also, we are going to learn union keyword and understand how it works. And at the end of the lesson, I will teach you how to construct queries with subqueries. Let's start our lesson. I believe that you already understood that in relational databases we split data between different tables and apply normalization to avoid data redundancy. This means that to extract data that you need, sometimes you need to execute so-called join queries against not one but multiple tables instead. Join query combines columns from one or more tables into a new table. ANSI standard SQL specifies 5 types of join: inner, left order, right order, full order, and cross. Let's learn how these joins look in theory, and after that we'll review practice examples. Further examples will be shown considering these two tables, user and role. Pay attention that user table contains foreign key to role table, and also there are users without roles, and also there are roles that are not assigned to any user. The same tables I have in my SQL. We created those during the previous lessons. If you want to repeat queries after me, make sure you have the same tables. The best visualization of join queries is these two circles. These circles represent the set of records that exist in two tables. Basically, you can see that one table is on the left and another table is on the right. Pay attention that these two circles have intersection. Those are exactly records that can be mapped between each other. In simple words, the area inside these two circles is called inner join. Area that includes space without intersection is called left and right order join. Anyway, we are going to review each of join type on real examples and one by one. And let's start from inner join. You can imagine it as intersection between two tables. An inner join requires each row in the two joined tables to have matching column values. That is exactly the moment when we'll use our foreign keys to establish connections between tables. Inner join creates a new result table by combining column values of two tables based upon the joined predicate. Imagine that we have two tables. They are A and B table. The query compares each row of A with each row of B to find all pairs of rows that satisfy the join predicate. When the join predicate is satisfied by matching non-null values, column values for each matched pair of rows of A and B are combined into result row. SQL specifies two different syntactical ways to express joins: the explicit join notation and the implicit join notation. The implicit join notation is no longer considered a best practice, although database systems still support it. The explicit join notation uses the join keyword, optionally preceded by the inner keyword to specify the table to join, and the on keyword to specify the predicates for the join. Today we are going to review different query examples. I save all of them. You will be able to find those in attachments to this lesson. Let me show you a demo of inner join query. Just to remind you, here is how our user table looks like. Not all users have role. And here is how our role table looks like. There are roles that are not assigned to none of the users. Is that clear? Now, let's select last name and role name of all users with their roles. We will not take into account users without roles and roles without users. I write select fields that I need, and pay attention, I use tables aliases to specify which field from which table I want to extract. After that, I write from user table, and pay attention, I specify alias here. U is just a character that seems for me to be good as an alias for this table. Basically, U last name in our query is a reference to the last name field in user table. Is it clear? After that, I write join keyword. As we discussed, I can omit inner keyword and specify table that I want to join. Again, alias for role table is specified next to the role table name. And after that I need to specify what rule will be used to map records into different tables. That's why I write on keyword and specify the rule. ID field from role table should match with the FK user role field from user table. If you followed the course and you didn't miss previous lessons, you should remember that FK user role is a foreign key. Now I am sure that this query will return us valid information. Let's execute it. And we see two rows returned, only last name and role name, like we requested. Any questions so far, team? In case of any questions, please write them in comments below this video. Now let's discuss ordered joins. So, how this ordered joining works? The joined table retains each row, even if no other matching row exists. All ordered joins subdivide further into left joins, right joins, and full ordered joins based on which table's row you would like to retain. How to understand where is left and where is right table? It depends on which side from join keyword table name is specified. The result of left ordered join or simply left join for tables A and B always contains all rows of the left table, even if the join condition doesn't find any matching row in the right table. This means that if the onClose matches 0 rows in the right table for a given row in the left table, the join will still return a row in the result, but with null in each column from the right table. A left-ordered join returns all the values from an inner join plus all values in the left table that do not match to the right table, including rows with null values in the link column. Is it clear? The same principle applies to the right-ordered join, but in this case we return all records from inner join plus all records from right table, even if they don't match to any record in left table. And the last type of ordered join is full ordered join. Conceptually, a full ordered join combines the effect of applying both left and right ordered joins. And rows that don't have mapping in other table will have null values in result set. Let's now review these types of joins on real example. Let's start from the left join. Basically, we would take the same query that we reviewed during the inner demo and we'll add left keyword. Let's execute it now and see what will be returned. And you can see that we received all last names from our user table. That is on the left from join keyword. And for records where any match wasn't found in role table, we just return null. That's called left join. Right join would look opposite way. In this case, we return all role names even if we don't have users assigned to this role, because role table is on the right from join keyword, and this is right join query. Does it make sense? Now, let me show you cross join. We just remove predicate and leave only join keyword. Taking into account we have 4 records in user table and 4 records in role table, we are going to receive in total 16 records. Basically, each record from one table should be mapped with each row from another table. We receive all possible combinations of records from each table. To be honest, this type of query is interesting to know from theory side, but probably it has limited areas for using in business cases. It is rare thing when you need to find combinations between all records from 2 tables. And the last but not the least type of join is full ordered join. In MySQL, it can be implemented with the help of union keyword. What is union keyword? It combines 2 queries in one single query to the database. In our case, we need to combine 2 queries with 2 joins, left and right. And you can see that I connect 2 select statements with union keyword. Let's execute this query. And we can see that we received all 4 records from user table and all 4 records from the role table, even despite not all records have mapping. Does it make sense? Hope that now with this example things become clearer. And we also learned how union works. Usually, union is used when you are dealing with some archived data. When you query the main table, an operational or table with archived data. Regarding joins, important things to know that in this way you can join 2 and more tables. This will become important when you will come to the homework task. Imagine that you are dealing with many-to-many relationships. In this case, you have 3 tables that you need to connect between each other. This will be part of your home task. I will also provide you with solution to the home task, but I just want you to solve this task by yourself first. The only one more topic that I'd love to discuss with you today is subqueries. This topic is too small for the separate lesson, but still important to know. I want to explain subqueries. What if you would like to create condition with the result of another query? You can do so with the help of subqueries. A subquery is a SQL query nested inside a larger query. A subquery is also called an inner query or inner select, while the statement containing a subquery is also called an outer query or outer select. The inner query executes first before its parent query, so that the results of an inner query can be passed to the outer query. You can use a subquery in a select, insert, delete, or update statements. A subquery is usually added within the where clause of another SQL select statement. In our particular example, let's imagine that we want to extract users who have value in money column more than average money value across all users. Before you would be able to execute this kind of query, let's make small adjustment in our tables. I need to add money column and fill it out with data. To make your life easier, I prepared a script for you that would add new column and populate it with data. I am going to leave the reference to this script in attachments to this lesson. If you follow the course and you have the same structure, script will be executed without problem. Pay attention to the data type of money column. 15 means the amount of decimal digits and 2 means that only 2 digits after point will be supported, considering math rounding rules. Okay, so once you executed this script, your user table should look like this. Now, let me demo you how subquery works. We create regular select statement. We want to receive rows where money is more than average money amount on accounts of all users. For this, I need to execute this subquery first to understand the amount of money that can be used in my order query. I put subquery in parentheses. Let's execute this query. Average money amount with this specific test data will be around 564. And we have 2 rows returned with money amount higher than average money amount. Do you understand now how you can work with subqueries? That's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson we learned what joins are. After that we focused on different join types. We learned inner, outer, cross joins, and reviewed SQL queries. Now you know how to work with union keyword. And at the end of the lesson we learned how to work with subqueries. That's all for this lesson. Thanks a lot, team, for your attention. Have a great day. See you in the next lesson. Hello team, in this lesson we are going to learn some new concepts in relational databases. I will explain what use, triggers, stored procedures and stored functions are. Also you will understand why we need them and how to work with them on practice, because today we'll have practical part 2. So be prepared for interesting lesson. We are going to go over each topic one by one. And when we'll focus on practical examples of use, triggers, stored procedures, and stored functions, I am going also to explain you some new syntax features. Like for example single line and multi-line comments in SQL, session variables. Also I will show you how you can change delimiter between SQL statements in MySQL. Let's start our lesson. And the first thing that I'd like to review with you in this video is view. Let's understand first what is view in databases. Views are virtual tables. They are only a structure and contain no data. Their purpose is to allow a user to see a subset of the actual data. A view can consist of a subset of one or more tables. What might be the reasons for creating views? There might be different reasons. Among advantages of using views, it is worth to mention. Restrict the view of a table. For example, you can create a view that contains not all fields, but only some of them that don't have any sensitive data. So you can hide some of columns in tables. In larger organizations where many developers may be working on a project, views allow developers to access only the data they need. Join two or more tables and show it as one object to user. Instead of constantly writing join queries, you can create view for most often joins and let user to watch the whole attributes as one database object. This also simplifies life of developers. Restrict the access of a table so that nobody can insert the rows into the table. Is everything clear so far? Let's look at examples. Hope you watched previous lessons because in this lesson we are going to use tables that were created during the course. We are going to create view with you and configure it for our needs. We'll create view from MySQL workbench. I am going to show you SQL queries that will create view for us. Just to remind you, we have two tables here, user table and role table. Here how they look like. Let's create view with user email and role name, because this is the data that I use most often in my app. During the login, I use user email, and also I need to understand user role to use this information for further redirection inside our app. That's why it might be a good idea for me to create this view and simplify life of developers to let them query this view directly instead of creation of join queries. And I believe you understood that this is a simple example with two tables only. But in real life, you might create tables that use join queries to 5 or even more tables. We are going to start simple. And let's create this view for 2 attributes from 2 tables. To create the view in MySQL workbench, I can click on the Create View icon. Technically speaking, MySQL workbench just helps us with one line of create view statement. And after as, we need to specify SQL query for our view. I click Apply button. And I execute this query. Now we create our view. And you can find it here under Views in MySQL workbench. Basically, you can perform select operations against this view the same as you do against the table. In select statement, you just use view name. Let me now update original tables. For example, let's paste one more record in user table with role assigned. When row is added, let's execute select all query to our view one more time. And you can see that view is also updated. Isn't that cool? And you don't need constantly write join statements. Pay attention that I can't add new rows here in view. So, as we discussed, we often use views for select statements. That's all what I wanted to share with you regarding views. Is it clear? Even in case you have any questions, please add them in comments below this video, and I will be happy to answer. Let's proceed with a new topic. Let's learn what triggers are and how we can use them. A trigger is a set of instructions that are automatically activated in response to a specific event occurred on a table in the database. A trigger is always associated with a particular table. If the table is deleted, all the associated triggers are also deleted automatically. A trigger is invoked either before or after the following event. Insert, when a new row is inserted. Update, when an existing row is updated. Delete, when a row is deleted. When you submit for execution an insert, update, or delete statement, the relational database management system fires the corresponding trigger. Always remember that it can't be two triggers with similar action time and event for one table. For example, we can't have two before update triggers for a table, but we can have before update and before insert trigger, or before update and after update trigger. Let's review the structure of the create trigger statement. We write create trigger first. Trigger name should be unique. After that, we specify whether trigger should be activated before or after some event occurred. Then we need to specify on which event we want to activate our instructions, either on insert, update, or delete, in which table. After that, we can specify for each row. This specifies a row-level trigger. For example, the trigger will be executed for each row being affected. We can add trigger order. This option might be useful if we have chain of triggers and we need to control their order. And after all this, we need to describe trigger body. That is exactly a set of instructions that are needed to be executed. Is everything clear? Let's look at our practical demo and create one trigger as an example. We are going to come up with some imaginary business case. Imagine that before inserting new record in user table, we want to check that in case there is no value specified for our foreign key, FK user role field should be populated with value 6. Yes, I know that for such purpose we can set up default value for field. But I want you to focus on the syntax right now, and I just want to present you syntax as simple as possible without overcomplicating business logic. So, pay attention to the syntax and my comments as we go. There is one more syntax specifics. You can see that I specified another delimiter, double ampersand. Usually, we use the semicolon to separate two statements when writing SQL statements. A MySQL client program, such as MySQL Workbench, uses the delimiter to separate statements and execute each statement separately. However, for example, a stored procedure or trigger consists of multiple statements separated by a semicolon. And if we use MySQL Workbench to define a trigger, like in this case, that contains semicolon characters, the MySQL client program will not treat the whole stored procedure create statement or the whole trigger create statement as a single statement, but many statements. Therefore, we must redefine the delimiter temporarily so that we can pass the whole trigger description to the server as a single statement. That's why I set new delimiter at the beginning of this statement and returned it back to default at the end of the statement. To execute multiple statements, we can place trigger body between begin and end keywords. Basically, you can put here update, insert, delete statements. You can address those statements to any table you wish. And also, you can make conditions like I do here. I write if followed by predicate, some expression that returns either true or false. In this particular case, before inserting new value, I verify that new value that is going to be inserted is null. Within the trigger body, we can refer to columns in the subject table. That is the table associated with the trigger. By using the aliases alt and new. Alt and column name refers to a column of an existing row before it is updated or deleted. New and column name refers to the column of a new row to be inserted or an existing row after it is updated. Does it make sense? In the if block, we can write any statements we wish. Considering that we override delimiter, we can use semicolon here to separate statements between each other. And at the end of the statement, I should specify and if. Once I declared all statements in trigger body, I should close trigger body with and keyword. And as we already discussed, I want to return delimiter back to default. Let's execute this statement. and I see that query has been executed successfully and trigger is created. You can check all existing triggers and update them via MySQL Workbench. Do mouse right-click on the table and select Alter Table. And under Triggers tab, you can find all existing triggers. To delete trigger, you can click mouse right-click and select Delete Trigger. You can move the order of triggers here if you have multiple triggers. Duplicate triggers if needed, and so on. Let's see how trigger works. So, I add new record and deliberately leaving FK user role attribute empty. Let me apply changes. And after changes applied, you can see that 6 has been added by default. So, before insertion, my trigger set the value to the record that I was about to add, and only after that insertion happened. And I received result like this. In conclusion of triggers discussion, it is worth to mention some drawbacks of using triggers. The main problem with triggers are: they are completely global. If you create a trigger to react on an insertion event, that means that this rule will be applied to any kind of insertion event without possibility make an exclusion, at least sometimes. Logic on database layer. Remember that creating triggers on the database layer, you bind your logic to specific database, and in some degree detach your business logic from your app. While triggers not always contain business rules and may be important piece in supporting of data consistency in database, this is not always the case. And in case you make decision migrate to another database management system, it may become a pain to not lose any important operation that were described in triggers. Triggers are stealthy. By saying this, I mean that it is easy to forget they are there until they hurt you with unintended and very mysterious consequences. All this doesn't mean that you should never use triggers. You just need to be aware about this potential impact and use triggers carefully and wisely. If everything is clear, let's move on. Now, let's talk about stored procedures. Let's learn what are they and how to work with them. A stored procedure is a prepared SQL code that you can save so the code can be reused over and over again. So, if you have a SQL query that you write over and over again, save it as a stored procedure, and then just call it to execute it. You can also pass parameters to a stored procedure so that the stored procedure can act based on the parameter values that is passed. So, what advantages of stored procedures? Performance. The SQL Server stored procedure, when executed for the first time, creates a plan and stores it in the buffer pool so that plan can be reused when it executes next time. Reusable. Stored procedures can be executed by multiple users or multiple client applications without the need of writing the code again. It can be easily modified. We can easily modify the code inside the stored procedure without the need to restart or deploy the application. Security. Stored procedures reduce the threat by eliminating direct access to the tables. We can also encrypt the stored procedures while creating them so that source code inside the stored procedure is not visible. Reduced network traffic. When we use stored procedures, instead of writing SQL queries at the application level, only the procedure name is passed over the network instead of the whole SQL code. In stored procedures, we can pass in and out parameters. There are 3 types of parameters that we can pass in stored procedures. They are in, out, and in-out. In is an input-only parameters, which provide values to the storage procedure. In addition, the value of in parameter is protected. It means that even if you change the value of the in parameter inside the stored procedure, its original value is unchanged after the stored procedure ends. In other words, the stored procedure only works on the copy of in parameter. An in parameter passes a value into procedure. The procedure might modify the value, but the modification is not visible to the caller when the procedure returns. Out is output-only parameters, which return values from the stored procedure to the calling program. The value of an out parameter can be changed inside the stored procedure, and its new value is passed back to the calling program. An out parameter passes a value from the procedure back to the caller. Its initial value is null within the procedure, and its value is visible to the caller when the procedure returns. In-out is an input and output parameters which provide values to and returns values from the stored procedure. This is a combination of in and out parameters. It means that the calling program may pass the argument, and the stored procedure can modify the in-out parameter and pass the new value back to the calling program. An in-out parameter is initialized by the caller, can be modified by the procedure, and any change made by the procedure is visible to the caller when the procedure returns. For each out or in-out parameter, pass a user-defined variable in the call statement that invokes the procedure so that you can obtain its value when the procedure returns. If you are calling the procedure from within another stored procedure function, you can also pass a routine parameter or local routine variable as an out or an out parameter. If you are calling the procedure from within a trigger, you can also pass new column name as an out or in-out parameter. The parameter list enclosed within parentheses must always be present. If there are no parameters, an empty parameter list should be used. Parameter names are not case sensitive. Each parameter is an in parameter by default. To specify otherwise for a parameter, use the keyword out or in-out before the parameter name. Don't worry, if you are not feeling confident about understanding of different parameter types, we are going to have demos soon, and it will be easier to understand with examples. If you understood the theory of stored procedures and why we need them, let's hold the demo. Let's create a simple procedure. Our procedure will select user by email. You already know why I set different delimiter in my SQL query. The reason is the same as an example with triggers. Here is an example with in parameter. Important thing to remember. Pay attention that name of the parameter and name of column in where clause should be different, in order server would understand where you refer to parameter and where you refer to the column. After that, I write begin keyword. And after that goes stored procedure body, where we can specify our instructions. When procedure body is finished, we use end keyword. Now we can easily execute this stored procedure with the help of call keyword and passing the email parameter. In case we wouldn't pass email parameter, we would see error that would tell us about wrong number of parameters. And here is record with the correct email has been returned. Do you understand how to create stored procedure and how to call it? As you can see, there is nothing complex in this, but probably few questions still in your head. How to work with out and in-out parameters, correct? As I promised you, let me show a practical example with these types of parameters. Let's create procedure now that will return us average amount of money in out parameter. As you can see, I vividly specify that this is out parameter. And after that, inside procedure, I use into keyword to store the result into the out parameter. Is that clear? You should be familiar with this query. This is aggregate function that we reviewed in a separate lesson. So, in case you want to learn more about average and aggregate functions, feel free to review previous lessons. In the same way, we create this stored procedure. And now, let's learn what is different during the invocation of this stored procedure. When we call our stored procedure, we pass so-called session variable as a parameter to receive returned value, because we need a reference to the variable to retrieve a result of a stored procedure execution. A session variable is a user-defined variable that starts with @sign, doesn't require declaration, can be used in any SQL query or statement, non-visible to other sessions, and exists until the end of the current session. And after that we can refer to this variable to get value that was recorded into it. I use simple select statement. Does it make sense? Is it more clear now? Hope that with this example it is more clear how to use our parameter. It looks like that I have one more parameter type to show. Let me show you example of in-out parameter. In this example we are going to implement counter stored procedure. This procedure will take input parameter, will increase it by the specified amount, and will return us the value. In the body of our stored procedure we'll increment our counter. That's it. Let's look how we work with this kind of stored procedures. I declare a session variable and initialize it with some value. After that I call my stored procedure a few times by passing the same session variable and increment value. After all this I can read my session variable to find that it was incremented. That proves that the state of our counter session variable was modified multiple times. Is everything clear? And by the way, I have never showed you before how to work with comments in MySQL. Probably there just were no need in this. There are different types of comments that you can use in MySQL. First kind of comment that you can see here is double dash. The comment must be at the end of a line, your SQL statement, with a line break after it. This method of commenting can only span a single line within your SQL statement and must be at the end of the line. Another type of comment is similar to the previous one, just one more syntax of a single line comment, started with a number sign. Also you can use multi-line comment. In multi-line comment you should specify where a comment is started and where it is finished. I'm not showing you how to alter and drop stored procedures, because it is similar to dropping and altering other database objects. Just click mouse right click on stored procedure that you are interested in. Well, that's it regarding this example. And now let's talk about functions and understand how they are different from stored procedures. A function in MySQL is a program that is used to perform an action such as complex calculations, for example, and returns the result of an action as a value. Does it look like something similar to you? Something what we have just discussed? You are not the only one who wants to understand the difference between stored procedure and functions in SQL. Wait for a minute, and I will explain you in details what exactly the difference is. There are two types of functions available in MySQL. They are system-defined functions and user-defined functions. We'll discuss system-defined functions in a separate lesson. The function which is defined by the user is called a user-defined function. MySQL user-defined functions may or may not have parameters that are optional, but it always returns a single value that is mandatory. The returned value, which is returned by the MySQL function, can be of any valid MySQL data type. Regarding parameters in function, everything is much simpler than in stored procedures. You don't have different types of parameters like in, out, or in-out. All parameters in functions registered as in parameters. Now, let's review high-level syntax of create function statement. First of all, specify the name of the stored function that you want to create after create function keywords. Secondly, list all parameters of the stored function inside the parentheses, followed by the function name. And as we have discussed, by default all parameters are the in parameters. We can't specify in, out, or in-out modifiers to parameters. Third thing to do. Specify the data type of the return value in the returns statement, which can be any valid MySQL data type. Fourth, specify if a function is deterministic or not, using the deterministic keyword. A deterministic function always returns the same result for the same input parameters whereas a non-deterministic function returns different results for the same input parameters. If you don't use deterministic or not deterministic, MySQL uses the not deterministic option by default. Fifth, write the code in the body of the stored function in the begin end block. Inside the body section, you need to specify at least one return statement. The return statement returns a value to the calling programs. Whenever the return statement is reached, the execution of the stored function is terminated immediately. Let's look at the demo of functions now, and after that we will sum the differences up. In our example, let's create a function that can identify user status based on the amount of money he or she has. The function will take money as method argument. It will return value of varchar data type. This is deterministic function. We declare a variable, and depending on the amount of money, we initialize this variable with one or another value. And at the end of the function body, we return the value. Is everything clear here? Please press a pause if you want to look at all lines more thoroughly. We execute this SQL statement, and we have function created. You can easily list and review all functions that exist in the database like this. Show function status and specify the database. We can see that in our database only one function is declared so far. Let's invoke it now. And you can already find one more difference between stored function and stored procedure. Different from a stored procedure, you can use a stored function in SQL statements wherever an expression is used. This helps improve the readability and maintainability of the procedural code. In our example, I want to extract last name of user, money amount, and get result of my function for each record. You can see that I invoke function here and pass money value to it. Let's see what we'll get. And you can see that as a result, we get what we expected. Function has been applied to each record and returned us correct status for each user. Do you understand now how to create and execute function? If yes, then it is great. Now, when you saw functions and stored procedures, let's summarize what are differences between them. There are numerous differences between stored procedures and stored functions. Let's review the most important ones. The function must return a value, but in stored procedure it is optional. In a procedure, we can return 0 or n values. Functions can have only input parameters for it, whereas procedures can have input or output parameters. Functions can be called from procedure, whereas procedures cannot be called from a function. The procedure allows select as well as insert, update, delete statements in it, whereas function allows only select statement in it. Procedures can't be utilized in a select statement, whereas function can be embedded in a select statement. Stored procedures can't be used in the SQL statements anywhere in the where, having, select section, whereas function can be. An exception can be handled by try-catch block in a procedure, whereas try-catch block can't be used in a function. We can use transactions in procedure, whereas we can't use transactions in function. I believe that we captured and reviewed main differences. That's all for this lesson. Let's recap what we have learned in the video. Today we have learned what views are. We created our custom views based on our existing tables. I explained you what triggers are. Now you know how to create and work with stored procedures. As we reviewed examples, we learned different types of commands in SQL, delimiter in MySQL, and session variables. At the end of the lesson, we have learned functions, and we learned differences between functions and stored procedures. That's all for today. Thanks a lot for your attention. Have a great day. See you in the next lesson. Hello team, in this lesson we are going to learn database administration. We're going to learn how to configure users, grant them necessary rights to perform actions in database, how to track database performance, manage data export and data import. Definitely, this lesson is going to be interesting and useful for you. In this lesson, I am going to do a lot of screen sharing. On the example of MySQL Workbench, I am going to show you how easily you can perform such basic operations as data import, export, new user creation, configuring the role and access for new account, and tracker MySQL Server performance. Let's start. And as I already said, today we are going to have a lot of demo examples and screen sharing. So let me start sharing my screen. Let's start from learning data export and data import. First of all, I want to show you few menus and tabs in MySQL Workbench. Here we have Administration tab, and under Management section you can find Data Export and Data Import options. Also, you can click on Server menu to find Data Export and Data Import options. Why we need this? For example, you need to configure local database and populate it with necessary data from production environment. Either for local development, debugging, or any other purpose, you do data export in one place and do data import in your local database. Or imagine that you developed your app and created database structure, and now it is time to go live and move to production environment. And as an example, let's imagine that we need to do export of our learning database and all data that we created during the previous lessons. I click Data Export, I need to select Database, and when I select a database, I can select tables that I want to export. Now pay attention here. If I want to initialize my database in production environment, and I don't need test data at all, I have few options here. Namely, I can dump structure only. If you need both data and structure, you can select the options that will tell MySQL to dump data and structure. Below you can find checkboxes that allow you to indicate whether you are ready to export stored procedures, functions, triggers, events. Below you can find checkboxes that allow you to indicate whether you wanna export stored procedures, functions, triggers, events. In export options, you can specify project folder for the dump. In case you would specify project folder, each table will be exported as a separate file. In case you select export to a self-contained file, all instructions will be exported to a single file. Pay attention that on my screen, and probably on yours too, it is not possible to investigate all possible configurations. Just resize widgets, like I do here, to see all menus and buttons. You can enable creation of dump in single transaction and include create schema too. After you configured everything you need, just click Start Export button. After export is finished, you can find the results of your export in the destination that has been configured. The result of the export is nothing more than SQL instructions that create database objects and insert data in tables if needed. Now, let's import data into our database. Select Data Import. Specify either project folder with your SQL queries, or select Radio button to specify self-contained file. You can select schema from where to import data, or create a new one. This is needed for cases if your SQL instructions that you are going to import don't contain create schema statement. After that, just click Start Import button. And that's it. Do you understand how to export and import data now? Let's now learn how to create users and grant them privileges. In Management section, I click on User and Privileges. Here you can see list of user accounts. As you can see, there are some accounts already created. Let's learn what are they. One part of the MySQL installation process is data directory initialization. During data directory initialization, MySQL creates user accounts that should be considered reserved. MySQL info schema localhost, used as a definer for information schema views. Use of the MySQL Info Schema account avoids problems that occur if a database administrator renames or removes the root account. Use of the MySQL Info Schema account avoids problems that occur if a database administrator renames or removes the root account. This account is locked so that it can't be used for client connections. MySQL Session Localhost. Used internally by plugins to access the server. This account is locked so that it can't be used for client connections. MySQL sys localhost. Used as a definer for sys schema objects. Use of the MySQL sys account avoids problems that occur if a DBA renames or removes the root account. This account is locked so that it can't be used for client connections. Root localhost. Used for administrative purposes. This account has all privileges and can perform any operation. Strictly speaking, this account name is not reserved, in the sense that some installations rename the root account to something else to avoid exposing a highly privileged account with a well-known name. But what to do in case we need to create a new user with a separate set of privileges? There might be different cases. For example, you need separate account for development purposes, and you need to restrict some rights for it. Or you create database account for your application, and you deliberately want to keep only read rights. Does it make sense? To create new user, click Add Account here. We can change name of new account. Select authentication type. For the standard login, password authentication, select standard. Let's come up with a password. You can even configure account limit. For example, amount of queries that can be executed per hour. Max number of connections, concurrent connections. You can check this tab to explore more. Administrative roles tab, in my opinion, very important one. You need to grant privileges to new account. In other words, you need to specify what new account can and can't do in the database. You can select one or more predefined roles. Or you can select privileges manually. It is only up to you. And on the last tab here in Schema Privileges, you may set privileges related to schemas. You can add rules for all schemas, schemas that match the provided pattern, and concrete schemas. By the way, you can grant and revoke privileges even after you created user account. After you configured everything, just click on Apply button. And user will be created. So, we created account with select privileges only. Let's now establish new connection using our new credentials. And let's try to drop some table. And you can see that when I tried to drop a table, the command wasn't executed. Command was denied for my user, but I still can select any information I need from this schema. Is that clear? Can you understand now how privileges work and how to configure them? The last thing that I'd like quickly to show you is how to track performance of MySQL server in MySQL Workbench. There is a separate section here that is called Performance. You can open Dashboard and track performance in real time. On the dashboard, you can find Network Status, MySQL Status, and InnoDB Status. When you have queries executed, you would see that these charts will be different, and you can see some measurements here. There are separate widgets that allow you to track status of InnoDB storage engine. Most of the metrics and widgets are self-describing. And if you followed this course, there is nothing new for you. You should already know what InnoDB is, what SQL statements are, what select, insert, create, update, alter means. That's all what I wanted to share with you in this lesson. Let's recap what we have learned today. In this lesson, we learned how to make data export. Also, you saw example with data import. We created new user with you. We configured global privileges for it and also configured schema privileges. And at the end of the lesson, I showed you performance dashboard in MySQL. That's it. Thank you all for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we are going to review very important theoretical concepts of data modeling. This lesson will be useful for everyone, no matter whether you architect or database engineer. We need to learn and understand the basic concepts of data modeling on different levels and different phases of our project. The fundamental understanding of these processes helped me to save a lot of time and avoid a lot of mistakes and rework in the past. That's why I believe it is super important me sharing this with you. We are going to learn such terms as data model, data context, database design. I will explain you why data modeling is super important, and I will provide you with tools and algorithms to ensure efficient process on your project. And after that, we are going to dive into specifics of different data model types and review those with examples. Namely, we are going to discuss conceptual data model, logical data model, and physical data model. By the end of the lesson, you are going to have clear understanding about each type of data model and differences between them. Let's understand first what data model is. A data model is an abstract model that organizes elements of data and standardizes how they relate to one another and to the properties of the real-world entities. For example, a data model may specify that the data element representing a car be composed of a number of the elements, which in turn represent the color and the size of the car and define its owner. The term data model can refer to two distinct but closely related concepts. Sometimes it refers to an abstract formalization of the objects and relationships found in particular application domain. For example, the customers, products, and orders found in manufacturing organization. And other times it refers to a set of concepts used in defining such formalizations. For example, concepts such as entities, attributes, relations, or tables. So, the data model of a banking application may be defined using the entity relationship data model. A data model explicitly determines the structure of data. The next term is related to the previous one. Database model. What is a database model? A database model is a type of data model that determines the logical structure of a database. It fundamentally determines in which manner data can be stored, organized, and manipulated. The most popular example of database model is a relational model, which uses a table-based format. A database model refers to the logical structure, representation, or layout of a database and how the data will be stored, managed, and processed within it. It helps in designing a database and serves as blueprint for application developers and database administrators in creating a database. You are more or less already familiar with relational data model. So, relational data model is an approach to managing data using a structure and language consistent with logic, where all data is represented in terms of tuples grouped into relations. And we learned already different types of relations in a separate lesson. There are three main groups of data models. They are logical, conceptual, and physical. In this lesson, we are going to learn all of them and understand the difference between them. But before we even try to understand the difference between different groups of data model, let's make sure that we all understand the importance of data modeling and try to understand motivation that stands behind this lesson. Data modeling is the process of creating a visual representation of either a whole information system or parts of it to communicate connections between data points and structures. The goal is to illustrate the types of data used and stored within the system. the relationships among these data types, the ways the data can be grouped and organized, and its formats and attributes. Why we need data modeling? Can we live without it at all? Well, hard to answer objectively, but in my opinion, we can't live without data modeling during the development of our app. It is only a matter how you will come up with a data model for your app, but you will spend some time on data modeling for sure, and it will be done in one or another way. And what I would like to explain in this lesson is to give you standardized tools and approaches for data modeling, because creating proper data model for your whole app it is a super important task, and sometimes it is hard just to create few tables straight away and start using specific data structures and build your code around identified dependencies. If you still can't understand how it is important, think about it also from different angle. Usually, development of web application is performed by multiple developers. It can be 2 engineers, in case this is early stages of a startup, and it can be significantly more engineers if you already have proof of concept and about to start feature development. Now imagine that lack of database design and pure data modeling cause rework of one or even multiple features. How much money will you spend on salary of engineers to change also code that was built around this data model? Definitely there are techniques of clean code architecture and introduction of abstraction layer in your app that minimize rewriting of all persistence layer. So definitely this won't be like dramatic impact. But still, sometimes changes in business model mapping may impact business logic and the way how you interact with data inside your app and how you process it. The ability to correctly identify the business entities and the way we wanted to model those relationships is pivotal to good information quality. Most teams and organizations opt for physical modeling and create application-specific schemas that often lack the high-level vision for how the business really needs to utilize its data. Also, there is one more related term. It is database design. What is it? Database design is the organization of data according to a database model. The designer determines what data must be stored and how the data elements interrelate. Database management system manages the data accordingly. Database design involves classifying data and identifying interrelationships. This theoretical representation of the data is called an ontology. The ontology is the theory behind the database's design. In order to perform data modeling in an efficient way, we need to have clear understanding of data context. You can treat data context as a puzzle where a puzzle piece is a data entity. If you would like me to be not so specific in concrete terms, but define an abstraction, instead of data entity, we can use any other terms. So, as piece of puzzle, you can use any concept or important thing for business about which we want to collect data. And in order to get the pieces to fit together, you need to understand the proper relationship of the piece in question to the other puzzle pieces. A conceptual data model is the picture on the puzzle box that provides the vision of what the information puzzle should look like at the end of the day, regardless of whether your solution is a data warehouse, ERP, master data management, or anything else. Now, let's learn what a conceptual data model is. A conceptual data model is a diagram identifying the business concepts, or like we usually call them, entities. Also, this type of data model identifies the relationships between these concepts in order to gain, reflect, and document understanding of the organization's business from a data perspective. It shows how the business world sees information. It suppresses non-critical details in order to emphasize business rules and user objects. It typically includes only significant entities which have business meaning, along with their relationships. A conceptual data model usually takes the form of an entity relationship diagram or object role model. The conceptual data model typically does not contain attributes, or if it does, only significant attributes. It is important to mention that the conceptual data model is technology and application independent. The conceptual data model should reflect relationships from a historical, longitudinal perspective. For example, a relationship between store and employee may usually be considered as one-to-many, but when viewed from a historical perspective, perhaps the relationships may actually be many-to-many. What if the employee begins work at another store? Why conceptual data model is important, and what issues you may encounter in case you skip phase of conceptual data model design. You may be constantly stumbling through without conceptual data model, but you won't see the big picture. It is hard to identify and understand all possible relationships that are required and miss important things when you are down in the details of developing a new system from scratch, especially when you work on some complex enterprise solution. The three basic tenets of conceptual data model are entity, a real-world thing, attribute, characteristics or properties of an entity, relationship, dependency or association between entities. Conceptual data model example. Customer and product are two entities. Customer number and name are attributes of the customer entity. Product name and price are attributes of product entity. Sale is the relationship between the customer and product. As you can see, this is not like super detailed vision of data model, and definitely this is not ready-to-use database that is built with the specifics of database management system. A logical data model is a data model of a specific problem domain expressed independently of a particular database management product or storage technology. But nevertheless, logical data model is visualized and described in terms of known data structures. For example, logical data model may be described via relational tables and columns, object-oriented classes, or XML tags. Sometimes in the literature you may find that it is referred as logical schema. Logical database design describes the data without any details of how exactly this data will be physically implemented in the database. Among logical data models, it is worth to highlight the next ones. Hierarchical database model. It is the oldest form of database model. It was developed by IBM for information management system. It is a set of organized data in tree structure. DB record is a tree consisting of many groups called segments. It uses one-to-many relationships. The data access is also predictable. Network model. It is a database model conceived as a flexible way of representing objects and their relationships. Its distinguishing feature is that the schema, viewed as a graph in which object types are nodes and relationship types are arcs. It is not restricted to being a hierarchy or lattice. Relational model. This is probably one of the most popular data models nowadays, where all data is represented in terms of tuples grouped into relations. Entity relationship model describes interrelated things of interest in a specific domain of knowledge. A basic ER model is composed of an entity types which classifies the things of interest and specifies relationships that can exist between entities. You can see that on diagram it is super easy to understand relationships between entities because of readable way of depicting all connections and their types. Object model. It is a database management system in which information is represented in the form of object as used in object-oriented programming. Object databases are different from relational databases, which are table-oriented. Object-relational databases are hybrid of both approaches. Document model. This is data storage system designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data. And if you remember our lesson about overview of different database management systems, then you should remember that document model is probably one of the main data models that is used during the design of NoSQL database. Entity Attribute Value Model. It is a data model to encode in a space-efficient manner entities where the number of attributes, properties, parameters that can be used to describe them is potentially vast, but the number that will actually apply to a given entity is relatively modest. Such entities correspond to the mathematical notion of sparse matrix. Star schema. It is the simplest style of data mart schema and is the approach most widely used to develop data warehouses and dimensional data marts. Logical data model is as opposed to a conceptual data model, which describes the semantics of an organization without reference to technology. Logical models are often diagrammatic in nature. When are they used? Usually, they are most used in business processes. Once validated and approved, the logical data model can become the basis of a physical data model and form the design of a database. The term logical data model is sometimes used as a synonym of domain model or as an alternative to the domain model. While the two concepts are closely related and have overlapping goals, a domain model is more focused on capturing the concepts in the problem domain rather than structure of the data associated with that domain. The logical data model is used to define the structure of data elements and to set relationships between them. The logical data model adds further information to the conceptual data model elements. The advantage of using a logical data model is to provide a foundation to form the base for the physical model. However, the modeling structure remains generic. The next thing that we are going to learn today is to learn more about group of physical data models. Let's start from the definition. A physical data model is a representation of a data design as implemented or intended to be implemented in a database management system. Do you feel already the difference between conceptual and logical data models? In the life cycle of a project, it typically derives from a logical data model, though it may be reverse engineered from a given database implementation. A complete physical data model will include all the database artifacts required to create relationships between tables or to achieve performance goals such as indexes, constraint definitions, linking tables, partitioned tables or clusters. Physical database design represents how the actual database is built. In the first lesson of my course about databases, we learned the most popular database management systems. Please refer to that lesson if you want to check specific names of database management systems. There are two main physical data models: inverted index and flat file. Inverted index, that is also referred to as a posting file or inverted file, is a database index storing a mapping from content, such as words or numbers, to its location in a table, or in a document, or in a set of documents. In this course you also can find a lesson about indexes and how to work with them. In that lesson we discuss specifics of interaction with index from its creation till its removing. The purpose of an inverted index is to allow fast full-text searches at a cost of increased processing when a document or just a new tuple is added to the database. So, basically the performance of reading and searching data will be better and will be executed faster. But on the other hand, operations of insertion will take more time. That is because after adding additional row or tuple, indexes needed to be recalculated to stay sorted and ensure logarithmic big O notation for extracting operations. The inverted file may be the database file itself rather than its index. It is the most popular data structure used in document retrieval systems, used on a large scale for example, in search engines. On the other hand, a flat file database is a database stored in a file called a flat file. Records follow a uniform format and there are no structure for indexing or recognizing relationships between records. This file is simple. A flat file can be a plain text file or a binary file. Relationships can be inferred from the data in the database, but the database format itself does not make those relationships explicit. The term has generally implied a small database, but very large databases can also be flat. If you want an example of a flat file database, you can imagine linear stores of NoSQL data. A physical data model describes a database-specific implementation of the data model. It offers database abstraction and helps generate the schema. The main difference between logical database design and physical database design is that logical database design helps to define the data elements and their relationships, but physical database design helps to design the actual database based on the requirements gathered during the logical data design and conceptual data design. We learned what conceptual data model, logical data model, and physical data model is. To help you understand better the difference between all of these, I want to present you the current slide. So, let's recap in one sentence about each type of data models. Conceptual data model. This data model defines what the system contains. This model is typically created by business stakeholders and data architects. The purpose is to organize scope and define business concepts and rules. Logical data model defines how the system should be implemented regardless of the database management system. This model is typically created by data architects and business analysts. The purpose is to develop technical map of rules and data structures. Physical data model. This data model describes how the system will be implemented using a specific database management system. This model is typically created by database architects and developers. The purpose is actual implementation of the database. A conceptual data model identifies the highest level relationships between the different entities. Features of conceptual data model include the important entities and the relationships among them. No attribute is specified, no primary key is specified. A logical data model describes the data in as much detail as possible, without regard to how they will be physically implemented in the database. Features of logical data model include all entities and relationships among them. All attributes for each entity are specified. The primary key for each entity is specified. Foreign keys. Keys identifying the relationship between different entities are specified. Normalization occurs at this level. The steps for designing the logical data model are as follows. Specify primary keys for all entities. Find the relationships between different entities. Find all attributes for each entity. Resolve many-to-many relationships. Normalization. You can learn more about normalization from other lessons in the course. This is also a very important topic, and I dedicated a lot of time and attention to it. Physical data model represents how the model will be built in the database. A physical database model shows all table structures, including column name, column data type, column constraints, primary key, foreign key, and relationships between tables. Features of a physical data model include specification of all tables and columns. Foreign keys are used to identify relationships between tables. Denormalization may occur based on user requirements. If you don't know what denormalization is, please refer to the lesson about normalization and normal forms. In scope of that lesson, I also described what denormalization is. Physical considerations may cause the physical data model to be quite different from the logical data model. Physical data model will be different for different database management systems. For example, data type for a column may be different between Oracle and DB2. and also there might be other differences. The steps for physical data model design are as follows. Convert entities into tables. Convert relationships into foreign keys. Convert attributes into columns. Modify the physical data model based on physical constraints, requirements. That's all what I wanted to share with you today. We learned a lot of important and interesting things today. Let's review what we have learned. In this lesson, we learned what data model and database model is. We discussed what database design is. Also, we discussed and understood importance of data modeling process. After this lesson, you know what data context is. We reviewed and learned 3 main groups of data models. They are conceptual, logical, and physical data models. Thanks a lot, team, for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, in this video we are going to review with you your home tasks. The tasks that I'm going to share with you are supposed to help you learn and understand SQL topic better. If you are students of my Java from Zero to First Job course, you should already know that during the course we work on creation of our own online shop. We also need to have a database to support main operations in our online shop. That's why in today's homework we are going to have e-commerce terminology. Anyway, I believe this will be interesting for you, because the home tasks that I would ask you to implement are closely related to real-life examples. And the first thing that you need to do is to make sure that you have all necessary tables to execute queries from your home tasks. To help you create all necessary tables faster and populate data there, I prepared special script for you that you just need to execute in your database. Just open this link, copy the script, and execute it in your database. Once this script will be executed, you will notice that 5 tables created in your database. Take your time to explore those tables, their structure, and data in them. Pay attention to the type of the relationships between different entities. Once you have all necessary tables and data in it, we are ready to proceed with home tasks. The first task is to select distinct emails of users who made at least one purchase. Basically, nothing is complex here. This query would require to create join query to 2 tables, purchase and user. The second task would be to create SQL queries that will select product names and purchase ID for each purchase. Third task, to create SQL statement to select credit card and product name. You should select credit card that was used for purchase of the specific product. One more task is to select last name of user and total amount of purchases made by this user. This is going to be a really interesting one. Select last name of user and total amount of purchases made by this user only for users who made 2 or more purchases. And the last but not the least task is to select total amount of money user already spent in our store. As you can see, I tried to come up with real-life business cases. By implementing these queries, you will be able to practice your knowledge in aggregate functions, join queries, grouping the results, applying different conditions, and so on. Don't hurry up to check my solution. Try to take your time and come up with your solution first. Try to create queries by analogy. Because during the course we already created similar queries. In some tasks from the list you may need to have multiple joins. Press pause, and once you are done with your solution, resume the video. And let's compare my and your solution. In the first task, I use distinct keyword to extract only distinct user emails. I use join statement to make join query on purchase table. To make sure that I extract only users that have associated record in purchase table, I use foreign key in purchase table to map records between 2 tables. Here we have one-to-many relationships. That's why there is no need in the third table, and we can easily implement this relationship with the help of foreign key in purchase table. Does it make sense? Is everything clear so far? And by the way, team, as always, in case you have any questions, please do not hesitate to put your questions in comments below this video, and I will be happy to answer those. Second task is almost similar to the first one, in terms that we create join statement to two tables only. We need to extract information about product, and we can extract it from product table. And to verify in which purchase this product was purchased, we need to check this in purchase product table. In the third task, we need to create multiple joins. Why? Because we need to extract credit card value that is stored in user table and product name that is stored in product table. But to identify which user bought which product, we need to query purchase table. Because in purchase table, there is an info about users' purchases. But to understand which product has been purchased in scope of which purchase, we need to query purchase product table. Because there is many-to-many relationships between product and purchase. Each purchase may consist of multiple products, correct? During the one session, I can buy laptop and separate keyboard, for example. And each product may be purchased many times. We have hundreds of the same keyboard. Or we have hundreds of similar laptops. That's why to implement many-to-many relationships, we need the third table. And in this particular case, we also need to include it in our join statement to get information that we need. We need to specify conditions that will allow us to map records between different tables, including product table. And when we execute this query, we receive what we expect. In the fourth task, we are going to use aggregate function to count total number of purchases made by each user. After we made select statement to retrieve required information from user and purchase tables, we need to group results by each user. In this particular example, I want to group result by last name. You can use aliases if you wish, but probably you already noticed that I use them in all my queries because I used to them, and I find this comfortable. When query is executed, we use user's last name mapped to the total amount of purchases he or she made in our online store. In the fifth task, we are going to use the same query as in fourth task with small addition. We need to add conditions that will have only records that we need. That's why after group by, I write having clause to leave only users that have more or equal to 2 purchases. Is it clear? In the sixth task, we also use aggregate function. This time we need to find total money amount spent in our online shop by each user. For this, I use sum aggregate function to sum price of all products that have been purchased by our user. And the same logic we have discussed is applied here. We need to make multiple joins to map all records between each other to extract information we need. In this example, I group result by user last name. Basically, that's all my solution, and that's all homework review. Hope that this video was helpful for you to recap knowledge learned in this course. And as I already said, feel free to ask questions in case of any. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, I'm happy to announce that today we start super important topic. We are going to learn JDBC. Definitely it will be hard to learn all JDBC topic in one single lesson, but today we are going to learn basic concepts about JDBC, understand what it is, and have first practical exercise to establish connection to the database from our Java program. Since this is our first lesson about JDBC, we'll start from JDBC overview to help you understand what it is and why we need it. After that, we are going to review different JDBC driver types. To make sure you understand more about database connectivity, I believe it is important to review and learn what ODBC is. I want to make sure that after this lesson you understand how JDBC works. After this theory piece, we'll jump to practical exercises. We'll learn how to add JDBC driver into the Java app. We'll establish with you connection to the database to make sure that our environment is ready for the next lessons. We have a lot of things to learn today. Let's start. Let's start today from understanding of what JDBC is. JDBC stands for Java Database Connectivity. JDBC API implementation used for connecting to a particular type of a database. It is a standard Java API for database-independent connectivity between the Java programming language and a wide range of databases. In simpler words, it is a set of classes and interfaces that allows Java programs to send SQL statements to a database. Why this is needed? Imagine that you have a lot of different Java programs, and also you have a lot of different relational database management systems. The question is, should we use unique application programming interface of each relational database management system to perform operations with it, different protocols and other specifics? For example, unique methods for establishing connection, unique way to execute SQL queries, unique way to read and modify resulting records, and so on? No way. That's why community come up with API standard for Java applications to interact with databases, namely set of interfaces, set of methods. And once community agreed on the JDBC API, each provider of relational database management system provided own implementation of JDBC driver. So, JDBC API is just a standard set of APIs, interfaces, and JDBC driver is a concrete implementation. Is it clear? And this become area of interest of database providers to create implementation of JDBC API because Java gained a lot of popularity and common unique solution was needed in order Java could interact with database management system provided. There are different JDBC driver types. Let's review each of them one by one. The first type that I'd like to describe contains a mapping to another data access API. It is a database driver implementation that employs the ODBC driver to connect to the database. The driver converts JDBC method calls into ODBC function calls. Logical question from your side would be, what is ODBC driver? And this is a good question. ODBC stands for Open Database Connectivity. It is a standard application programming interface for accessing database management systems. The designers of ODBC aimed to make it independent of database systems and operating systems. An application written using ODBC can be ported to other platforms both on the client and server side, with few changes to the data access code. ODBC was originally developed by Microsoft and Simba Technologies during the early 1990s. The driver is platform dependent as it makes use of ODBC, which in turn depends on native libraries of the underlying operating system the JVM is running upon. Advantage of this type of driver is obvious. Almost any database for which the ODBC driver is installed can be accessed, and data can be retrieved. Regarding disadvantages of this type of driver, it is worth to name the following ones. The ODBC driver needs to be installed on the client machine. Performance overhead, since the calls have to go through the JDBC bridge to the ODBC driver, then to the native database connectivity interface. Thus may be slower than other types of drivers. Specific ODBC drivers are not always available on all platforms, hence, portability of this driver is limited. No support from Java version 8. The second type of JDBC driver is an implementation that uses client-side libraries of the target database. It is also called a native API driver. The driver converts JDBC method calls into native calls of the database API. For example, Oracle OSI driver is a type 2 driver. Regarding advantages, we can say that performance is better than a type number 1 driver. That is because there is no implementation of JDBC or DBC bridge. But it also has numerous of disadvantages. Some of them are: the vendor client library needs to be installed on the client machine. Not all databases have a client-side library. This driver is a platform dependent. Type number 3 uses middleware to convert JDBC calls into database-specific calls, also known as a network protocol driver. The middle tier application server converts JDBC calls directly or indirectly into vendor-specific database protocol. This differs from the Type 4 driver in that the protocol conversion logic resides not at the client, but in the middle tier. Like Type 4 drivers, the Type 3 driver is written entirely in Java. Advantages of this type of driver are the following ones. Since the communication between client and the middleware server is database independent, there is no need for the database vendor library on the client. The client need not to be changed for a new database. The middleware server can provide typical middleware services like caching of connections, query results, etc., load balancing, logging, and auditing. A single driver can handle any database provided the middleware supports it. Among disadvantages of this type of driver, we shouldn't forget about the next ones. It requires database-specific coding to be done in the middle tier. The middleware layer added may result in additional latency, but is typically overcome by using better middleware services. Type 4 connects directly to a database by converting JDBC calls into database-specific calls. The JDBC Type 4 driver, also known as the direct-to-database pure Java driver, is a database driver implementation that converts JDBC calls directly into vendor-specific database protocol. Written completely in Java, Type 4 drivers are thus platform-independent. They install inside the Java virtual machine of the client. This provides better performance than the Type 1 and Type 2 drivers, as it doesn't have the overhead of conversion of calls into ODBC or database API calls. Unlike the Type 3 drivers, it doesn't need associated software to work. Advantages are: completely implemented in Java to achieve platform independence. These drivers don't translate the requests into intermediary format, such as ODBC. The client application connects directly to the database server. No translation or middleware layers are used, improving performance. The JVM can manage all aspects of the application to database connection. This can facilitate debugging. And regarding disadvantages, we must admit that drivers are database specific, as different database vendors use widely different and usually proprietary network protocols. But I believe this is not critical disadvantage considering all advantages. Also, nowadays all major databases have their own implementation of JDBC, and the only thing that you need to do is to add JDBC driver into the class path of your Java app. So now you know different types of JDBC driver. Probably you already understood that we are going to learn how to work with JDBC Type 4. Let's recap one more time how it works. We are going to have program code. This can be any program code that performs operations with persistent storage. In my course Java from Zero to the First Job, we create online shop. And imagine that during the user registration, we run some code that should store user. Before learning databases, we stored users in file. Now that code will interact with JDBC API using standard interfaces. JDBC API will use implementation of the API, namely JDBC driver for specific database management system. And that driver will set commands to the database management system to execute SQL queries. Here on the slide you can see how it works. Let's now have a live demo and I will show you how to add JDBC driver to your app and establish connection with the database. In this lesson, we are going to do everything from configuration side to be sure that our development environment is all set for the following lessons. The first thing that we have to do is to get JDBC driver that we need. How to understand what driver we need and where to download it? Very easily. Just open your browser and make a Google search. You have to type Maven repo first. This is a repository that stores a lot of artifacts, libraries for Java development. After that, put the name of your database management system and write JDBC. Google search will show you a page that should lead you to Maven repository. In our case, we have MySQL installed. That's why I select MySQL connector. Depending on the version of database management system that you installed on your computer, you have to select driver of the same version. It will be enough to know at least major version. In our case, we installed MySQL of version 8. That's why I select here the latest version available. And here we can download jar. Download it on your PC. Once you downloaded jar, we have to add it into the class path of your project in IDE. In our case, we are going to use Eclipse. Let me quickly show you how to add external jar to a class path in Eclipse. Mouse right-click on your project, after that select Build Path, and after that click on Configure Build Path. Select Libraries tab, click on Class Path, and after that click on Add External Jar. After we can click Apply and Close. Great! Now we have MySQL JDBC driver in our class path. And we are ready to proceed with writing the code to establish connection with our database. All examples related to JDBC will be stored in the separate package that is called JDBC. You can find the reference to the code examples that I am going to show you in this lesson in attachments to the lesson. And now we are going to review JDBC connection example file. In this file we have main method and we can run it. Let me go line by line to explain you what we have here. If you would try to find tutorial in the internet about establishing connection with the database, most likely you will find a lot of tutorials where the first step is uploading driver class into a class path. In modern environment and in our environment setup, this is not needed, since all JDBC drivers that are found in the class path are automatically loaded. But just in case, I'll leave commented lines of code that demonstrates you how to upload a class into the JVM. Why this is needed? I mean to load driver class. When you load JDBC driver class like this, or it is loaded into JVM automatically, according to Java rules, static initialization block is executed. So, let's open driver class source code and investigate what is there in the static initialization block. MySQL connector has open source code available on the GitHub. And here's how driver class looks like. You can find static initialization block here, where driver manager is used to register instance of the current driver. That's why it is enough this class just to be loaded into the JVM to perform all necessary configurations. But as I said, in our case, Java will identify driver in the class path automatically and will load driver class. Driver manager is one out of many classes from Java SQL package that we will use. Basically, in JDK, all classes related to SQL are grouped into Java SQL package. Driver manager is a class that is responsible for managing JDBC drivers. Also, we will use this class to create object of connection type that will be used to execute SQL statements. Once we are sure that driver is uploaded into the JVM, we need to establish connection. Similar to other resources, we need to make sure that all opened resources are properly closed after they were used. That's why we use try with resources block. If you're not familiar with this block, we reviewed it in details in my complete Java course in the input-output stream topic. In short, resources declared in try with resources block will be automatically closed after the block will be completely executed. Java guarantees this and responsible for proper closure of the resources. You can put in this block only types that implements auto-closable interface. We use driver manager to get connection object. Get connection method is overloaded and we can use different versions of it. But the idea is the same. You have to pass host of your SQL server where a database is located and credentials. You can see that overloaded methods may take either string and properties in this case will contain information about user and password. Or you can pass one concatenated string with all required information or 3 separate strings. In our case, we pass 3 strings. Let's look at what actually we pass here. We concatenate hostname and database name as a first method argument. After that, we pass user and password. Definitely, storing database credentials in the source code file is not the best practice. But for demo purposes and for first JDBC program, I believe it is okay. Later, when we will keep implementing our online store, I will show you where to put credentials. Database name is the one that we created together in the lesson about database. If you remember, we created with you database for our online store project. Here just use its name of that schema. User and password is pretty clear and simple. But let's look at the host name and understand how it looks like. It contains a prefix and actually the URL to the host where our SQL server is running. In our case, this is localhost and default port. But how to identify which prefix to use, because it will be different for connection with different database management systems. This URL establishes a database connection with the JavaDB embedded driver. The JavaDB also includes a network client driver, which uses a different URL. Typically, in the database URL, you use JDBC word, and database management system name. For example, to create URL to establish connection with Derby database, you would write JDBC Derby here. For PostgreSQL, you would use PostgreSQL word here. And we establishing connection to MySQL database management system. That's why I have MySQL here. Do you understand? Anyway, you can always check this kind of detail in the documentation or by simply searching through the internet. The main pattern that should be followed here I described. After we called getConnection method, the connection variable should be initialized. If for some reason it is null, that means connection wasn't obtained. If it is not null, then let's congratulate ourselves. We successfully established connection. Let's run our application. And we can see that connection established successfully. GetConnection may throw SQL exception. It may be thrown if a database access error occurs or the URL is null. Also, child exception may be thrown. That is SQL timeout exception. It may be thrown when the driver has determined that the timeout value specified by the setLoginTimeout method has been exceeded and has at least tried to cancel the current database connection attempt. That's why I handle potential SQL exception here. That's it. And you can see that connection is successfully established. Congrats! That's all what I planned to cover in this lesson. Let's recap what we have learned today. In this lesson we hold JDBC overview and learned what JDBC is. We learned different JDBC driver types. I explained you what ODBC is. After this lesson, I believe you have understanding how JDBC works. And in real-life example, I showed you how to add JDBC driver into your Java project and establish connection from your Java program with the database. Now we are ready for the next lessons. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we keep learning JDBC, and today we will learn how to execute SQL statements from our application. and how we can parse result set from the database to process this data further inside our program. We'll start from learning of what statement is. I will show you main methods that will help you to execute SQL queries against the database. These methods are execute, execute query, and execute update. We are going to review different examples with these methods. Also, I am going to show you how to read results returned from the DB with the help of result set. And in order you could read data from result set in the proper format, we are going to learn mapping between SQL data types and Java data types. After that, I will explain you what SQL injections are and how we can avoid them with the help of the prepared statement. And at the end of the lesson, we'll learn how to invoke storage procedures and what callable statement is. Today we are going to have practical lesson with a lot of examples. So, let me start with screen sharing and from code examples. And the first thing that I'd like to start with is executing statements against database from our Java program. In the previous lesson, we learned how to establish connection to a database via JDBC driver. Make sure you watched previous lesson because this is important. And before we learn statement class and how to work with it, we need to do small refactoring in our code to make sure we are efficient during the following examples. You saw in previous lesson how to get connection object, and taking into account we would need connection object a lot of times, basically in each our example. That's why it is a good idea to avoid repeatable code and move it into one class. Here I have a class that is called dbUtils. It is a static method getConnection that creates object of connection type and returns the reference to the object. Having this class and this method would save my time by not writing all this code all the times, including exception handling. Does it make sense? And now let's learn how to work with statement class. Let me open another example. File is called JDBC statement select example. We have main method here that will allow us to start the program. So let's start from review of this method. I create connection object. After that, I create statement object based on my connection object. I just call create statement method without any parameters. Statement object is used for executing a static SQL statement and returning the results it produces. In previous lesson, we learned that we should close connection object. The same thing we have to do with statement object. It is a good practice to close statements too. Statement type extends auto-closable interface. That's why we can also put it in the try with resources block. And here is where knowledge of SQL will come in handy. Because you need to have SQL knowledge to create SQL statements that will be used in statement object. Let's create simplest select statement that returns us all users from user table. If you missed lessons about database, or you just forgot how our tables look like, I will quickly remind you. We created a database where we also created tables that will represent our business entities in our applications that we develop in our online store. And one of such tables is user table that contains information about our users. And here's how it looks like. Let's fetch information from this table. The simplest query to fetch all data is select all from user. Let's get back to our Java application now. Now, important thing to talk about. Statement object has three main methods to work with. All of them execute SQL statement against database. They are execute, execute query, and execute update. Let's find out what is the difference between these methods. All these methods take string method argument. That is SQL query that we are going to execute. The main difference is in returned values. For example, execute method returns Boolean value. True is returned if returned type is result set object. And false is returned when returned value is an update count or there are no results. Do you remember that when we executed SQL statements in MySQL Workbench, for example, and we executed update query or insert query, we saw in logs number of rows impacted with query. And in case we'll receive number, execute method will return false. But when we execute select statement in database, we receive table with values. This is called result set. And in case result set is returned, we receive true in this method. Technically speaking, you can execute all kinds of queries via execute method. But execution of select statements totally makes no sense with execute method. Do you understand why? And also, it is not a lot of sense in execution of queries if you want to see count of rows impacted with SQL query. Probably the only case when you might want to use execute method is case when you execute dynamically unknown SQL statement. If we want to get result set object in response, we need to use execute query method. Execute query method returns result set. As you already understand, object of result set will allow you to read all rows that was returned by database line by line. And execute update method returns int value. Do you already understand what is this int value? That is row count that was impacted by SQL statement. Basically, we can receive the same number here in Java program. For example, insert, update, or delete statements returns the number of rows impacted with the query execution. So, this method is not suitable for select statements, because again, when we execute select statement, we count on receiving some data in response. That's why, theoretically, it makes sense to execute insert, update, or delete queries with execute update method. So, do you understand now the difference between these three methods? And what method do we need to use in our select statement example? You are right. We need to use execute query method. Let's get back to our demo file. Now, let's talk a little bit more about result set. Result set is a table of data representing a database result set. This object maintains a cursor pointing to its current row of data. Initially, the cursor is positioned before the first row. The next method moves the cursor to the next row. Next method returns false when there are no more rows in the result set object. That's why this method can be used in while loop to iterate over all rows in result set. By default, only one result set object per statement object can be opened at the same time. Therefore, if the reading of one result set object is interleaved with the reading of another, each must have been generated by different statement objects. All execution methods in the statement interface implicitly close a current result set object of the statement if an open one exists. But nevertheless, closing of result set is considered to be a good practice. That's why I put result set in try with resources block here. And when we have result set, we can iterate over each row going one by one. I create while loop here and call next method to move pointer to the next row and to make sure that the next row exists in result set. After that, I can extract values from the result set row with get methods. Interesting thing that you can extract value that is already in Java data type. There is a mapping between SQL data types and Java data types. Let's review it. On this slide, you can see mapping between data types that are familiar to you from database management system and from Java. For example, if field in database is of varchar data type, that means that you can put it in string data type. If value is of tinyInt data type, that is equivalent of integer in Java. Does it make sense? And result set has methods that allow you to extract value of specific data type. Let's get back to our demo. And knowing the data type that you want to extract, you have to call proper method. Pay attention that all methods are overloaded. They can take either int argument or string argument. Int value will indicate index of a column. Considering that order of columns may be changed and new columns may be added, this is not something we can always rely on. That's why it is recommended to extract value from column by column name. And you can see that I pass column name to extract the values that I need. Pay attention that this is exactly naming of a column like it is named in the database. I extract ID, first name, last name, and email for each user. Let's run this program and see what we have in console. And as you can see, we printed information about each user. Do you understand how we can execute select statements? Nothing super complex, agreed? Now, let me show you update example. This example has a lot in common with the previous one. Let's focus on the things that are different. We have different SQL statement here. This time we are going to update amount of money for user with ID 17. And instead of execute query, I call execute update method. And after that, I print to console amount of rows that were impacted with update query. I believe you already understood how these things work. All examples from this lesson will be in attachments to the lesson. So feel free to investigate those by yourself. You can find those examples with delete and insert statements. I believe that we are more or less clear on how statements work. Let's learn prepared statements now. But before we learn prepared statements, let me show you one of the problems that we are going to solve with the help of prepared statements. One of the malicious attacks in web applications are SQL injections. SQL injection is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. It generally allows an attacker to view data that they are not normally able to retrieve. This might include data belonging to other users, or any other data that the application itself is able to access. In many cases, an attacker can modify or delete this data, causing persistent changes to the application's content or behavior. For example, attacker may query passwords of users, or get other sensitive data. There are a wide variety of SQL injection vulnerabilities, attacks, and techniques, which arise in different situations. Some common SQL injection examples include retrieving hidden data, where you can modify a SQL query to return additional results. Subverting application logic, where you can change a query to interfere with the application's logic. Union attacks, where you can retrieve data from different database tables. Examining the database, where you can extract information about the version and structure of the database. Blind SQL injection, where the results of a query you control are not returned in the application's responses. Let's imagine now that we have online shop, and we pass category name as URL parameter like it is shown on the slide. And imagine that category parameter is used in our statement in Java code. Namely, we take value of category parameter and use it to concatenate our SQL statement. This request triggers query where I extract all products from category computers, for example, and with status active. Probably you think, what might be wrong here? But what would happen if I would add double hyphens in URL? This means that these double hyphens will be added to the SQL statement. Double hyphens means comments in SQL syntax, and everything what will go after them will be treated as a comments. Thus, you will extract all products in active and in inactive status. Do you understand this now? Or imagine that you pass category parameter with union keyword. And in union statement, you can pass another SQL statement to query other tables. Thus, attacker may extract information that he or she were not supposed to have access to. Can you imagine now what potential impact may be? That's why securing your app from SQL injections is so important. And let's learn now how we can secure ourselves from SQL injections. Now you know what SQL injections is. Let's find out what we can do with that. One of the ways to avoid SQL injections is to use prepared statement. Because prepared statement defines a SQL query template and lets client only define parameters values. We prepare a statement, and after that we only need to populate parameters in it. That's it. By using parametric queries and prepared statement, you prevent many forms of SQL injection because all the parameters passed as part of the placeholders will be escaped automatically by JDBC driver. But this is not the only advantage of prepared statement. Also, prepared statements have better performance. SQL queries passed to the prepared statement method go to database for precompilation if JDBC driver supports it. If it doesn't, then precompilation occurs when you execute prepared queries. Prepared statement queries are precompiled on the database, and their access plan will be reused to execute further queries, which allow them to execute much faster than normal queries generated by statement object. You should always try to use prepared statement in the production JDBC code to reduce the load on the database. In order to get a performance benefit, it is worth nothing to use only a parameterized version of SQL query and not with string concatenation. And the last but not the least advantage of prepared statement is obvious. It allows you to create parameterized SQL queries and send different parameters by using the same SQL queries. You can use question mark in the query as a placeholder that will be substituted by any other value. Enough theory about prepared statement. Let's look at examples. I put all examples related to prepared statements in a separate package that is called prepared statements. Basically, all queries here performs the same operation as an example with statement, but with only one difference.
I use prepared statement type instead of statement.
Let's review insert example. You can see that I have the same SQL statement as in previous example, but instead of values, I put question marks here. After that, I call prepare statement method to get the reference to the prepared statement object. And after that, I can initialize each of these parameters with values. I can set values of different types. You can use auto-suggestion feature in your IDE to learn more info about available methods, but all of them have intuitive naming. If you need to set string, just call setString method. If you need to set integer, then you need to invoke setInt method, and so on. Pay attention that index number 1 means the first position of question mark. So, we start not from 0, but from 1. Is it clear? And here I set values for each parameter. And after that I call executeUpdate method without any arguments. And the query is executed. Basically, that's how prepared statements work. Nothing complex, agreed? I believe we are done with prepared statement. And one more thing that I'd like to show you today. It is scalable statement. The interface used to execute SQL stored procedures. We learned with you in details what stored procedures are in our SQL section of the course. That's why usually I studied JDBC only after students learned databases. Because without knowing databases, it is hard to understand such terms as stored procedures, for example. Let me just quickly remind you what stored procedures are. Stored procedures are a group of statements that we compile in the database for some task. Stored procedures are beneficial when we are dealing with multiple tables with complex scenario, and rather than sending multiple queries to the database, we can send required data to the stored procedure and have the logic executed in the database server itself. So, to make sure you understand everything what I say, check lessons about databases. In that course, we created stored procedures. Let's now invoke one of them. As usual, we create connection. After that, I invoke prepare call method. I pass SQL statement that should invoke my stored procedure. Instead of the argument, I pass placeholder. And after that, similar to the prepared statement, I initialize the argument with the value in specific position. If you remember stored procedures, there might be different argument types: in, out, and in-out. In case you want to declare that one of the parameters is out parameter, you have to register it first, like here in the commanded line. Argument index and argument type. Pay attention that you should specify SQL type here. In my case, I have only one argument and it is not out type argument. That's why I keep this line commanded. And after that, everything goes as usual. We can call execute query method that returns us results set. After that, we work with it as in previous examples. In this particular case, my stored procedure returned me user by email. And in case you have out parameter and you wanna read it, you can read it from callable statement object after you executed a query, like in this example. You read the Java type that you need using get methods. Basically, that's it. That's all what I wanted to learn with you in this lesson. Let's recap what we have learned today. Today we learned a lot of things and we had a lot of demo. Now you know what statement is and how to work with it. You saw how to work with result set object. We learned mapping between SQL data types and Java data types in order we could read data from result set properly. Now you know what SQL injections are and how to avoid them with the help of prepared statement. And at the end of the lesson we learned with you callable statement. That's all what I wanted to share with you in this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, I'm happy you're watching this lesson because today we are going to have not very long but super important lesson for advanced usage of JDBC. Today we are going to talk about transactions and batch updates to the database. We'll start from understanding of what transactions are. We'll learn theory and such basic requirements to transactions as asset. After understanding the theory on real example, we'll create Java program that uses transactions. I will show you how we can commit our transactions, roll back transaction in case of error, or roll it back only to the required save point. Also in this lesson I am going to show you how we can make batch updates to the database to increase performance of our app. In the end of the lesson we will talk about how to explore database metadata programmatically. Let's start our lesson. And the first thing that we are going to do in our lesson, let's define what transaction is. In programming, we refer to a transaction as a group of related actions that need to be performed as a single action. In other words, a transaction is a logical unit of work whose effect is visible outside the transaction either in its entirety or not at all. We require this to ensure data integrity in our applications. To understand it better, imagine simple examples that you went through multiple times, I hope. This is checkout in online store. You are on the checkout page, and you are redirected to the payment gateway. There are a few actions that needed to be done. Let me even simplify things, and let's imagine that we have just 3 steps. Reducing money amount on your credit card, increasing money amount in the account of online store, creation request for product delivery. an exception might happen on each of these steps. For example, you don't have enough money on your credit card, or there is an exception in receiving money on the site of online store. Probably they forgot to update account with relevant bank details. Or, while transaction has been happening, your product has been purchased by somebody else and request for delivery can't be created. This is just an example, because there might be different cases. And to avoid cases with missing product for delivery, you can reserve the product for 15 minutes before checkout process is started. But this thing implemented in different ways in different cases. The only thing that I want you to pay attention to is that you may have multiple related steps, where we value only successful completion of all steps. And in case at least one of the steps is not completed, we have to restore state of the system as it was before transaction started. Basically, return money to your credit card, or reducing money from online store, or reject request for product delivery. Do you understand now what transaction is and how it helps us to solve our business cases? Great! The next thing that we are going to learn is a set of properties of a transaction intended to guarantee data validity despite errors, power failures, and other mishaps. This set of principles is called ACID. This is an acronym that stands for atomicity, consistency, independence, durability. These four properties are the major guarantees of the transaction paradigm, which has influenced many aspects of development in database systems. And now we are going to learn each of these principles. Let's start from the first one, atomicity. What does atomicity mean? Transactions are often composed of multiple statements. Atomicity ensures that all changes we make to the data as part of a transaction, we make them as a single entity and operation. This effectively means that either we perform all the changes or none of them. An atomic system must guarantee atomicity in each and every situation, including power failures, errors, and crashes. A guarantee of atomicity prevents updates to the database occurring only partially, which can cause greater problems than rejecting the whole series outright. As a consequence, the transaction cannot be observed to be in progress by another database client. At one moment in time, it has not yet happened, and at the next, it has already occurred in a whole, or nothing happened if the transaction was cancelled in progress. An example of an atomic transaction is monetary transfer from bank account A to account B. It consists of two operations, withdrawing the money from account A and saving it to the account B. Performing these operations in an atomic transaction ensures that the database remains in a consistent state. That is, money is neither debited nor credited if either of those two operations fail. The next transaction property is consistency. Consistency ensures that we execute all the data changes while maintaining a consistent state at the start and the end of a transaction. Any data written to the database must be valid according to all defined rules, including constraints, cascades, triggers, and any combination thereof. This prevents database corruption by an illegal transaction, but doesn't guarantee that a transaction is correct. Referential integrity guarantees the primary key-foreign key relationship. A consistent state of data must conform to all the constraints that we define for data. Let's now talk about isolation property. Transactions are often executed concurrently. Multiple transactions reading and writing to a table at the same time. Isolation ensures that concurrent execution of transactions leaves the database in the same state that would have been obtained if the transactions were executed sequentially. Isolation ensures that we keep the intermediate states of a transaction invisible to other transactions. This gives concurrently running transactions an effect of being serialized. The degree to which a transaction must be isolated from other transaction is defined by isolation levels. And the last but not the least property is durability. Durability guarantees that once a transaction has been committed, it will remain committed even in the case of a system failure, for example, in cases of power outage or crash. And remember, these are 4 main properties of transactions. Without these properties, it is hard to name as a transaction just sequence of work items. Hope that this is clear. Like I said, there are also very important properties of transaction like isolation levels and propagation. Definitely, we can learn them now, but usually for my students it is hard to understand this topic without examples. That's why I recommend to postpone learning such things as isolation levels and propagation property when we will come to learning of Java Persistence API, GPA. Because in that case I will be able to show you demo right after explaining theory via Transaction Manager. But in this lesson we can focus on the transactions itself and its ACID properties. Okay, let's move on. Now we learn enough theory to proceed with examples. Let me show you how we can manage transactions via JDBC. Transaction example is located in JDBC transaction example file. All examples you will be able to find in attachments to the video. Let's go line by line and see how it works. In this example, we are going to make a money transfer from one user to another. Here in top we have 2 prepared SQL statements. The first one is to update money amount for specific user ID, and another one to select user by its ID. After that, we configure money amount that we want to transfer, user from ID, and transfer to ID. Now we are ready to make a money transfer. We get connection object, we prepare our statements for select and for update. After that, I declare a reference to the save point in order it will be accessible in catch block. Save point is an object that contains the state of the transaction. This point within the current transaction can be referenced from the rollback method of connection object. This is exactly the method that will help us to restore the state of the transaction. In a minute you are going to see how we can use that method. When a transaction is rolled back to a save point, all changes made after that save point are undone. Save points can be either named or unnamed. Basically, during the creation of the save point we can pass string name here and create named save point. After that, I create try catch block to handle all potential exceptions and roll back transaction in case of exception. I need this in order my catch block would be within the try with resources block, in order I could still have a reference to the connection object to roll back transaction in catch block. And now I start my transaction. In JDBC, to take control over transaction we have to set auto commit to false. If a connection is in auto commit mode, then all its SQL statements will be executed and committed as individual transactions. Otherwise, its SQL statements are grouped into transactions that are terminated by a call to either the method commit or the method rollback. By default, new connections are in auto commit mode. But with this set method we can turn it off. The first thing that I do is reading data about user from to make sure that user have enough money for money transferring. In case user doesn't have enough money, we just quit the method and not proceeding with the next steps. In case user have enough money for the transaction, we deduct money amount and update user in the database with reduced money amount. Theoretically, after some steps in transaction, you can make a save point. For example, you have some logical steps combined together that makes sense to apply, or to roll back to that state and try the following steps one more time. In this case, you just need to invoke save point method. You can pass string here to create named save point. In our particular case, we have only 2 steps and logically it makes no sense to save the state only after reducing money amount for the first user. After that, I select another user to add money amount to his money value. and update another user in the database. Once I updated users, I call commit method. And now imagine, SQL queries start being executed. And we already updated the first user, but all of a sudden the light went out, and your database appeared to be without power at all. And even more, the light went out and your server with your Java app without power too. You didn't have time to update the second user. What to do now? Java tracks the transaction, and apparently it detects that some exceptional case happened. In this case, we will enter catch block. And in catch block, I call rollback method on my connection object. This method ensures that state that was before the transaction started will be restored in the database. That's what we need in our case. In some cases, you may roll back to the save point. This is not our case in this particular example, but I will keep this line commented just for a reference. Basically, that's all regarding this example. This is how easily we can manage transactions with the help of JDBC. Another thing that I'd like to show you today is batch updates to the database. A JDBC batch update is a batch of updates grouped together and sent to the database in one batch, rather than sending the updates one by one. Sending a batch of updates to the database in one go is faster than sending them one by one, waiting for each one to finish. There is less network traffic involved in sending one batch of updates, only one round trip, and the database might be able to execute some of the updates in parallel. The speed up compared to executing the updates one by one can be quite big. You can put in batch SQL insert, update, and delete statements. It doesn't make sense to batch select statements. Let me show you how you can execute batch updates to the database with the JDBC. All examples from the lesson you can find in attachments to the video. Just a reminder. Examples with batch updates are located in JDBC batch example. Everything is simple here. I create connection object, prepare a statement. We are going to do 3 insertions in one batch. In case you want all insertions would be executed in one transaction, you have to set autocommit to false. But this is optionally. It is important to keep in mind that each update added to a statement or prepared statement is executed separately by the database. That means that some of them may succeed before one of them fails. All the statements that have succeeded are now applied to the database, but the rest of the updates may not be. This can result in an inconsistent data in the database. That's why I recommend to use transactions during the batch updates. After that, you will fill out prepared statements with required values for all placeholders. And once you're done with each query, just invoke add batch method. And the same way I do with 3 groups of parameters. When I added all I wanted to the batch, I need to call execute batch method on my prepared statement object. And all batch will be executed and sent to the database. Is it clear? Anyway, in case you will have any questions, do not hesitate to ask me below this video. And the last but not the least thing for today that I'd like to discuss with you is how to explore database metadata programmatically. Metadata means data about data. For example, you might need to explore what tables you have in this database. Or you might want to investigate what columns this or another table has. This will help you to build dynamic queries. By saying dynamic queries, I mean you will be able to investigate the structure of the database on the fly during the program execution. Depending on the business logic of your app, this might come in handy sometimes. And definitely, you have to know about such possibility in Java. The main interface that provides variety of methods to obtain information about the database is called database metadata. Let me open its source code. You can explore multiple methods, and also you can see that there are really a lot of them here. We are not going to learn and review each of these methods, but definitely the amount of methods listed here is more than enough for building a tool or even an application for interactive database interaction, because you have opportunity to explore a lot of information about database. Let's open our demo file that is called database metadata example, where I prepared for you all examples related to interaction with the database metadata. And the first thing that I do here is getting the reference to the database metadata object using the reference to the connection object. Now, let's extract information about all tables. I call getTables method of my metadata object. There are different parameters here that I don't populate. What are they? The first two parameters are catalog and schema pattern. The third parameter takes a table name pattern. For example, if I write prod with %sign, similar to the syntax that we used in like operator, this will include all the tables whose name starts with prod. The last parameter takes a string array containing the types of tables. Use table for user-defined tables. To learn all table types, use method getTableTypes. After invocation of getTables method, we will receive result set with table info in it. We will iterate over result set to get table names and print it to console. You can retrieve it by table name column name. But let's imagine that you don't know how columns are called. Could it be so? Yes, absolutely. And what to do? You can get metadata of your result set. Let me show you how you can easily iterate over all columns and learn all column names, but on the example of table types. Because we also passed here table. But how did you know? Let's get result set by calling getTableTypes, and after that call getMetadata method on the result set object. Now you will get result set metadata. Having this result set metadata, I can learn how many columns we have. And after that, I can iterate over each row to get value from each column by iterating over each column in the result set. And here you can see in console that we printed all values from the result set without knowing column names and amount of values at all. Can you see how cool it is to dynamically investigate the database? You can explore even more by navigating through the source code of result set metadata and database metadata. Take my code examples, play with this code, and I hope you will be able to learn more about metadata in practice. That's it for today. Let's recap what we have learned today in this lesson. We learned what transactions are. Also, now you know the properties of transactions. We learned what ACID properties are. After that, in real examples, we learned how to manage transactions with JDBC. You saw examples of commit, save point, and rollback commands. We reviewed how to execute batch updates to the database. And at the end of the lesson, we learned how to work with database metadata and result set metadata. That's it for today. Thanks a lot for your attention. Have a great day and see you in the next lesson.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.